first basic measurement, that is nothing but horizontal distance. And we need to start our second basic measurement, that is horizontal angle. Okay. Last Sunday we couldn't take our session. That is around 6 hours of class. On last Saturday, 6 hours of class means 1 week. Okay. So had we had that last week, then this chapter would have been over by now. But unfortunately, due to some technical issues, we were unable to take the last Sunday's class. So one Sunday gone means 1 week class gone. Okay. Anyway, let us try and catch up some time here. So we're going to start our new chapter here. That is nothing but angular measurements and compass survey. Okay. So what is the second basic measurement that we have? The second basic measurement we have in our surveying is nothing but horizontal angles. The first parameter is nothing but horizontal distance. The second parameter is nothing but the horizontal angles. The question is, how do you measure horizontal angles? Alright. So horizontal angles are measured by using an instrument known as compass. So therefore, we call the survey as compass survey. Therefore, we will call the survey as what? Compass survey. Right. Now, let us understand why we need to measure the horizontal angle. Why we have to measure the horizontal angle, and how is this particular compass survey conducted. So that is the discussion that we should have. So you imagine, okay, just imagine that you're having a field that looks like this. Okay. So this is the ground that you're having, an area where we are supposed to do survey. What is the first job that we need to do here? First job that we need to do is we need to do our site visit. We need to do our site visit, that is reconnaissance. And during the reconnaissance, we can identify what is the nature of the field. Now imagine in this particular area, the surveyor has identified that a river is flowing like this, right? And here he has identified a certain forested area. Here also there is a large forested area. Let us also see that around this area there are some large buildings here like this. So this is my first building here. Another building is present here in this particular format like this. Okay. So there is a building here like this. And let us assume that this is a residential area with so many residential properties like this. Okay. Waterfront properties are there like this. This is the area. So in this particular area, how can I take my chain? How will I take my chain? Can I take the chain to the center of the area like this? No. It's a joke because you cannot pass that particular chain through the water body like this. Okay. Can I take it like this? No. Again, almost all the obstacles in chain surveying are present. Building is there, water body is there, and if I can take it like this, again, water is there, forest is there. So almost all the, obstacles of surveying are present here. All the obstacles of surveying are present here. So in this particular area, it is not suitable to conduct our, chain surveying. So during the reconnaissance itself, the surveyor should identify that chain surveying is ruled out. Okay, right. So the surveyor, what he'll do, he will do the regular procedure of, establishing the main survey stations around the area. So he will establish, the main survey station around the area like this, A, B, C, D, E. Whatever points are there, he will establish them. But rather than running a chain here, what he'll do is, he'll establish the direction of a reference meridian here. With respect to that, he'll measure the length of the line, and he'll measure something known as a forebearing of the line AB as theta 1. Forebearing of line AB as theta 1. Next, he'll shift the instrument to B and measure something known as the back bearing of the line, that is theta 1 dash. The back bearing of the line, that is theta 1 dash. He'll again measure the forebearing of the line BC, okay, and like this, that is theta 2. Measure the length, shift the instrument to C, measure the back bearing of this line as theta 2 dash. Okay, the process is repeated. I'll go from C to D like this, okay, then from D to E like this, and again come back to D to E to A like this. Okay, so we are getting a figure like this. What do you call this particular figure as? Can anybody please tell me what will you call this particular figure as? Come on. What will you call this particular figure as? See, it's not pentagon, Divyansh. It is known as a traverse. Yes, very good. Very good, very good. This is what we call it as a traverse. So we are getting, yes, a pentagon, but in chain surveying, what do you call this particular pentagonal figure as? We will call this particular pentagonal figure as a traverse. Okay. So basically, a compass surveying is conducted to run a traverse. The principle of chain surveying is chain triangulation. Likewise, I can say the principle of compass surveying would be nothing but traverse. Okay. So this is the basic area. Right. So you see, it's a branch of surveying that deals with angular measurements. Okay. Compass survey is conducted to obtain a traverse around the area to be surveyed. So how can I define this traverse? If you look at this, a traverse consists of some lines A, B, B, C, C, D, etc., etc. Right. So these lines are all connected to each other. Okay. Yes. So it is basically an interconnected network of straight lines. And do I know the length and the angles of the lines? Yes. So I know the length of all the lines as L1, L2, L3, and I also know the angles between the lines. For example, so this angle is theta 1 dash here, this angle is theta 2. If I take the difference, will I get this angle here? Yes. If I take the difference between these two, I can get the angle here. So this angle is what we call it as the included angle between the two lines A, B, and B, C. I can call it as theta. Okay. So a traverse is nothing but an interconnected network of straight lines which are related to each other by known angles. Okay. interconnected network of straight lines of known length which are related to each other by known angle. Based on this, there was a previous year ESE question. Was a previous year ESE question. Okay, yes. So that is it. That's angular measurements and compass surveying definition. The question is why we need to connect a traverse, because a traverse provides us with something known as horizontal control. What does a traverse provide you with? A traverse provide you with something known as the horizontal control. So what do you mean by this horizontal control? See, if I'm able to fix a point in the horizontal plane, if I'm able to fix a point in the horizontal plane, then I can say that I have achieved horizontal control. If I can fix a point in the horizontal plane, then I can say that I have achieved horizontal control. Now, to fix a point in the horizontal plane, how many measurements are required? To fix a point in the horizontal plane, you need two measurements: distance as well as angle. For example, please look at the door in your house. You are sitting in a room. Look at the door in the room where the door is. Okay, for example, I'm having a door here. So to find the position of that particular door here, if I only take my horizontal distance, will that be sufficient? The answer is no. Okay. For example, let me say that the door is 2 meters away from me. The door is 2 meters away from me. So if this is my position, if I only measure 2 meters, I can get infinite points around. There are infinite points that is satisfying that particular horizontal distance condition. So it is not enough to find the position of that particular door here. So now what I'll do is I'll take a reference value like this. Listen carefully, okay? I'll take a reference direction like this. With respect to the reference direction, I'll measure the angle at which I'll see the door. Let me say that angle is 60 degrees. So now let us see whether I can prove that or not. So this is my location here. Now where do I see this particular door? At a horizontal angle of how much? 60. So I can measure the horizontal angle of 60 degree here. Right? And now I can measure a distance of 2 meters here. I'll get the position of the door. Okay. So this is how it works. Right? That is how it works. Okay. So that is the meaning of horizontal control. So if I want to fix a point in the horizontal plane, I need to measure the distances as well as angle. Okay. And a compass traverse provides us with input. Right? Yes. So how can I define my horizontal control? Location of all points lying in the horizontal surface is known. Horizontal control is achieved. So if I can fix the position of all points in my horizontal plane, I can achieve the horizontal control. That's it. Now let us move on to the different types of traverses. So what are the different types of traverses? Basically, we have the closed and we have the open traverse. The basic two types of traverses that we have is our closed traverse and open traverse. So let us understand when we call a traverse as an open and when we call it as a closed traverse. For instance, look at this figure here. Let me call it as A. Please tell me what kind of traverse is this? A, B, C, D, E. What kind of traverse is this? Is this an open or is this a closed traverse? This is nothing but a closed traverse. This should not be needed. This should be supposed to be a closed traverse. Now the question is why? Why is this a closed traverse? Because I am starting from a point A and I am coming back to that same point A. I'm starting from a point A and I'm coming back to the same point. So if the starting and end stations are the same, I can call that particular traverse as a closed traverse. I can call that traverse as a closed traverse. What if the starting and ending are not the same? Okay. So for example, this is A. Right. What kind of traverse is this? Definitely this is an open traverse. Why? Because the starting point and ending point are not the same. So the traverse does not come back to its starting position. Therefore, it is an open traverse. Now, can I ask you a small question? What kind of traverse is this? So this is A, B, C, D, and E. Please tell me the last one. What kind of traverse is the last one? What kind of traverse is the last one? Okay. Everyone is saying that it is an open traverse, but I will say this can be a closed traverse. Right. But I will say this particular traverse can be a closed traverse. How? Provided point A and point E are well-defined points. Okay. Provided that my point A and point E are well-defined point, this can be a closed traverse. This can be a closed traverse, right? Because why? What is the meaning of well-defined points? When I'm saying that A and E are well-defined points, what is the meaning of that? It means that you already have the position of A and E on your paper. Similarly, you know the positions of A and E on the ground, right? So the positions of A and E are known on the paper as well as known on the ground. That particular traverse is what we call it as a closed. That particular traverse can become a closed traverse, or we can call that point as a well-defined point. So please try and answer. If A and E are two well-defined points, do I know the length of the line A in between them? Yes or no? Do I know the length of the line A in between them? Yes or no? The answer is yes. So I know the length of the line A in between them. So now tell me, what does this traverse become? This has become a closed traverse. Such a closed traverse is what we can refer to as a linked traverse. Such a traverse is what we can call it as a linked traverse. Understand? Yes. So I'm starting from A, B, C, going back to a point E. Now, right, if the starting and ending points are well-defined point, the last line length can also be calculated. That can also always be calculated, can be measured in the paper. Okay, so then it becomes a closed traverse. Now, such a traverse is what we call it as a linked traverse. Okay, yes. Now, let me ask you another interesting question here. Out of these two, there is the open traverse and closed traverse. Which one do you prefer to have? Out of this open and closed traverse, which one do you prefer to have in the field? Do you prefer to have a closed traverse or do you prefer to have an open traverse? Everybody saying the answer is closed only. Right, the answer is you cannot say. The answer is you cannot say, or you should not say, because right, you cannot be partial towards closed traverse. There's no partiality. Whether you go with a closed traverse or whether you go with an open traverse will be ultimately decided by what? Decided by the field condition. Yeah, it is based on the field condition, not on the what is your requirement. For example, I am giving you a 100-kilometer long road. I am asking you to survey a 100-kilometer long road. So to survey that, will you go with a closed traverse or will you go with an open traverse? 100-kilometer long survey line. Will you measure with open or will you measure with closed traverse? Definitely you will go with the open traverse, because 100-kilometer long road like this. So this is a 100-kilometer long road, right? So if you are planning to go with closed traverse here, you need to go 100 meters from one end to the other end, and to close the traverse, you need to come back. That is total waste of time. So for narrow strips of lands like canal, railway line, road, etc., right? We will definitely go with open traverse. But if I'm asking you to find the boundary of a building, what will you do? So you imagine that this is your home. I'm asking you to fix the boundary of your home. You can go with which one? You can go with the closed traverse. So whenever the extent of area is less, whenever the area to be covered is less, I can go with the closed traverse. In the case of very narrow strip of lands, we can always go with what? Always go with the open traverse. But can you please tell me, what is the psychological reason behind the selecting that open traverse? What is the reason that you have actually selected the open traverse there? What is the reason for that? For what reason you have selected that I will go with an closed traverse? What is the reason for that? See, the psychological reason about why you think that you will go with the closed traverse is because of the fact that you can apply checks. Okay, you can apply checks in the case of our closed traverse. Okay, since the traverse is coming back to the starting station, always we can apply checks. Okay, just imagine this. Okay, so imagine your college days. Okay, some of you are still in college, so it will be very much relatable to you. Imagine you are starting from your house. You are going to college, right? College starts at 9 or 10 o'clock. You wake up exactly at 9 o'clock. Okay, by 9:30 you are ready. Super fast, you are ready. Okay, by 9:30 mother has prepared lunch. Mummy has prepared lunch. You take the lunch box, dabba. We call it as dabba. Okay, right? Dabba only. Yes, not dabba. Dabba you take. You put it inside your bag. Then what you do? You take that particular bag, the lunch box. You go out of the house. Right? You catch a bus. Let us call it as an RTC bus. Right? That RTC bus will go here and there, and it'll exactly drop you at the college at 10 o'clock. So you're at the college at 10 o'clock. 10 to 4, you are supposed to be in the college. 4 o'clock the college is over. By 4 o'clock you catch another bus. The bus will go here and there. Finally at 5 o'clock you are back at home. By 5 o'clock you are back at home. So do you know what our mother will be doing at 5 o'clock? She'll be out of the house. She'll be eagerly waiting for your return. Correct now? But she'll be eagerly waiting for your return. So she'll be outside your house and she will check whether you are coming back to the home or not at 5 o'clock. So whenever you come back to the home at 5 o'clock, what have you become? What have you become? You have become a closed traverse. Correct now? You started from your home, even here and there, and finally you come back to your home. So by the time you come back to your home, mother will be applying checks at 5 o'clock, whether you are home or not. So if you are home at 5 o'clock, mother is checked and the check has satisfied and mother is full happy. Right? So you are at closed traverse. Imagine, like suppose after 4 o'clock, you did not go to your home. Where do you go? You went to your mama's house. You went to your uncle's house. So mother will, as usual, does not know this, will come out and by 5 o'clock mother will apply check. Is the check satisfied? No. You're not, back to the house at 5 o'clock. The check has, become unsatisfied or the check has gone wrong. So mother will get full tension. What mother will do? Mother will take mother will take her phone and mother will, call you and ask, where are you? Mother is very angry. Okay, you say, mother, I am at Chacha's house or I am at Mama's house. Now, what mother will say? Mother will be full happy. Why? Mother will be completely happy. Why? Because the Chacha's house is a well-defined point. Correct? Mother knows where the Chacha's house is. Right? So now mother is again full happy. No problem. Mother will go and tell father that, father, right, my son is at Chacha's house. Okay, father, my son is at Chacha's house. But do you think the father will believe you? No. Father is very intelligent. Father will not believe you. Unless father will apply his check, he will not believe you. So father will apply his own check. Will father call you? No. Don't you? Father is intelligent. Father will not call you. Father will call Chacha and ask Chacha, my son is there or not. If Chacha says yes, then only the check is satisfied. So again, you are a closed traverse. Why are you closed traverse? See, you did not come back to the starting point. No, you did not come back to the starting point, your home. But you went to another point which was already well defined. Okay. So what is the advantage? You will become a closed traverse. I will be able to apply check. So such a traverse is what we call it as a linked traverse. Right? A type of closed traverse. It does not come back to the starting point, but it is going to some other point which is already well defined. So we can apply check. Okay. So that is a linked traverse. So now you are a linked traverse. Suppose now after 4 o'clock, you did not go to your house. You did not go to your Chacha's house. You went to Rohit's house. Now who is Rohit? Nobody knows. Who is Rohit? Nobody knows. So by around 5 o'clock, mother comes outside to apply the check. Check is not satisfied. Mother will call you, right, and ask you, where are you? You say, Arey mother, I am at Rohit house. Mother will get extreme amount of tension. Why? Because mother cannot check what you are doing at Rohit house. Rohit house is an undefined point. Nobody knows where is Rohit house is. So mother cannot check what you are doing at Rohit house. So after some time, right, you're supposed to reach your home at 5 o'clock. But since you went to Rohit house, you will be coming out, or coming back to your house at 10 o'clock. You may come in 2 legs or you may come in 4 legs. Whatever happens, okay, mother will wait with the chadu. Mother will wait with the broomstick. Okay, because mother cannot check what you did at Rohit house, because Rohit house is an undefined point. No checks can be applied. So what are you right now? You are an open traverse. Okay, so open traverse cannot be checked. Basically, that is the basic problem. So arithmetic checks are not there for my open traverse, but it is there for the closed traverse. Okay, that's it. That is the basic idea between the traverse. So you know this in your back of your mind that closed traverses checks are possible. That is the reason why you will say the answer as closed traverse. Anyway, let us move on. So what are the points that we discussed? Let us see. So it is either closing upon itself, closed traverse, or upon any other point which is well defined. Open traverse neither closed upon itself or any other point that is well defined. Whereas closed traverse suitable for small section of area. Example would be area of a pond, building, etc. Boundary conditions of these points we can establish. Next, it is suitable only for narrow strips of lands. Example, transportation lines, roads, rails, etc. Followed by canals, etc. Right. Now please note down this. Arithmetic checks can be applied for closed traverses. That is the advantage. So let us look at the arithmetic check by canals, etc. Right. Now please note down this. arithmetic checks can be applied for closed traverses. That is the advantage. So let us look at the arithmetic check available for closed traverses. So what I'll do is I'll give you a closed traverse here. I'll give you a closed traverse here. Remember, I know all the length of the line A, B, C, D, E, A, as well as, right, I know the bearings of all the lines. I told you some theta 1 dash, theta 2 dash, etc. I'll measure. And I have calculated all these angles inside the traverse. I calculated all the angles inside the traverse. What do you call these angles inside the traverse? It is known as an, interior angle. The angles inside a closed traverse is what we call it as an interior angle. So I measure all the interior angles. Now, if I take the sum of this particular interior angles, there is a mathematical formula that should be satisfied. So you imagine that you're having n number of traverses. You're having n number of sides in your traverse, n number of sides in your closed traverse, right? Then the sum of the interior angle, inside angles, 2n minus 4 into 90 degree. But if you're taking the exterior angles, you're measuring this exterior angles like this, then the sum of exterior angles will be what? 2n plus 4 into 90 degree. Please remember, this check is very important for us. To see whether your answer is correct or not, these checks are very, very important. If you're writing mains examination, there will be separate weightage given to arithmetic checks applied. There will be certain weightages given to the arithmetic checks applied. Please make sure that you remember your checks available for the questions. Okay. Yes. That's it. That's the arithmetic check. Okay. So that's it. That's the discussion regarding the open and closed traverse. So that's the basic introduction of our compass rule. Now we'll move on to the next discussion. That is meridian. Okay. So what is a meridian? As you can read here, a meridian is nothing but a reference direction with respect to which angles are measured. I measure my horizontal angles with respect to this meridian. So just to remember the example of the door, what I told you, I'm having my door here. To find the position of this door, what did I do? I took a reference direction like this, and with respect to that reference direction, I have measured the horizontal angle. So any reference direction in the field with respect to which I am measuring the horizontal angle, that is what we call it as a meridian. Okay, that is what we call it as a meridian. We have different types of meridians, starting with first one, right? Starting with the most important meridian, that is known as the true meridian. So how can we identify a true meridian? You see, you can identify a true meridian like this. You can define it like this. You imagine that this is our Earth's surface, and this is the geographic north and south of the Earth. This is geographic north, and this is geographic south. So what do you mean by geographic north and south? It means the rotation of the Earth is happening about this particular axis. Okay, that is the mean. So that is geographic north and geographic south. Let us consider a point here, say P. So I'm considering a point P here like this. What is the direction of true meridian passing through the point P? If you want to imagine the direction of true meridian, what you need to do is, you need to imagine a circle, a very large circle, a very big circle. We call it as a great circle. And you need to imagine this great circle passing through the geographic north, passing through the geographic south, and through the point P under consideration. Okay, so if you can imagine a circle like this, okay, it passes through the geographic north, the geographic south, and through the point P under consideration. This resulting great circle will give me a direction like this. So what is this known as? This is what we call it as the direction of true meridian at the point P. That direction will show the direction of true meridian at the point P. Let us start to analyze this direction. So tell me, do you think the geographic north and geographic south of the Earth will always change? Absolutely not. Okay. The geographic north and south of the Earth will never change actually. It almost remains 100% constant. So geographic north and geographic south is constant. But what about the point P on the surface of the Earth? Is the point P on the surface of the Earth constant? Will anybody take the point P away? No. You imagine P is for Pune city. Can anybody take away that particular Pune city, yes or no? No. So the point P is constant, the geographic north is constant, the geographic south is also constant. Then what we can understand, the direction of true meridian is always a constant. The direction of true meridian is always a constant. Please remember, it will never change. Similarly, what if I take another point here, say Q? What will be the great circle passing through the point Q? Through the point Q? It should pass through the geographic north, geographic south, and through the point Q like this. Okay. So this will be the direction of true meridian passing through the point Q. Yes or no? Yes. Please try to answer my question. How does these two true meridians looking like? Please again. How does these two true meridians look like? Do they look, parallel to each other, or do they converge to the center of the Earth? Sorry, converge at the poles. Are they parallel or are they converging to the poles? Please tell me the answer. Yes, they are converging to the poles. Okay, so please remember, true meridians are always fixed; they will never change the direction. As well as the direction of true meridian will always, converge at the poles. Let us look at those points here. So, what is a true meridian? See, the directions represented by a big circle, great circle, that is passing through geographic north, geographic south of here. Geographic north and geographic south of here. The directions of true meridians are always fixed. Directions of true meridians are always fixed. Next, true meridians are converging at the poles. Okay, true meridians are converging at the poles. Now, how do you find the direction of the true meridian? There are different ways. One way is, you see, above the geographic north of the earth, there is a star in the sky. This star is known as the North Star. Okay, so with respect to the geographic north, vertically above the geographic north of the earth, we have a star known as the North Star. So at a night sky, if you are able to find the position of this North Star, it can help me find the direction of true meridian. Right. So what am I saying is, to get the direction of true meridian, you need to take an astronomical observation. Astronomical observation means an observation towards a star. It's a heavenly body. It's a celestial body, so we call it as a astronomical observation. Okay, now? Yes. Please remember that they are established with respect to taking astronomical observation. That's it. So that is our true meridian, one of the most important meridian in this chapter. The second meridian is what we call it as a magnetic meridian. Second one is a magnetic meridian. You see, I can define the magnetic meridian in the exact same way as the true meridian. In whatever manner I have explained the true meridian, in the exact same method I can define my true meridian also. So magnetic meridian also. So what I need to do is very simple. Instead of taking the geographic north and geographic south of the earth, instead of taking the geographic north and geographic south of the earth, what I can do is I can simply take the magnetic north and magnetic south. I can take what? The magnetic north and magnetic south of the earth. So if I take the magnetic north and south, right, what will be the definition? A great circle passing through the magnetic north, magnetic south, and through the point P under consideration. Okay, that is how we can define the magnetic meridian. But there is a far better way of identifying the magnetic meridian. There is a very easy way of doing this. That is how by taking a magnetic compass. So you imagine that this is a magnetic compass that we have, and you imagine in this magnetic compass, this is the direction of the needle. This is the direction of the needle. That arrowhead represents the magnetic north direction. Arrowhead represents the magnetic north direction. So this is where the magnetic north is. This is where the magnetic south is. So what is this direction here? This direction is what we call it as the magnetic meridian. So the easiest way of identifying the magnetic meridian at a point, say A, is by the direction shown by the magnetic needle. So you see the direction shown by a freely suspended magnetic needle at a place. That is what we call it as a magnetic meridian. Now imagine that I bring a metallic object very close to the needle. So this is a metallic object I am bringing, okay, or this is a a magnetic material I am bringing, or it's simply a magnet I am bringing closer to my point A. So due to the presence of this particular magnet, will the needle inside the compass deflect? Yes. Either the needle will be attracted to it or it will be deflected to it. Whatever happens, the direction shown by the magnetic needle will change. Okay. So tell me, is the directions of magnetic meridian constant? No. Unfortunately, no. Okay. So this also point you remember. Magnetic meridians are not constant because it will change based upon the magnetic fields that are present around it. So you need to be careful there. That's it. Okay. So that is the magnetic meridian. As I told you all throughout this chapter, the two most important meridians are magnetic and true meridian. Understand? Okay. The two most important meridian for us is nothing but the magnetic meridian and the true meridian. But just for the sake of discussion, you need to know what is meant by the grid. Okay. The two most important meridian for us is nothing but the magnetic meridian and the true meridian. But just for the sake of discussion, you need to know what is meant by the grid meridian. You need to know what is meant by the grid meridian. You imagine that this is a very large country. Okay, you imagine this is a very large country, and we need to do survey on this country here. So you imagine this is a very large country like this. Also, I'll give you one more information. This is the direction of true meridian. This is the direction of true meridian passing through the center of the country. So this is a very large country. This represents the direction of true meridian passing through the central region of the country. You imagine there's a state like this. There's a state inside the country, and I want to do surveying in this state. Truly speaking, how should be the meridian at the state? Right, this is where the geographic north of the earth is. So how will be that true meridian passing through my state? This is how the true meridian passing through the state is looking like. Are the two true meridians parallel to each other? No. The two true meridians, in the country and in the state, they are not parallel to each other. So this can result into confusions. This can create confusions for us. So to avoid this from happening, what we do is I will not take the direction of the true meridian for the state. So to avoid confusions, we will not survey the state with respect to the true meridian of the state. But what we do is we'll take this central true meridian as reference. Parallel to this, we will assume one more meridian like this. Parallel to this, we'll assume one more meridian. This becomes the reference meridian for us. Right? This becomes the new reference meridian for the state. Okay. So what is my grid meridian? See, this central region, the true meridian of the central region. This is a reference for the survey of the entire country. So this reference meridian, central reference meridian, is what we call it as grid meridian. So please write this. For the survey of a state in a country, the directions of true meridian passing through the center is taken as reference, not with respect to the state. So this reference meridians are known as grid meridian. Okay. For India, this grid meridian is 82 degrees 30 minutes east of our Greenwich village, Greenwich meridian, 82 degrees 30 minutes east. It passes through a small village known as Mirzapur. Okay. The same Amazon Prime Video Mirzapur is there, the same thing. Right. Into the same village, our reference grid meridian passes through. It is a small state in Prayagraj. Right. So Prayagraj is nothing but what? Allahabad. It is renamed now. So please remember. The grid meridian for India is 82 degrees 30 minutes east, and it passes through Mirzapur, Allahabad. That's it. Okay. So that is your grid meridian. Now the last meridian that we have is arbitrary meridian. Last one is what we call it as an arbitrary meridian. So what is this arbitrary meridian? So let us try and understand. How did I fix the position of this particular door? How did I fix the position of that particular door? I fixed the position of the door with respect to the true meridian. With respect to a meridian taken like this. I told you that is my door. I'll take a reference meridian like this. From this meridian, the door is 60 degree angle. What is this meridian I take? Is this true meridian? No. Is it my magnetic meridian? No. Randomly I have taken this. So any randomly taken fixed positions of the field is what we call it as arbitrary meridian. Okay. Any random fixed directions in the field with respect to which I'll take measurement is known as arbitrary meridian. Okay. So you see, any randomly taken fixed direction of reference for the ease of working. That is what we call it as the arbitrary meridian. Okay. Yes. So these are the four different meridians that we have. Okay, what are they? Of reference meridian, magnetic meridian, grid meridian, and arbitrary meridian. Now please remember, all throughout our survey we just want the true meridian and magnetic meridian only. Okay, yes. So once you understand the meridian, we should start our discussion on bearings. Okay, so let us see what bearing is. Just give me 1 minute, I'll come back. Just give me a minute, I'll just come back. Okay. Talk about bearing. So what do you mean by bearing of a line? See, bearing of a line is nothing but the horizontal angle the line makes with the reference meridian. What is bearing? Nothing but the horizontal angle line makes with the reference meridian. So when I talk about the example of our, when I talk about the example of our, door here, what was the bearing? I took a reference meridian like this. With respect to this reference meridian, I got an angle of 60 degrees. Right. So you see, right. So this was my meridian. Okay. This was my meridian. With respect to that meridian, I have taken a line from my position to the door, and I've told you that this particular angle is 60 degrees. So this 60 degree is what we call it as bearing. Okay. From this particular point onwards, we will start, we'll stop calling it as a horizontal angle. We will start calling it as the bearing of a line. So what is a bearing? Horizontal angle between a line and the reference meridian is known as bearing. The horizontal angle between a line and the reference meridian is known as bearing of a line. Known as bearing of a line. Right. Next, we have different types of meridians. Therefore, we'll have different types. And the reference meridian. The first type of bearing that we have is true bearing. What is a true bearing? See, it's very easy to understand. So you imagine that this is the direction of true meridian at a point. This is the direction of true meridian at a point, say A. And this is a line AB. This is a line AB that we are having. So what do you call this horizontal angle between the true meridian and the line AB? You call it as the true bearing of line. Okay, that's it, as simple as that. Horizontal angle between true meridian and the line under consideration. That is what we call it as true bearing. Now, is the true meridian at point A constant? Yes. True meridian at point A is constant. We discussed about this. You think about this. A is Ahmedabad and B is, let us say, Bombay. So if I'm joining Ahmedabad and Bombay via straight line, will that line remains the same every time? Yes, obviously. The line will remain the same because nobody is going to take Ahmedabad away, nobody is going to take Bombay away. So that particular points A and B are the same. So the line AB remains the same. So AB remains the same, true meridian remains the same. Then what happens to the true bearing? It is always constant. For a given line, true bearing is always constant. Okay, true bearing is also always a constant. And this is also known as the azimuth of a line. This is also known as azimuth. True bearing is also known as azimuth. Okay, that is another name. True bearing is also known as azimuth. Okay, right. So that is our first bearing. That is nothing but the true bearing. Now we move on to the next bearing that we have. We call it as the magnetic bearing. We call it as the magnetic bearing. What do you mean by magnetic bearing? Very simple. Horizontal angle the line will make with a magnetic meridian at a point. As simple as that. So you imagine that this is my magnetic meridian. So a compass is showing me a direction like this. So this is my point C. This is the direction of the needle shown by the compass at C. I will call that direction as magnetic meridian. And if this is my line CD, what is the horizontal angle here? This horizontal angle is what we call it as magnetic bearing of line. Okay, this horizontal angle is magnetic bearing of line. So tell me, is the magnetic meridian at a point constant? The answer is no. We discussed now, due to some magnetic field, the magnetic meridian may change the direction. Yes. So the direction of magnetic meridian at the point C is not constant. But what about the line CD? That remains constant, no doubt. CD line will always remains the same, no doubt about that. So CD is constant, but the meridian is not constant. So what can you tell me about the horizontal angle or the magnetic bearing? Will that change? Yes, absolutely yes. So the magnetic bearing is not constant. Horizontal angle between the magnetic meridian and the line under consideration. That is known as the magnetic bearing. Now remember, it is not constant for a given line. It does not remain constant for a given line. It keeps on changing. Yes. So the two important meridians for us are true meridian and magnetic meridian. The two important bearings for us are magnetic bearing and true bearing. Okay. Yeah. Okay, so these are the two meridians that we have, magnetic and a true meridian. And associated with the magnetic and true meridian, we have the magnetic bearing and we have the true bearing. Okay, now? Yes. Now, apart from this, there are two more meridians we discussed. What are they? They are the grid meridian and arbitrary meridian. With respect to them, we'll have angles also. I just mentioned them, not important for us. So grid bearing, what is it? Horizontal angle line means with the grid meridian, not important. Arbitrary bearing is that. What is that? That is again horizontal angle line means with the arbitrary meridian point. Not very important. Throughout the entire survey, we need the true meridian and the magnetic meridian only. Yes. So that's it. So that is the discussion regarding the different bearings. Now we'll talk about the systems of angular measurements. So we are discussing about horizontal angles here. What we are going to discuss now is what are the different ways in which horizontal angles measured in the survey all throughout the world. Okay. So there are actually three different systems. Starting with first one, what we call it as the sexagesimal system. So what happens in the sexagesimal system is, if you take one entire circumference like this, you take an entire circumference of a circle, that entire circumference is divided into how much? 360 degrees. The circumference of a circle is divided into 360 degrees. Okay, and each degree is further divided into what? Is divided into minutes. Each minute is further divided into seconds. So you see, a circumference is divided into 360 degrees. Each degree is equal to 60 minutes. Each minute is equal to 60 seconds. And then what will be the value of each second? What will be the value of each second? There will be no value because second is the basic unit. there will be no value because second is going to be the basic unit. Okay, so please remember that. So this is what we call it as a sexagesimal system. This is what we use in countries like India, US and all. Right. Now in the European country, a new system known as centesimal system is gaining popularity. So in this particular system, centesimal system, one circumference is divided into 400 grads. Okay. We divide it into 360 degrees. They divide into 400 grads or grades or gons. All of them are same. So you see, one circumference is divided into 400 grads, gons or grades. In our total station manual, if you go and read it, you will see that angular measurements are taken in degree, minutes, seconds as well as in gons, which means it can measure in both sexagesimal system as well as in our centesimal system. That is the understanding. Okay, that's it. Next step. We'll see what is the value of 1 grad. 1 grad is 100 centigrade and 1 centigrade is equal to 100 centicentigrades. 1 centigrade is equal to 100 centicentigrade. So these are the different ways in which the centesimal system works, and this is gaining popularity in the European countries. Right? It's popular in European countries. That's it. Okay. So that is hexadecimal and the centesimal system. The third system is what we call it as our system. This is used in our astronomical observation. So in 24 hours, what happens? Please tell me. 24 hours in watch is equivalent to what? Is equivalent to you see 360 degree of earth rotation. That's it. 24 hours in our watch is equal to 360 degree of earth rotation. Every 1 hour in your watch is equal to 50 degree of earth rotation. Then in every 1 minute, earth will rotate by 15 minutes, and in every 1 second, earth will rotate by an arc of 15 seconds. So this is used in our astronomy. This is used in our astronomical observation. In engineering services, we have this topic, time conversion, calculation of time, which we'll discuss in our separate class for years. Yes. Okay, so these are the different systems that we have. India we use which system? In India we use the hexadecimal system. Okay, right. So that is the systems of measurement. Okay. Now let us move on to the representation or designation of bearings. So designation of bearings means what are the different ways in which a horizontal angle can be represented in the field? What are the different ways in which a horizontal angle can be represented in our books or in our paper? The first method is what we call it as whole circle bearings (WCB), or also known as the azimuthal bearing system. So the azimuthal bearing of a line means what? Azimuthal bearing of a line is nothing but a whole circle bearing of a line. So based on this, there was a GATE PYQ very recently. Right, there was a GATE PYQ very recently. You should go take up your material and check whether you can solve it. Okay, 100% sure you'll be able to solve it. Okay, right. So let us start with the first bearing system here. That is whole circle bearings. See, the definition of whole circle bearing is very simple. In fact, this is the easiest bearing to measure. So what you do is you start measuring from the north end of the reference meridian to get your horizontal angle. You start measuring from the north end of your reference meridian in which direction? Clockwise direction. That's it. So it is the angle measured from the north end of the reference meridian in clockwise direction. And please remember, it will always remains the it is always measured in the clockwise direction. So let us imagine that. So this is my meridian directions. Okay, this is going to be my meridian directions here. Okay, so this point I call it as O. This point I call it as O. Right, now this is my north, this is my south, this is my east, this is my west. Imagine that you are having a line OA. What is the whole circle bearing of the line OA? It is the horizontal angle measured from north end of the reference meridian clockwise direction. You start from the north, you go in clockwise direction. So what is that? That is your whole circle bearing of the line, that is OA. Next step, right? Line here, OB. Again, what should I do? Start measuring from the north end of the reference meridian clockwise direction. What is this angle? Theta 2 degree. My next line is OC, like this. It is measured from where? It is measured from the north end of the reference meridian in the clockwise direction. That is theta 3 degree. Okay. And what is the last line here? That is OD. That means measured from the north end of the reference meridian in clockwise direction. What is that? That is theta 4 degree. So this is how our whole circle bearing of the lines will be measured. It is always measured from the north end of the reference meridian in which direction? Clockwise direction. It is always measured in the north end of the reference meridian in which direction? Clockwise direction. Okay. Right. So you see the statement here. right? Rather, before the statements, let me ask you, in this particular system, what is the range of values I can have? What is the range of values I can have here? Anybody? Right, very good, very good, very good. Absolutely correct. They have given me the value as 0 to 360 degree. So please remember, okay, the range of values I can have in the system is varying from 0 to 360 degree. Now, where is 0 degree? 0 degree is marked at the north end, 0 degree is marked at the north end, 90 degree at the east end, 180 degree at the south end, and 270 degree at the west end. This is how it is measured. Now, 0 to 90 degree is the first quadrant, 90 to 180 is the second quadrant, 180 to 270 is third quadrant, and 270 to 0 is the fourth quadrant. That is the quadrants 1, 2, 3, 4. Please remember that. Okay, yes. So that is our pole circle bearings, or also known as azimuthal bearings. Let us write about them. So the horizontal angle measured from the north end of the reference meridian in the clockwise direction. From the north end of the reference meridian in clockwise direction, ranges vary from 0 to 360 degree. That's it. So this is our first designation, first representation known as pole circle bearings. From the north end of the reference meridian in clockwise direction, ranges vary from 0 to 360 degree. That's it. So this is our first designation, first representation known as pole circle bearings. The second representation is known as reduced bearings, or also known as quadrantal bearing system. So here the discussion is completely different from our last case. Discussion is completely different from our last case. Yeah. In the 1 second. So in the whole circle bearing system, what did we do? We started measuring it from the north end of the reference bearing. That's it. And in which direction? Clockwise. But here it may be the reduced bearing of a line may be measured either from north or from the south. It is not necessary to be from north. It can be measured from either north or south. In which direction? Either in the clockwise direction or in the anti-clockwise direction. So you can measure it in any method depending upon where the line is. It can be either in the clockwise direction or it can be in the anti-clockwise direction. So you please look at this. Right. So let us call this as north, south, east, west. This is my first line here, OA. So what is the reduced bearing of this line OA? So first and foremost, let me say it should be the acute angle the line makes with the reference meridian. Obviously, it will be the acute angle the line makes with the reference meridian. So acute means what? Less than 90. Reference meridian means what? North south. Acute means what? Less than 90. Reference meridian means what? North south. So what is the angle my line OA makes with the north south meridian? Like this. It is measured. I call this angle as theta 1. Okay. It is measured from north towards the line. So this is the direction of measurement. Is that clockwise or is that anti-clockwise? How is theta 1 measured? Is it clockwise direction or anti-clockwise? No doubt, that is a clockwise direction. That is a clockwise direction. Yes, very good. So how do I define this particular meridian? It is like this. It is measured from the north end of the reference meridian, theta 1 degrees towards which side? Towards east. Towards which side? That is towards the east. So measured from north, theta 1 degrees towards the east. Measured from north, theta 1 degrees towards the east. This is my next line here, OB. This is my next line here, OB. So again, who is your acute angle? Right, the line OB makes, it is with the south end of the reference meridian like this. Okay, so I'm measuring from south towards the line. So that is clearly an anti-clockwise measurement. If this is theta 2, how will I report the answer? My bearing is measured from south, theta 2 degree towards the which direction? Eastern direction. You see, towards this eastern direction. South, theta 2 degree east. North, theta 1 degree east. That's it. Okay. So this is my next line here also. This is my next line here also. Right. Okay. So where is the acute angle? What is the acute angle? It is the angle measured from south towards west like this. Right. South towards the west like this. What is this angle? This is theta 3. So I am measuring it from where? South. In which direction? You see, anti-clockwise direction or clockwise direction? Theta 3 is measured in the clockwise direction. So you should say, I measured it from south, and the angle is theta 3 degree. Towards which side? Towards the west side. So south theta 3 degree towards the west. The last line is nothing but OD. Who is the acute angle the line makes? This is the acute angle the line makes with the reference meridian. This is the acute angle line makes with the reference meridian. Right. What is this angle? I call it as theta 4. So what do you do? You measure from north. You measure it theta 4 degrees towards where? Towards west. Measure from north. Theta 4 degrees towards the west. That's it. Okay. So that is the definition. So the complete definition is this. It is the acute angle, less than 90 degree angle, measured from where? Measured from the north or south. In which direction? Either in the east or west direction. If you are measuring in this fashion, can anybody please tell me the range of values? Please tell me, what will be the range of values here? Yes, very good. The range of values here will be 0 to 90 degree. The ranges will be 0 to 90 degree. Okay. Okay, that's it. So let us write about it. Now, please, one more point that you remember is, where is this particular 0 degrees? Remember, the 0 degree is marked at the north and south region, and 90 degrees marked at the east and west regions. Please remember, 0 degree is marked at north and south, 90 degrees marked at the east and west, right? And we need to measure the acute angle, less than 90 degree angle, which will be in each quadrant, northeast quadrant, southeast quadrant, southwest quadrant, like that. So we call it as quadrantal bearing system. Okay, right? So look at the definitions. Acute angle line makes the reference meridian measured either from clockwise direction or measured either from south or north, in clockwise or in anti-clockwise direction. That's it. The range of values you can get here is from 0 to 90. Now we'll do a small, practice here, small exercise here. Exercise goes something like this. I will tell you what my reduced bearing is. You need to tell me where I'm looking at. I'll tell you what my reduced bearing is. You need to tell me where I'm looking at. Okay, so, right, so. Okay, so that is my point O, right? I will say this is north. Yes. So you imagine I am standing at this point O here. Imagine I am standing at this point O here. Let me say that my reduced bearing is north 0 degree. So tell me, if my reduced bearing is not 0 degree or 0 degree north, tell me where I am looking at. Tell me where I am looking at. I'm looking at north, na? Yes. Okay, so yeah, you say it as, where am I looking at? Tell me what's your answer. Yes, very good. I'm looking towards the north. Right. Tell me, am I looking exactly towards the north, or am I looking east and west of north? I'm looking exactly towards north, or to left side or right side of north. There's no confusion. I'm looking exactly towards north. This is what we call it as due north. This is what we call it as due north. Okay. So whenever we are looking exactly towards the north direction, we call that particular reference as due north. We call that particular condition as due north. Now, listen. My reduced bearing is, see, my reduced bearing is, you see, north 90 degrees east. Tell me, where am I looking? Very good. Tell me, east, correct? Yes. Am I looking exactly at east? Yes. Shilpa, very good. You're looking exactly at east. So what will you call it as? You need to call it as due east. You're looking exactly towards east means you should call it as due east. Similarly, what about this? South 90 degrees east. Where am I looking? South 90 degrees means what? Is it the same or different? Yes, very good. Very good. These are nothing but the same. Everybody give me the correct answer. It is nothing but due east. Now tell me, what will be south 0 degrees? What will be south 0 degrees? Yes, you are getting the idea. We will call it as due south. This was a previous ISRO question. ISRO, they have asked this question. And tell me, for due west, what should be the condition? Tell me the condition for due west. Come on. What will be the condition for due west? Yes. North 0 degree west and south 0 degree west. Very good. North 0 degree, right, west, sorry. Not 0 degree, correct? North 90 degree west or south 90 degree west. Both of them will show that the line is due west. Okay, na? Yes. That's it. So this is how you will, report the values. Okay, so this is something else that you need to remember, because sometimes in your examinations they will say like this: a line AB was due west. Due west means what? It is going exactly towards west. Okay, that's it. So you should know that terminology. So next, what we need to do is we need to discuss about conversion. If you look at this, you see the reduced bearing systems are practically not in use anymore. Reduced bearing system is not really practically in use anymore. So what we need to discuss is how to convert the reduced bearings to whole circle bearings and vice versa. Sometimes it will be easier to work with whole circle bearings, but in some discussions that we'll see later on, we need to write every line with respect to the reduced bearings rule. So it is very important that if they give you a reduced bearings, can you convert into whole circle bearings? If they give you a whole circle bearing, can you convert back into a reduced bearings? Okay, so that is one point that we need to discuss. So that is conversion between bearings. So there is no other way of studying this rather than only by solving some problems. Let us take some problems and try and solve it. I'll give you some random values of whole circle bearings and reduced bearings. You please try and tell me what is the converted bearings. Okay. So let us begin. Okay, so I'll give you some values. You can. First one is my whole circle bearing is say something like 200 degrees. What should be the reduced bearing for it? Okay, so you convert them. Okay, now how do you convert them? How will you convert them? See, I want you to draw some figures and convert them. Alright, there are some of you which can convert just by looking at the value. That's very good. But what I want you to do is, I want you to convert them by using some figures. Look at the first data. First data is whole circle bearing of 200 degrees. So please listen here. What you do is, right, first and foremost, you see how that 200 degree will be. 200 degree means line lies here. This is 0, this is 90, this is 180, and this is 270. Correct? Yes. So this is where the line is. Right. We need not write at 90 and all. Just for the sake of discussion, I wrote like this. So this is where my line 200 degrees, and this is what is given to you. This data is given to us 200 degrees. What are we supposed to find out? We are supposed to find out this reduced bearing. This is the acute angle. Okay, so what is this? It is measured in this fashion. This is south, this is west. The entire angle is 200. What will be this acute angle? 200 minus 180, it will be 20 degree. So your answer would be south 20 degree west. The answer would be south 20 degree west. That's it. Okay. So please proceed. Please proceed. The remaining problems also you solve. I'll just give you 5 minutes. Okay. My line 200 degrees, and this is what is given to you. This data is given to us 200 degrees. What are we supposed to find out? We are supposed to find out this reduced bearing. This is the acute angle. Okay, so what is this? It is measured in this fashion. This is south, this is west. The entire angle is 200. What will be this acute angle? 200 minus 180, it will be 20 degree. So your answer would be south 20 degree west. The answer would be south 20 degree west. That's it. Okay. So please proceed. Please proceed. The remaining problems also you solve. I'll just give you 5 minutes. Okay. Okay, so let me see what is the answers you got. Okay, whatever answers you got now, post all the answers together. Yes, very good. So I can see that you have given us the answers here. Very good, Sheetal, Divyansh. Let us convert. Okay, I'll also convert. You just tell me whether my solutions are correct or not. Okay, yes. So in the second example, what is the data given? example, the line is south 40 degree east. So line lies in which quadrant? South east quadrant. This is my line. This angle is what they are giving us as 40 degree. What is the whole circle bearing of the line? Measured from north in Parker charge. What will be this? 180 minus 40. Your answer should be 140 degree. So the whole circle bearing of the line should be what? 140 degree. Look at the third example. It is 340 degree. So line lies in which quadrant? Whole circle bearing. So this is where the line lies. This entire angle is what they are saying it as 340 degree. And what is the acute angle? This is the acute angle. This will be 20 degree. Yes, we know from calculations it will be 20 degree. So what is this? That is in north. What is this? West. So what is my answer? North 40 degree. West. North 20 degree west. Yes. Now let's look at the fourth example here. So fourth example very simple. North 40 degrees east. North. So what is the whole circle bearing? Whole circle bearing is nothing but 40 degrees. Fifth example is 250 degrees. Same thing, huh? So this is 250 degree. What is this? This is 180 minus 250 is what? 70 degree. Yes. Sixth one is south 60 degree. South 60 degree means this is where the line is. Okay, right. How is my line? My line is like this. So this is south 0 degree. So what will be the whole circle bearing? Measured from north in Parker direction. Whole circle bearing will be 1 degree. Seventh one is 140 degree. Okay, so this whole circle bearing is 140 degree. What is the radius bearings? So the radius bearing. So south, this is east. So what is the answer? This will be 40 degree. My answer will be south 40 degree east. That's it. Okay, so this is how our answer will be like. I hope you got the same answer. Yes, everybody getting the same answer. Sixth one, Karthik. How it is south 50 east. But yes. Ethel also. What is that south? It is not 50 degree. Na? South is 0 degree. Okay, south is 0 degree. That is not 50 degree. South is 0 degree. Okay, I think some small confusion there. Yes. 2 is equal to 7. What is that? 2 is equal to 7. Yeah, second example and third example same. Second example and this one. Both are giving us the same value. Yes. Yes. That is correct. Yes. So I hope you got the answers there. This is how the conversion will take place. Yes. So that's now that we understand that particular conversion, we will move on to our next discussion. What is meant by the forebearing and backbearing of the lines? Very, very important discussion for us. What is meant by the forebearings and what is meant by the backbearing of the lines? Very, very important concept. If you don't understand this concept, we cannot move forward. We cannot move forward. Okay. So what is meant by the forebearings and backbearings of the lines? Right. See, forebearing of a line is nothing but the bearing of a line measured in the direction of travel. Forebearing of a line is nothing but the bearing of a line measured in the direction of travel. Let us try and take some examples here, right, and understand. More than writing the definitions and all, the important part is, do you know how to draw the forebearing, measure the forebearings and backbearings of lines? Okay, yes, that is the important part, and we will start the discussion with that point. So you see, this is my line here, AB. AB, okay, right. So when I say I'm having a line AB, what is the direction of travel? The line will be traveling from A to B like this. So this is the direction of travel. Line AB is traveling from A to B like this. So if I'm asking you, what is the forebearing of the line AB? What is the forebearing of the line AB? What is the meaning? The line is traveling from A to B. The forebearing of AB is measured from A. Remember, forebearing of AB is measured from A towards the point B. Right. So you need to measure the forebearing of the line AB from which point? From point A towards the point. From A towards the B like this. Okay. So I'm measuring it from A towards point B like this. Okay. That is what we call it as the forebearing of the line AB. I will call it as same theta. As per this figure, what is the forebearing of the line AB? Is nothing but equal to theta degree. Yes. Now tell me, if so, where will I measure the backbearing of AB from? If forebearing of AB is measured from A to B, you need to start measuring from A towards B. The backbearing of line AB is measured from where to where? From B to A. So please remember, forebearing of AB is measured from A to B. Forebearing of AB is measured from where to where? A to B. Right? A to B. Backbearing of AB is measured from B to A. Okay. Forebearing of XY measured from X to Y. Forebearing of XY measured from X to Y. Backbearing of XY measured from Y to X. Forebearing of CD measured from C to D. Backbearing of CD is measured from D to C. That's it. So from where will I measure this backbearing of AB from? I should measure it from B towards A. So from B point, I should measure it towards A. So from B point, I should measure it towards A like this. What What is this angle here? This angle is what we call it as the back bearing of the line AB. How do you measure the back bearing of AB? How do you measure the back bearing of AB? Please remember, to measure the back bearing, there is always one simple step that you need to remember. There's only one simple step that you need to remember. What is that? That is to extend the line forward like this. That is to extend the line forward like this. Okay, that's it. Now, if you extend like this, can you please look at the figure and tell me, if this angle is theta, what is going to be this angle here? This angle is also going to be what? Theta. So that is theta. Okay. So that entire angle is back bearing. This is equal to theta. What will be this much angle? That angle is nothing but 180. So theta plus 180 should give me the back bearing. So no, this theta angle plus this 180 degree should give me what? Should give me my entire angle of back bearing. So I can write like this. It should be this theta angle plus 180 degree. Remember, this theta is equal to this theta because the line is extended now. Yes. Okay. So, but what is theta? Theta is what we call it as the forebearing of the line. So we'll get the relation something like this. Back bearing of this line AB is nothing but equal to theta, forebearing of this line plus 180. So back bearing of AB is nothing but forebearing of the same line plus 180 degree. That's it. Okay. Now similarly, let us measure the let us do the same example with another line. So we are having another line here like this. So this is A, this is B. So tell me, from where I measure the forebearing of AB? Forebearing of AB will be measured from A to B like this. Forebearing of AB will be measured from A to B. Correct now? Yes. Forebearing of the line AB. See, the forebearing of the line AB is measured from where to where? A to B like this. So I measure like that. This is the angle I get. That is the forebearing of AB. Because when I am saying line AB travels from where to where? From A to B like this. Okay, completely different line. It is measuring from A to B. So this is my point A, right? So I need to start from A, then I need to go towards B. That is forebearing of AB. Now tell me, how will I find the back bearing of AB? How will I find the back bearing of AB? How will I measure the back? Bearing of AB. The back bearing of AB will be measured from B towards A. Back bearing of AB will be measured from where to where? From B towards A. So it will be measured from the point B towards the point A like this. Like, what is this angle? This angle is what we call it as the back bearing of the line. So how to measure that back bearing? What you need to do is just extend the line forward like this. Just extend the line forward like this. Right? Now tell me, if this is back bearing, what is this angle here? That angle is nothing but the forebearing of the line. Correct now? Yes. So this angle is also theta. From this entire theta angle, if I reduce 180, from this entire theta angle, if I reduce 180, will I get the back bearing? Yes. From that entire theta, if I reduce 180, I'll get this back bearing. Okay. So back bearing is measured from B to A. Back bearing is measured from B to A. So that entire theta minus 180 degree, I'm getting the back bearing. Okay. So what is the back bearing of the line? The back bearing of the line is equal to the forebearing of the same line. Forebearing of the same line plus or minus 180 degree. Right, that's it. Back bearing of the line is equal to forebearing of the line plus 180. Back bearing of the line is equal to, first case, forebearing plus 180. Now it is forebearing minus 180. So if I put both these particular points together, I can write like this. Back bearing of any line is equal to forebearing of the same line plus or minus 180. So now, first case I got plus 180. Second case I'm getting minus 180. Right. So why we are getting plus or minus 180? Let us have an understanding here. So tell me, in the first example, if I compare this theta value, that is the forebearing with 180 degree, who is greater here? The theta is greater or 180 is greater? 180 is greater. So the forebearing theta is less than 180. What is the sign I got? You see, the sign I got here is the plus sign. Let us do the same analysis. Compare the forebearing and 180 degree in the second case. Who is greater? Clearly theta or forebearing is greater. Right? Who is greater? The forebearing is greater. Yes. So what is the sign that you got here? The sign that you got is negative. Right. So if it is more than 180, right, you are getting negative sign. If it is less than 180, you are getting a positive sign. So, no. So here back bearing of a line is equal to forebearing of the same line plus or minus 180. Yeah. When will I use plus sign? I'll use plus sign when forebearing is less than 180 degree, and I'll use minus sign when forebearing is more than 180. When forebearing is more than 180. This is how it works. This is how it works. Okay. But please understand. Do you need to mug up a formula here? Forebearing, back bearing is equal to forebearing plus or minus 180. If this is like this, use that side. If it is like this, use that side. Do you need to mug up? The answer is absolutely not. There is no need for you to mug up. Right? There is no need for you to mug up. Karthik, please lower your hand. You can ask me questions later. Okay? There is no need for you to mug up the formula here. Right? Please understand. If I want to write forebearing minus 180, should this forebearing be more than 180 or less than 180? Should it be more than 180 or less than 180? Clearly, it should be less than 180. Sorry, more than 180. If you want to reduce 180 from a value, if you want to, reduce 180 from a value, that value should be more than 180 or less than 180. Basic common sense says that should be more than 180. That's it. So when I give you a forebearing that is more than 180, to get the back bearing, you reduce 180 from this. But if I give you a forebearing that is less than 180, something like say 60 degree, can you reduce 180? No, you cannot reduce. You add 180. That's it. That is the logic. So if you study now the equations with the logic there, you will never forget it, and you will never use up your memory, right? You will never use up your memory. Sometimes you may want to mug up something, right? At that time you need to have some space in your memory. So where logic does not work, sometimes now, right? Where you need to mug up, that time you need to use that space. For things like this, do not waste your memory. So that's it. The back bearing of a line is equal to forebearing of the same line plus or minus 180. That's it. This is the equation. Use plus sign for when the forebearing is less than 180. If you want to reduce 180, make sure that forebearing is more than 180. That's it. Okay. Yes. So please read the statement. The forebearing of a line is the bearing of a line measured in the direction of travel. Back bearing of a line is the bearing of a line measured in the direction opposite to travel. Back bearing is the bearing of the line measured in the direction opposite to travel. That's it. So that is forebearing. And back bearing of a line. Okay, now? Yes. So what we'll do is we'll do some small examples here. I'll give you some set of forebearings. You tell me what is the back bearings. You need to tell me the answer, right? In real time. I write the back bearing. I'll write the forebearing. Immediately you tell me the back bearing. Right. So let us see who are fast. Who will give me the answer first? So I'll give you a set of forebearings here. Okay, like you need to tell me the back bearing. Okay. So yes, let us begin. So the forebearing of a line is equal to 60 degree. Tell me the back bearing. Fast. Yes, very good. 60 degree plus 180. What is 60 plus 180? It is not 120. Right? 60 plus 180 is 120. No, right. In our mathematics, 60 plus 180 is what? It is nothing but 240 degrees. Yes or no? Yes. So the forebearing of the line is 60 degree. Back bearing of a line is equal to 240 degree. Next, forebearing of a line is, I'll give you easy value 100 degrees. Okay, forebearing of a line is equal to 100 degrees. What is the back bearing of the line? Very good, 280 degrees. Absolutely correct. Next, forebearing of a line is equal to say 179 degrees. What is the back bearing? No, Kundan. Yes. No, not 259. Yes, very good. 359 degrees. So no. Yes. Next, fourth one. Forebearing of a line is equal to 300 degrees. What is the back bearing? 300 plus or minus? Very good, minus. You are super fast. Very good. Right. 300 minus 180. You should get it as 120. Next, forebearing of a line is equal to, like say, 250 degree. 250 degree. What is the back bearing? 250 plus or minus? Minus. Very good. 250 minus 180 should be what? 70. Last one. Forebearing of a line is equal to 181 degree. What is the back bearing? Yes, very good. The answer is nothing but 1 degree. Right. So very good. So now I can very confidently say that you have become experts. Right. You have become bearings expert. Whatever bearing, whoever can give you now, you can immediately find the answer. Very good. Absolutely correct. Yes. So here, if you look at this, whatever examples that I have given now, whatever examples I have given, all of them are what? Whole circle bearings. Right? Everything is in whole circle bearings. But what if I try and give you a data in reduced bearings? So you look at this. If the forebearing of line AB is south 40 degree is, the back bearing of line is dash. The back bearing of the line is dash. You need to fill the answer. Right? So most of you will be thinking, see, please stop writing. Please listen to me. Okay? Most of you might be thinking, I don't want an answer. Okay, so stop writing and listen. Most of you will be thinking that, sir, I will first convert south 40 degree east into my whole circle bearings, and now I'll convert that whole circle bearings into forebearing into back bearing, and I'll put the answer. The problem is, you see, if I give you a bearing in reduced bearing system, forebearing in reduced bearing system, I expect the answer also in reduced bearing system. So let us see how we can find the answer as soon as possible. Okay, let us see how we can find this. We just need to draw some figures here. Right? Let me draw some figures. Okay. 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 So let us just draw a figure here. So this is my line here. So this is the point here. Now what is the bearing of the line they are saying? It is south 40 degree east. Okay, so this is where my point is. Okay, this is where my point is. Okay, yes. Now, what is the whole circle bearing of the line AB? If I want the forebearing of AB in whole circle bearings, what is the answer? This is the answer in whole circle bearings. Correct now. This is the forebearing of the line AB in whole circle bearings. But they are not giving that value. They are giving this reduced bearing as 40 degrees. Okay, this reduced bearing is what they are giving as 40 degrees. Now tell me, what is the back bearing of AB in whole circle bearings? So in whole circle bearings, the back bearing is measured from B towards A. I will measure from B towards A. What is this? This is the back bearing of the line AB, but in WCB system. If we convert this into reduced bearings now, what will be the equivalent reduced bearing? This angle will be the equivalent reduced bearing. Now please look at this figure and tell me, right, that if this angle is 40 degree here, what will be this angle? This is also 40 degree. Please tell me, if this is south here, what is this? This is north here. If this is east here, what is this here? This is the west here. So tell me, when the forebearing of the line is south 40 degree east, right? So when the forebearing of the line is south 40 degrees east, what is the back bearing of the line? The back bearing of the line is equal to north 40 degree west. Back bearing of the line is what? North 40 degree west. So tell me, to calculate the back bearing of a line or the opposite bearing in reduced bearing systems, what we need to do? Very simple job. You interchange north and south. You interchange east and west. And what do? You maintain the angle. You just maintain the angle. Right. So you imagine, write this next example and tell me the value. Okay. So if the forebearing of the line is equal to, say, south 40, or rather, let me go with so north 45 degrees west. Tell me the back bearing of the line. Very simple now. Yes. Back bearing will be north will change to south. 45 degree will remain the same. West will change to east. So south 45 degrees east. Now one last example. The forebearing of the line is equal to, say, south 38 degrees 18 minutes 14 seconds west. What is the back bearing? No need for even a single calculation. You can write north 38 degrees, 18 minutes, 14 seconds west. That's it. So you see, so not west, east. You see, right? How easy it is to convert. So is it easier in a whole circle bearings or reduced bearings? Obviously, it is easier in our which bearing system? In our whole circle bearing system only. Okay. Yes. So that is our answer. Yeah. This is what you need to do. Interchange north and south, interchange east and west, and finally what you do? You preserve the angle. That's it. Now to see whether you understand this concept clearly or not, one last question I need to ask. So look at this figure and try and answer my question. Okay. Okay, so I call this line as AB. Okay, this is A, this is B, right? This angle is say theta. Look at this figure and tell me what is the forebearing of the line BA is. Anybody? Take your time, tell me what is the forebearing of the line BA is. Forebearing of line BA. Yes. Only 2 people have given the answer. Kaustubh, Tushar, no. Rakshita, no. Very good. Almost 95% of the people has given us the correct answer. What is the forebearing of the line BA? It is nothing but equal to theta. Forebearing of BA is what? Nothing but equal to theta. Okay, forebearing of BA is theta. Then tell me, right, what will be the back bearing of ABs? Right, tell me from this figure, what is the back bearing of ABs? Come on. Yes. Again, 180 minus theta, Tushar, no, Tushar. Ankita, no. Revati, no. Praveen says depending upon theta value. No, Praveen. Vamshi, no. No, Tanvi, no, Meghna, no, Manjusha, no, Shilpa, no, Nanusri, no, Saikia. The answer is theta. Right, the answer is theta only. Answer is theta only. Right, please try to understand this. Where will I measure the forebearing of BA from? Forebearing of BA is the angle measured from B to A. When I say BA, the line is like this. Right, so forebearing of the line BA is measured from B towards A. From B towards A. What is that? That is theta. Forebearing of BA is measured from B to A. Forebearing of XY is measured from X to Y. Forebearing of YX is measured from Y to X. Yes. Now the second question is, what is the back bearing of AB? So AB means what is the direction of travel for the line AB? AB is traveling from A to B. If I ask you for a forebearing of AB, forebearing of AB should be measured from A to B like this. So this angle is the forebearing of AB, but that is not what I am asking you. I am asking you for back bearing of AB. Where do you measure back bearing of AB from? It is measured from B to A. Right, back bearing of AB is measured from where? From B towards A. This is what you call it as back bearing of AB. What is this? This is the right A to B now. This is the forebearing of AB. So tell me, where am I measure the back bearing of AB from? It should be measured from B towards A. What is that value? That value is again nothing but equal to theta. So from this we get a very, very, very useful relation for our numericals. What is that? That relation is the bearing of a line, or sorry, I'll write like this. The forebearing of a line AB, sorry, not AB, BA. Forebearing of BA can be written as what? Back bearing of A. Forebearing of AB can be written as what? Back bearing of AB. Forebearing of AB, BA can be written as back bearing of AB. Okay. So this is a very useful relation for solving problems. Okay. That's it. That is the complete concept of our forebearings and back bearings of lines. So please remember that. Okay. So this is very important for us. Okay. So that's it. So what do you mean by forebearing of the line? Bearing of a line measured in the direction of travel. Forebearing of a line XY is measured from X to Y. Back bearing of the line XY is measured from Y to X. Forebearing of a line YX is measured from Y to X. Back bearing of YX will be measured from X to Y. The relation is back bearing is equal to forbearing plus or minus 180. If you want to write minus 180, forbearing should be more than 180. If you want to write plus 180, then forbearing should be less than 180. Yes. Now, if the forbearing is given in reduced bearings, you need to interchange north and south, interchange east and west, you maintain the angle. It becomes very, very easy for us. No need to do any calculations. Right. Last one is forbearing of BA can be rewritten as back bearing of AB. Back bearing of AB will be nothing but forbearing of AB plus or minus 180. That's it. Okay, na? Yes. So we'll stop here and we'll go for our now we'll continue with the discussion towards the next point here. That is the calculation of included angles. Yeah. So before we can discuss about the calculation of included angle, let us understand, what is an included angle and what happens when we have two lines meeting at a point. So just try and answer this question. So this is my point A here. This is my point A here, and you imagine this is my line AB. This is my first line here, AB, and this is our second line, let's say BC. So I'm giving you two lines here, AB and BC. Can anybody please tell me, when two lines are meeting at a point here like this, how many angles will you get at the point of B? What are the two angles formed at B when line AB and BC are meeting? Yes, Uday Kumar says 2, Ankita says 1, then 2. Right, the answer is two angles are formed at B. Okay. So whenever two lines AB and BC are meeting at B, not back bearing, not forbearing. Back bearing, forbearings are known as the bearings of the lines. Included angle is the horizontal angle between two lines. Okay, that's the difference. Included angle is the horizontal angle formed between two lines. Bearing and all is measured with respect to meridians. Included angle is measured with respect to lines. So between the line AB and BC, how many angles are formed up? You can see that two angles are formed. Let me represent them. This is my first angle, number 1, and this is my second angle, number 2. So these are the two angles formed up, right? Angle 1 and angle 2. Can you please tell me, out of these two, right? Out of these two, who is your included angle? Who is your included angle? Can you tell me? Yes. Right? Very good. Absolutely correct. Right? These angles are right. No, before that question, right? Can you tell me who these angles are? Right. So you're saying that second one is the included angle. Right? You see, the first one. What do you know the name of the first angle here? Do you know the name of the first angle here? Yes or no? See, the first angle is what we call it as the exterior angle. Okay. First angle is what we call it as exterior angle, and the second angle is known as the interior angle. The second angle is known as the interior angle. So angle 1 is exterior angle, and angle 2 is interior angle. Now again, please tell me. Like I hope you can understand that. First one is exterior, second one is interior angle. Very good. But please tell me, why did I call angle 1 as interior? Why did I call angle 1 as interior? And why do I call angle 2 as angle 1 as exterior and angle 2 as interior? Anyone? What is the reason for calling the angles like that? Anybody? Come on. Why is angle 1 exterior angle? No. You cannot say it is outside, it is inside. You cannot say that. Yeah. That is not the correct way because this is an open traverse. In an open traverse, you cannot say who's interior and who is inside and outside. For a closed traverse only we can say who's inside and who's outside. So here we call the first angle as an interior angle, as an exterior angle because this is more than 180 degree. Okay. We call the second angle as interior angle because this angle is less than 180 degree. This angle is less than 180 degree. Yeah. So the first angle is more than 180. That's why it is known as exterior angle. The second angle is less than 180. That's why it is known as the exterior angle. Now out of these two, who is going to be my included angle? Who is going to be my included angle? Is it angle 1 or angle 2? Is it angle 1 or angle 2? See, please understand. Our included angle can be interior or it can be exterior. It can be either interior or it can be exterior. Okay? Right. So yes, let us just put all of that discussion together. Okay? So when two lines are meeting at a point, when two lines are meeting at a So when two lines are meeting at a point, how many angles we get? We get one interior angle and we get one exterior angle. Okay? Right. Now who is interior? Less than 180 angle is interior, and who is exterior? Right. More than 180 angle is the exterior angle. Now finally the question is, right, out of these two, interior and exterior angle, who is going to be my included angle? The included angle may be interior or it may be exterior. But the general preference is always given to the interior angle. So this is the first point that you need to understand. Right. This is the first point that we need to understand. Right. So based on that, we'll start our discussion. So what are figures that I have drawn? Right. What are figures I have drawn? Right. I will draw these figures once again. Okay. So let us see now how we can draw that. Okay. Just right. Right. Just wait 1 second. understanding of our included angles. Okay. This is the first fundamental understanding of the included angles. We will divide this into two different cases here. Starting with case 1, lines coming from same origin. Okay, that is going to be our first case. We are having lines that are coming from the same origin. Okay. So what do you mean by lines coming from same origin? Tell me, A, B, and BC. Are these lines from same origin? Please yes or no? Are these lines from same origin? Please yes or no? Come on. Yes. Tushar, this respond says yes. Right. Vamshi says no. Yes, yes, yes. Very good. The answer is no. These are not like coming from same origin. AB is coming from A. BC is coming from B. These are not from same origin. What about this? AB, AC. Same origin? Yes or no? Yes. This is lines from same origin. AB, AC. OA, OB, lines from same origin. Okay. So this is what we are discussing. So please remember that particular point. Okay. So we are discussing about the lines coming from same origin. Let us see how to find the included angle. Right. One by one. So let us look at the first statement. Let us look at the first statement. So I'll give you some lines here. Okay. So this is my common origin. This is my first line here, AB. This is my first line here, AB. This is my next line here, AC. Okay. So what is this bearing? That is equal to say theta 2, like second line. First line is AB. The bearing of line AB is theta. So what is the included angle theta? Included angle theta is theta 2 minus theta 1. Included angle is equal to theta 2 minus theta 1. That is the included angle. Okay. Right. Now let us look at the second case. Now tell me, is this less than 180 or more than 180? Clearly this is less than 180. No doubt. Second example, let us see. Okay. Again. AB and AC. What is this? This is theta 2. What is this? This is theta 1. What's the included angle theta? It is again nothing but theta 2 minus theta 1. Is it less than 180 or more than 180? It is clearly nothing but less than 180. Okay. This is AB. This is AC. Right. So what is the bearing here? This is say theta 2. And what is this bearing here? There is nothing but theta 1. Okay. What is the included angle here? Theta. Is it theta 2 minus theta 1? We can write it like this, theta 2 minus theta 1. But you see, if for example theta 2 is 200 degrees, theta 2 is 200 degrees, and theta 1 is say something like 10 degrees. What is theta 2 minus theta 1? What is 200 minus 10? 200 minus 10 will come as equal to how much? 190 degree. So this 190 degree is more than 180 degree, so we cannot write the answer. So we'll write the equations like this, but we need to make sure that this is not exceeding, right? It should not be more than 180 degree. So if you get an answer like 190 degree, you should write 360 minus 190. Okay. So make sure that this particular value is less than 180. That is the point. That is the third case. Similarly, let us talk about the fourth case also. Fourth case here. I think you will be able to see this fourth case. So this is my first line AB. This is my first line AB. This is AC. What is the bearing of the line AC? This is theta 2. What is this? This is something but equal to theta. So who is going to be your included angle? Please remember, this is going to be your included angle. This is going to be your included angle theta. So what is the value of theta? It is going to be theta 2 minus. If I take theta 2 minus theta 1, will I get the less than 180 or more than 180 angle? If I write theta 2 minus theta 1, I get a value more than 180. So it is not theta 2 minus theta 1. So it should be equal to 360 degree minus theta 2 plus theta 1. 360 degree minus theta 2 plus theta 1. That is our included angle. Okay. So these are the angles. Okay. Right. So please try and remember. Okay. Right. This is how we calculate the included angle when the lines are coming from the same origin. Okay. So you can see clearly who is preferred here. Interior angles are preferred. Clearly here our interior angles are given the preference. Yes. To understand this particular discussion, to understand this discussion better, we will take a small numerical here, and we will see what are the different ways in which the question can be framed. Okay, so this is the question: calculate included angle. Okay, included angle. This is the question. We are going to see what are the different ways in which the same question can be framed. So the data is like this: forebearing of AB is 40 degrees, forebearing of AC is 120 degrees. So are they line coming from same origin or different origin? No doubt, these are lines coming from same origin. This is my point A. What is this? This is my point B. This is my point. Okay. What is this bearing here? This bearing is 120 degree. This bearing is given as 40. Okay. So what is your included angle theta here? Like 128 degree minus 40 degree. You should get the answer as 80 degree. Okay. So is this more than 180 or less than 180? This is clearly interior angle less than 180. So this is the given data. Now let us see what are the different ways they can frame a question from this. What are the different ways in which they can say frame a question from this? The questions can be framed like this. Okay. The bearing of AB is 140 degree. The bearing of AC is 120 degree. The first question that they can ask you is this: what is the included angle at A? What is the included angle at A? The bearing of AB is 40 degree, bearing of AC is 120 degree. What is going to be your included angle? This is the first question that they can ask. What is going to be the included angle? How can I give you the answer for this? How can I give you an answer for this? Right. So here they are simply asking you for the included angle at A. Means what do you report? You simply report theta. That is going to be 80 degree. Okay. If they simply ask you what is the included angle at A, they don't ask you any directions or anything. Simply ask you the included angle at A. You can report the answer as the interior angle. Right. So simply if they are asking the angle at A, report the interior angle. But sometimes they will ask like this: bearing of AB is 40 degree, bearing of AC is 120 degree. What is the included angle BAC is equal to? what is the included angle BAC is equal to? What do you mean by BAC? Is the angle measured from B to A to C. Is the angle measured from where? B to A to C. So what kind of measurement is this? Please tell me, is this a clockwise measurement or is it a anti-clockwise measurement from D to A to C? Batao, please tell me, is this clockwise or is it anti-clockwise measurement? Right, clearly, yes, very good. This is nothing but a clockwise measurement. Right. Yeah, sorry. This is clearly an anti-clockwise. Now, this is counter-clockwise measurement. This is counter-clockwise measurement. So, since they are asking you for a counter-clockwise angle or anti-clockwise angle, you can again report the answer as theta. That is again nothing but 80. You again report the same angle that is less than 180 interior angle theta. But what if the third condition is something like this? What if they ask for angle CAB? What if they ask for angle CAB? So what is angle CAB? Angle CAB is the angle measured from where? C to A to B like this. Right, so the angle measured from C to A to B like this. So if you are measuring the angle from C to A to B like this is clearly a clockwise measurement. Since they are asking you for a clockwise angle, you cannot report the interior angle. You should report the exterior angle. So what is the exterior angle here? 360 degree minus 80 degree. What is that? That will be nothing but what? 280 degree. 280. Okay. So please remember, if they simply ask you the angle at A, you report the interior angle. If they ask you for a counterclockwise angle, you again report the interior angle. But if they ask you for a clockwise angle, you report the exterior angle. This is the practice. This is the practice that you should do. Okay. So please try and draw a rough figure. Please try and understand in which way they are trying to measure your horizontal angle. Okay, now based on that you can write your answers. Based on that you can find your answer. Okay, so please remember this. Okay. Right. So this is about the first, this is about the first two cases, or first three cases. Now the third case will be expressed something like this. Right. The bearing of AB is 40 degree. The bearing of AC is 120 degree. The included angle is dash. The included angle is dash. So they are not asking you for a particular angle, a particular clockwise angle, or a particular anti-clockwise angle. They just given a blank. You need to look at the options and find the answers. Let me give you some options here. So first set of options like this. Option A 100 degree. Option B say 120 degree. Option B is equal to 220 degree. Option C is equal to 80 degree. And option D is equal to 200 degree. So who is the answer here? Bearing of AB 40, bearing of AC 120, the included angle is dash. Answer is option A, B, C or D. Your answer is nothing but option C. What if the options are like this? Option A is equal to 280 degree. Option B is equal to 100 degree. Option C is equal to 120 degree. And option D is equal to 300 degrees. So now, who's your answer in the second case? Who's your answer in the second set of options? Very good. In the second set of options, it is nothing but option A. The second set of answer, the option is nothing but option A. Yes. What if, right? Now, why did you take the answer as option A here? Why did you select the option A here as correct? Because the interior angle 80 degree is not given. The interior angle 80 is not given. So whenever the interior angle is not given in the option, what you can do? You can go select your exterior angle. You can go and select your exterior angle. Right? So if the interior angle is not there, you can select the exterior angle. Next option you see, option A is 80 degree. Option B is 200 degree. Option C is 280 degree. And option D is 100 degree. So now tell me, who will select the correct answer? Who will select the correct answer? When the interior angle is there, you select the interior angle. When the interior angle is not there, you select the exterior angle. But when interior and exterior is present, who will get more preference? Interior angle will get more preference. Understand? So this is what we discussed. Right? Our included angle, right, can be either what? Interior, can be either interior angle or it can be the exterior angle. Right? Can be the exterior angle. Okay. So who is more preferred? Interior angles are more preferred. This is the definition. So this is what we have discussed. So a single question can be framed in 4 different ways, right? Depending upon what they are asking, you report the correct answer. If they are asking you for a clockwise angle like CAB, like CAB is measured in the clockwise direction, so you report the exterior angle. If they are asking you for BAC, that is measured in the anti-clockwise direction, report the interior angle. If they don't mention a direction, they simply ask the angle, you always go and prefer your interior angles. Yes. Okay. So these are the discussions in the first case, that is lines coming from the same origin. Let us have the same discussion in our case 2 here, right? Our case 2. What is case 2? Lines from different origin. What is case 2? We are having lines that are coming from different origin. So this is what ABBC, PQQR, right? XYZ, XYYZ, like that we are having lines. So in this case, please remember, whenever you are having lines that are coming from different origin, please remember, included angle is calculated very simply by using a relation or by using a statement. Included angle is the angle measured from the previous line to the forward line in the clockwise direction. That's it. So I'll write down the statement. We'll use some figures. We'll understand it clearly. So I'll write down. Right. It is measured from previous line to the forward line in which direction? Clockwise direction. That is the definition. Okay. So we'll take some examples and we'll try and understand that. So imagine I'm giving you a travels like this. So lines from same origin means we saw the figures. Lines from different origin means basically we are going to have traverses. Can we open or close traverse? This is A, this is B, this is C. A, B and C. Okay. Now tell me, the traverse is going from A to B to C. The included angle is formed at B. For this particular set of lines, who is the forward line? Please tell me. For the included angle at B, who is the forward line here? Is it AB or is it BC? Very good. Absolutely correct. Everybody. The answer is AB. Sushma? No, it's not AB. Forward line from A to B to C. Right? Okay, so the forward going line is, now the included angle B is BC. So what is this? This is the forward line. Okay. Now who is the previous line? If BC is the forward line, who is the previous line? Previous line is AB, but with respect to B, you need to tell me. Okay, you need to tell me that with respect to B. So with respect to B, who is the previous line? With respect to B, the previous line would be B. So this will be the previous line. So with respect to B, the forward line is AB, sorry, BC. And with respect to B, the previous line would be B to A. Okay. B to C is forward, B to A is the previous line. Now tell me, how should I measure the included angles? How should I measure the included angles? It is the angle measured from the previous line to the forward line in which direction? Clockwise direction. The angle measured from previous line to forward line in clockwise direction. So this becomes your included angle. Okay, right. Let us have the same discussion in another way. So this is A, this is AB, this is BC. Okay. So now tell me, same lines only we are having. Now you tell me. Right. So for this particular case, who is the forward line? That traverse is going from A to B to C. So who is the forward line? No change. Forward line is nothing but BC. So this is your forward line. The next line, previous line is what? With respect to B, who is the previous line? BA is my previous line. Yes. Now how do I measure it? Again, remember, okay? It is measured from the previous line to the forward line. In which direction? Clockwise direction. So the previous line is BA. Forward line is what? BC. I should measure from previous to forward in clockwise direction. I should measure from the previous to forward in which direction? Clockwise direction. And so tell me, what kind of angle is this? Is this exterior or is this interior? This is clearly an exterior angle. This angle is clearly more than 180 degrees. That is an exterior angle. And what is this angle? It is clearly less than 180 degrees. That is an interior angle. So now you compare these two and tell me what is happening. In both examples, in the first traverse and in the second traverse, in both of them, I have measured the included angle in the same way. How? From the previous line to the forward line in the clockwise direction. It's exact same way only I measured. But first time I am getting an interior angle and less than 180 angle, and in the next time I am getting an exterior angle. Right? That is more than 180. Tell me what is the reason for this? Why is this happening? Anybody? Why is this happening? Right. Okay. Soumya, can you explain that? Please explain, Soumya. Her answer is very vague. Soumya says it is direction. Can you explain that? Tanvi says change in position. No position. What change in position? Explain that. Directions of A and C. What is the directions of A and C? Chandra. See, look at the first traverse here. The first traverse here, ABC. How is the traverse going? The traverse is going from A to B to C like this. So what is the direction in which this traverse is going? This traverse is going in a anti-clockwise direction. Look at the traverse ABC in the second case. What kind of traverse is that? The traverse is going in the clockwise direction. So this is a clockwise traverse and this is a counter-clockwise or anti-clockwise direction of traverse. Yes or no? So tell me, when the traverse is going in the counter-clockwise direction, what is my included angle? My included angle is the interior angle less than 180 degree angle. My included angle is the interior angle less than 180 degree angle. But when the traverse, the same traverse, goes in the clockwise direction, who is going to be my included angles? It is going to be my exterior angles, more than 180 degree angle. Understand? Right? So if you recollect it and compare it to the previous discussion here, the same thing happened now. What was the angle BAC? Angle BAC was anti-clockwise. Therefore, we report interior. What was angle CAB? CAB was clockwise. Therefore, we report the exterior angle. The same logic is reappearing here. The same logic is reappearing here. It is measured, from previous line to forward line in clockwise direction. No change in that. You measure from the previous line. Right? You measure from the previous line. You measure towards the forward line. You measure it in the clockwise direction. Okay. So this is what we call it as the included angle in the second case. But here also, when I do that, when the traverse goes in the clockwise direction, I'll get more than 180. When the traverse goes in the anti-clockwise direction, I'll get less than 1. So you need to just do one thing. You don't have to make it 180 or make it less than 180 or more than 180. For you, there is only one thing that we need to do. What is it? Just identify previous line, identify forward line, and measure in that clockwise direction. That's it. That will be your introduction. That is the solution by geometry, by using figures. But some of you may find it very difficult to draw the figures. Some of us may find it very difficult to draw the figure. So in that particular case, what you can do is you can use a formula. I'll give you the formula. The formula goes like this: the included angle is equal to the forebearing of forward line minus the forebearing of previous line. Forebearing of forward line minus forebearing of previous line. So this is the formula that you can use to calculate the included angles. This is the formula that you can use to calculate the included angles. Okay, yes. But you see, there's a small problem here. What is that problem? The problem is the formula is written as A minus B. Right? The formula is written in the format of angle A minus angle B. Now, if you're writing it as A minus B, there is a good chance that at some point this particular value will be negative. At some point, A minus B will be negative. It can happen. Definitely, it can happen. So what will you do? Right? If that happens. So let me write a small note here. Note. I'll write down that statement. If the calculated included angle is negative, add 360 degrees to it. Add 360 degrees. Okay. So whenever the calculated included angle is negative, we cannot have a negative included angle. So what do? You simply add 360 degrees to it. That's it. That will be your answer. Okay. So using this formula, you don't have to draw any figure at all. You can very easily find the answers. Very quickly you can find the answers. Some of you will find that there is I don't want any formulas. For them, use this particular concept. It will always work out. Some of you want formula because you don't want to draw some figures. Then this particular method will work. We will solve problems in both the methods. Okay, we will solve problems in both the methods. So let us take a small example here, and you please do your calculation here. Calculate included angle. Okay, yes. So lines under 4 direction lines. So this is a closed traverse, lines coming from different origin. You know the formula, or I hope you have written the formula. Included angle is equal to forebearing of forward line minus previous line. And you can use the formula to find the answer, as well as you can use the equations the geometry to find the answer. First I'll use the equations, and then I'll use the geometry to find the answers. Okay? So you please proceed, I'll give you 5 minutes. After that I'll start. This is what I clearly told now. Always give preference to interior angles. Same question you are asking me again means it's not correct. So almost everybody has given us some answers, but I think all the answers are wrong. All the answers are wrong. Okay, why all the answers are wrong? Right? Anyway, let us see. Okay. So first and foremost, I'll draw the traverse here. So this is my point A here. Bearing of AB is 40 degrees. Right. So this angle is known as 40. Okay. 120. 290 degrees. Right. So no doubt this is a closed clockwise traverse. Okay. Yes. So let us look at the solution here. So tell me, what is my first angle here? Angle A. So what is the formula to find out angle A? Forebearing of forward line for angle A is what? AB. The previous line for angle A is what? AC. Okay. The forebearing of AB minus forebearing of previous line, that is AC. Forward line is AB, previous line will be AC. Okay. Yes. So forebearing of AB is what? 40 degree given to me, but what is forebearing of AC? Not given now. Forebearing of AC is not given. But we know from the fundamentals that forebearing of AC can be written as backbearing of CA. Yes. Now, what is the formula to calculate backbearing of a line? Backbearing of a line is nothing but forebearing of the same line plus or minus 1 degree. Yes or no? Yes. What is forebearing of AB? 40 degree minus forebearing of CA is what? 290 degree. Forebearing of CA is 290 degree plus or minus. I should write minus because it is more than 1 degree. Yes. So this will be what? 40 degree minus 110 degree. Okay. So what is 40 minus 110? 40 minus 110 is minus 70 degree. Right. So we know that when the calculated included angle is negative, what we should do? We should add 360 degrees to it. So add 360 degrees to it. What will be the answer? The answer will be 290 degrees. The answer will be 290 degrees. So 360 degree minus 70 degree, I get the answer as 290 degrees. So angle A is equal to 290 degrees. Now, right, please remember, how do you measure the included angle? From the previous line AC to the forward line AB in clockwise direction. From previous line to forward line in clockwise direction. You should get an angle outside the traverse. You should get an what? You should get an exterior angle. You should get what? You should get an exterior angle. Please remember it. Okay? Yes. You need to please remember that. Okay? Yes. Now, let us try angle B now. So please try angle B. Come on. I hope you understand what is the mistake you made. Yes. Now please find the angle B. Please proceed. Find out angle B. So this is BC. I hope you can say that. For angle B, who is the forward line? forward line is this one, reverse line is this one. So this is BC, this is BA. Okay, so I'll go a little bit fast. Forebearing of BC is given to me as 120 degree. Forebearing of BA is nothing but back bearing of AB. Okay. Now what is back bearing of AB? Back bearing of AB is nothing but forebearing of AB. Forebearing of AB plus minus 180 degree. That is 120 degree minus forebearing of AB is what? 40 degree plus or minus plus 180 degree. So that is 120 degree minus 220 degree. You get the answer as minus 100 degrees. With this you add 360 degrees. What is the answer you get? The answer is equal to 260 degrees. That's it. Okay. Now similarly, what is angle C? Right. So what is angle C? The traverse is A, B, C, A. So what is the forward line for C? CA, reverse line would be CB. Okay, you can also remember like this. Okay, so forebearing of forward line is CA minus forebearing of reverse line, that is nothing but CB. Forebearing of CA is 290 degree. Forebearing of CB is what? Right. Forebearing of BC. Forebearing of CB is backbearing of BC. Backbearing of BC is forebearing of BC plus or minus 180. One step I skip here, so it becomes 290 degree into 120 degree plus 180. That's an 1. So I get the answer as 290 degree minus what? Minus 300 degree. I'll get the answer as what? Minus 10 degree. What do you mean by minus 10 degree? We need to add 360 degrees to it. What's your answer? The answer would become 300 degrees. So this is your answer. Okay. This is your answer. Very good. Now it makes more sense. Now it makes more sense. Okay. So now I can see that most of you have got the answer. This is how I calculate my answer using the equations. I can do the same thing by using the figures. I can use this. I can find the same things by using the figures. So let me just use the figures here, and let me try and represent one of the angles. Yeah. So tell me. We'll start with B. For the angle B, just find out angle B. Remaining you please find out yourself. Okay. Just take it as homework. For the angle B, who's the forward line? This is the forward line. And who is the previous line? This is the previous line. How should I measure the angle from previous line to the forward line in which direction? Clockwise direction. This is how the angle should be measured. Now, remember, if you want to find intruded angle B, you need to have a reference at angle A. You need to look at the reference. For that, you need to refer the previous angle A. So the previous bearing of A is 40 degree. So if this angle is 40 degree, what is this angle? That angle is also 40 degree. Right. What will be this remaining angle here? What would be this much remaining angle here? Everything is 180. Out of that 40 is gone. So this will be what? 140 degree. So what is this angle here? This is 140 degree plus 120 degree. You should get the answer as what? 260 degrees. You should get angle B as how much? 260 degree from the figure. You should get it as 260 degree from the figure. Are we getting the same value? Yes, we are getting the same value. So let me ask you one final question. Is our calculations correct? Is our calculation correct? Yes or no? Please say yes or no. Right. The answer is we cannot say. Family says yes, our calculation is correct. But the correct answer is you cannot say, not yet. Because when will I say our answer is correct or not? Only after applying the arithmetic check. Okay, so we are having closed traverse here now, yes or no? Yes. This is a closed traverse and we need to apply the arithmetic check. So what is the arithmetic check that you will apply? Is it sum of interior angles? Or is it sum of exterior angles? Please tell me. Is it sum of interior or is it sum of exterior angles? Right? You see, what is the angles we are getting? Is exterior angles. Because it is outside the traverse. Correct now? Not because it is more than 180 or less than 180 or anything like that. This 260 degree angle is lying where? This 260 degree angle is lying outside the traverse. Right? So it is outside the traverse. Therefore we call it as an exterior angle. Therefore we call it as an exterior angle. So let us apply the arithmetic check. Oh. Arithmetic check. We can write like this. The sum of interior angles. Sorry. One plus 4 into 90. Minus equal to 3. 4 into 2 into 3 plus 4. 90 is what? 900 degrees. What is angle A? 290 degrees. So 550 plus 550, 800 plus 100. What is the answer? 900 degrees. So what do you say? Therefore, check them. Therefore, the answer is checked. Okay, that's it. So this is how you find your answers. Okay, right. So please make sure that you're applying this. So one last discussion we'll do before we move on to the next topic. Okay. So it is just the extension of what we just told you. So we'll just try and understand this. Right. So this is a closed traverse. This is A. This is A, B, C, D, and E. So what is the included angle at B? What is the included angle at B? Please tell me. Right. So for the included angle at B, who is the forward line? Forward line is BC. Who is the previous line? Previous line is B. How I should measure my included angle from the previous line, okay, to the forward line in which direction? Clockwise direction. From previous line to forward line in the clockwise direction. That is how I should measure my included angle. Please tell me, is this interior or is it exterior angle? Whatever angle that we got here, is it interior or exterior? It is exterior, but not because this is more than 180. It is only because of the fact that the angle is lying outside the traverse. Only because of the fact that the angle is lying outside the traverse. What if you are having a traverse like this? What if you are having a traverse like this? Say, like this. E, D, and let me call this point as F. So here, for this particular point here, E, what is going to be my included angle? Who is the forward line? A, B, C, D, E, F. So EF means this is the forward line. Who is the previous line? This is the previous line. How should I measure? From previous line to forward line. From previous line to forward line in clockwise direction. So this is how you measure. Previous to forward in clockwise direction. Previous to forward in clockwise direction. Clearly, this angle is less than 180. Clearly, the angle is less than 180. So tell me, will I call it as interior? No, you cannot call it as interior. You have to call it as exterior. Why? Because even though it's less than 180, he is lying outside the traverse. Where is he lying? He is lying outside the traverse. So we have to call him as an exterior line. Okay, now please try and understand this. Okay. Yes. Okay. So that is our answer then. Okay. Yeah. So that is the case here. Okay. Now let us take one more example here. So I'll draw another traverse here. So I'll name this as A, B, C, D, and E. Okay. Yes. Now this is my point B here. Tell me who is the included angle at the point B. Tell me who is the included angle at point B. Like again the same thing. Measure from previous line to forward line in the clockwise direction. So who is the previous line here? Previous line is like BA. And who is the forward line? This is the forward line. Who is this? This is my previous line. This is the forward line. Right. How is my included angle measured? Included angle is measured like this. From the previous line to the forward line in which direction? In the clockwise direction. From the previous line to the forward line in the clockwise direction. Like this. This is how you measure. So is this interior or is it exterior? This is interior. Why? Because it is inside the traverse. Okay. Right. So you look closely. In both cases, the way I measure is the same. From the previous line to the forward line in the clockwise direction. Okay. So is in the second case, previous line to forward line in clockwise direction. But first time I am getting an exterior angle. Next time I am getting an interior angle. What is the reason? Again, it is because of the direction in which the traverse is going. How is the first traverse going? Right. The first traverse is going in which direction? In the right clockwise direction. But the second traverse is going in which direction? Anti-clockwise direction. So again, the same discussion is repeating. Whenever you are having clockwise traverse, included angles are inside interior angles. Okay? Whenever we are having closed clockwise traverses, the included angles are what? Exterior angles. Clockwise means always exterior will come. Anti-clockwise means always interior will come. But in the case of closed traverse, interior is inside the traverse and exterior is outside the traverse. Please remember that. So this is one last point that we should know when we are talking about the traverses. Okay? So we'll write a note on this. The way you measure will never change. Forward, previous line to forward line in clockwise direction. The way you measure should not change. Okay. Right. So next step. So this is how the angles are represented. Okay, yes. Please remember. Right? Only one point. You measure from previous line to forward line in clockwise direction. Right? That's the only point. If the traverse is clockwise, automatically you'll get interior. Exterior. If the traverse is anti-clockwise, automatically you'll get interior angles. That's it. Okay? So this is the entire discussion regarding the calculation of included angles. One last problem we'll study here. That is the reverse of our included angle. Right? So in the first few examples, included angles have to be calculated from the given bearings. But now there is another numerical where we need to calculate bearings from the included angles. Right? Please proceed to try and solve this problem. You can solve this in two ways, either by using the equations or by using the formula. Formula will be very, very easy for us. So let us try with the geometry by using the figures. Please try this once. Let us see whether you can get the answer or not. I'll give you 2 minutes. Please try. Till date. Okay. So we can solve this problem by 2 ways, by equations or by using the formulas. Yes. 120 degree will be the correct answer here. Right. So let us first draw by using the figures. Okay. Right. So if you are using the figures, let us see what happens. So this is my line here, A, and the bearing of AB is 160 degrees. 160 degrees. Okay. Now how should I draw the line BC? I don't know. Because bearing of BC, I don't know. Is it like this, like this, like this, like this? Truly speaking, I don't know how I should draw the line BC. But they are saying that, right, the included angle is equal to 140 degree. Right. For the angle ABC, who is your forward line? BC is the forward line and BA is the previous line. That means this particular line here, right? This particular line here, that is your previous line. And how will I measure it? I will measure 140 degree from the previous line to the forward line in clockwise direction. So if I do measure like this, I should get the included angle as 140 degree. That means the line BC should look something like this. Right. So this is where the line BC should come. So now, yes, this is where the line BC should come. Now what are they asking you is the forebearing of BC. Please look at the figure and tell me, if this angle is equal to 160, what will be this angle? That angle will be 20 degree. If that angle is 20 degree, what is this angle? That is also 20 degree. If the entire angle is equal to 140, what will be the forebearing of the line BC? The forebearing of line BC is from this figure 140 degree minus 20 degrees. We'll get the answer as 120 degrees. So this is the answer by using the figure. This is the answer by using the figure. But ultimately in our gate examination, right? We should get the answer as soon as possible. Right. So what is the easiest way of finding the answer? That is by using the formula. Included angle is equal to forebearing of forward line minus forebearing of previous line. So the included angle is given as 140 degree. Forebearing of forward line BC I need to calculate. Forebearing of previous line is what is given as 1. Forebearing of AB is 160. So I need to calculate forebearing of BA. So this will be equal to forebearing of BC minus what is forebearing of BA? Forebearing of BA is backbearing of AB, that is 160 degree plus 1 degree. Okay, that should be 40 degree. So from this, forebearing of BC is what? 140 degree plus 160 degree plus 1 degree. What is the answer we get? Okay, that's 480 degrees. But does it make any sense to have an angle bearing more than 360? No, it is not at all, making any common sense. So I'll reduce 360 from it. So if I reduce 360 from it, I'll get the answer as 120. So this is the easiest way of finding the answer. But the figures that I've discussed is, it's an alternative solution. It's an alternative solution. If you understand how to draw the figures, it means you clearly understand the concept of included angles. That's it. Okay. So that is our discussion for our included angles. Okay. Yes. So whatever concepts are there for included angles, we have touched everything. We have taken some good examples to understand how the particular, concept works. Right. Now, let me ask you the question I asked you previously. Okay. When two lines are meeting at a point, how many angles will I get? The first question I asked you at the beginning of this discussion of included angle. Whenever two lines are meeting at a point, this is C, this is B, this is A. What are the two angles you get? How many angles did you get? Please tell me. How many angles did you get when two lines are meeting at a point? We discussed that we get two angles now. Yes. But now I will say you will get three angles. You get three angles. What are the angles? Let us see. This is the interior angle. This is the exterior angle. But apart from that, one more angle you get, that is a deflection angle. Let me show you how. How will I travel from A to C? To travel from A to C, I need to travel from A to B first. After that, I should travel from B to C. This is how I travel from A to C. So if I extend the direction of AB, after reaching B, I need to deflect by an angle like this. I need to change my direction by an angle like this. Then only I can travel to C. The amount by which you change is what we call as the deflection angle formed at the point. So there is interior angle, there is exterior angle, and then there is this deflection angle. Similarly, what if I have another line, say CD? How will I travel from CD? First I need to travel from B to C. That is the direction of B to C. Then I need to travel from C to D. How? By deflecting like this. Right? By deflecting like this. So what do you call this? We call it as the deflection angle at C. We call it as the deflection angle. That's it. So this is what we call it as the third angle when two lines meet at a point. Interior, exterior, and a deflection angle. Deflection angle is the angle that you measure, from the previous line to the forward line. Sorry, from the extension of the previous line to the forward line. So this is the extension of previous line. From the extension of previous line to the forward line. The angle that you measure is what we call it as the deflection angle. Okay. Now basically we have two types of deflection angle. They are right deflection angle. Second one is left deflection angle. First one is right deflection angle. What is next one? Next one is known as the left deflection angle. Okay. So tell me, out of delta B and delta C, who is your right deflection angle? Who is right deflection angle? Delta B or delta C? Yes, very good. Delta B is the right deflection angle. Very good. And delta C is the left deflection angle. Please remember, right deflection angles are positive and left deflection angles are considered negative deflection angle. Okay. So let us look at the concept here. So what is my deflection angle? Deflection angle is nothing but the angle measured from the extension of the previous line to the forward line. Deflection angles may be right deflection angle positive or left deflection angle that is negative. We can see that. Yes or no? Yes. So that is the concept of our deflection angle. Okay. Yes. Now what I'll do is I'll draw a small figure here. And let us try and understand that. Okay. So this is right deflection angle. Left deflection angles, let us. Now, what I'll do is I'll draw a small figure here. You tell me, right, what is happening. Okay. These are all extension of the line. So what is this? This is the deflection angle at A, deflection angle at B, delta C, delta D, and delta E. My question for you right now is, what is the sum of these deflection angles will be equal to? Batao. Any idea? Yes, very good, Chandra. Very good. Deshpande. Dosto. Soumya, no. Tanvi, very good. What is the sum? The sum is nothing but equal to 360. Right? You can clearly see that. You see, my line A is rotating like this. This is delta A. After that, delta B. Right? After that, delta C. Right? After that, delta D. And after that, delta A. So what is the total sum of these all angles? 360 degrees. Okay. So is it sum with sign or without sign? Obviously, it has to be sum with the sign only, because deflection angles may be positive or it may be negative, depending on whether it is right turning or left turning. Okay. So let me write down that point here. Also, please remember, deflection angles are used in preferred in what kind of traverse? Open traverses. In closed traverses, we prefer included angles, but in open traverses, it is preferable to go with the deflection angle. It is preferable to go with the deflection angle. Okay, yes. So that's it. That is the discussion regarding the two angles here, right? So now we'll move on to our next concept here. That is nothing but the concept of depth. Okay. So let us start our discussion on the concept of depth. Let us solve some problems. Okay, for that. Just give me a second. Grishma Shri. Bandaru Grishma Shri. What happened? You have any question? Grishma Shri. You raise your hands. If you have any question, you please ask me. Can't solve this? Can't solve this. Yeah. Okay, so what is the answer for this? Everybody say answers options. Okay, very good. So, what are they asking you in this question? They're asking you for the interior angle. Now, I did not give you any formulas for interior angles, so you need to find the answers by drawing figures only. The bearing of AB is 70 degree, the bearing of BC is what? 135 degree, and CA is 275 degree. Right. So this is A, B, and C. Now, please understand, they're asking you for this angle here. They're asking you for this angle. This is the interior angle B. They're not asking you for the included angle. They're asking you for the interior angle. Please look at this figure and tell me what would be this? What would be this? There would be nothing but back bearing of the line AB. There is nothing but back bearing of line AB. And what is this? This is nothing but forebearing of the line AB. So what is the interior angle B? So this is not a formula. I am just writing this from the figure. Interior angle B is nothing but this back. bearing of AB minus forebearing of BC. What is back bearing of AB? Forebearing of AB is what? 70 degree. Right? So forebearing of AB is 70 degree plus 180, that is the back bearing, minus what is the forebearing of BC? Forebearing of BC is given as 135 degree. So what is the answer? I'll get it as 100. Absolutely correct. Everybody got the answer. Option C is correct. Yes. Very good. Okay. Try this problem here. Question number 3. Question number 3 is very easy. Question number 3. The WCB of the line is 6 pi by 3. 6 pi by 3 is what? 2 pi. 2 pi means what? 360. Right? What is its reduced value? So what will be the reduced value? 360 degree means it is nothing but due north. Na? Nothing but due north. Due north means here, as per this, I can take the answer like this. Right? As per the options, I can select the option A as the correct answer. Sorry, option D as the correct answer. Okay. Right. Try question number 4. So identify which case is that and to give me the answer. Okay, identify the case and give me the answer. Okay, Harikiran. But which case is this? Yeah, so this is a common mistake. This is not case 1, it is case 2. But the problem with this question is whether you solve it as case 1 or case 2, both the time you get the same answers. But please try to understand the mistake here. This is not case 1. So first line is AO. Bearing of AO is 130 degrees. And OB is 40 degrees. So 40 degrees. 40 degrees. So who is the forward line? Forward line is OB. Who is the previous line? This one. How should I measure previous line to forward line in clockwise circle? This is how I should measure. Now tell me, if this angle is equal to 130 degree, if this angle is equal to 130 degree, what will be this angle? This angle will be 50 degree. So if that is 50, what is this? This is also 50. Then what is the included angle at 4? Is equal to 50 plus 40. You should get it as 90 degree. Right. That is by using the figure. I want to use the equation angle is equal to forebearing of OB minus forebearing of OA. Forebearing of OB is 40 degrees. What is forebearing of OA? Forebearing of OA is backbearing of AO. Backbearing of AO is nothing but forebearing of AO. What is that? 130 degree plus or minus 180. So plus 180. Okay. So 40 degree minus 310 degrees. You get the answer as minus 2 something. So the calculated answer is minus. We should add 360 degrees to it. What should be your answer? The answer should be 90. So in both examples, we are getting the answer as 90 degrees. Okay. So if you draw it as case 1 now, right? Then also you get 90. So this is OB, right? This is OA, this is 130 and this is 40. Again, the difference is what? 90. But that is not the correct solution. Okay, that is not the correct solution. Please understand. I hope anybody who made mistakes can correct it now, right? So I hope this is clear. Yes. Try this question now. I'll give you 2 minutes. Please try it. Okay. angles QPS is 60 degree. If the bearing of the line PQ is 30 degree, what is the bearing of the line RS? Okay, right. So whenever you are going to draw figures now, always start drawing with the bearings. Okay. So what is the bearing of the line given here? PQ is 30. So I also start drawing my data with that bearing only. So this is my point P. This is my point P. Okay. Right. So what is this answer? This bearing is given to me as 30. Now they are saying that the angle QPS is equal to 60 degree. So if this is equal to 30, this remaining angle is what? This remaining angle is 60 degree, which means your traverse should be going in this direction. Yes. So this is the S point of. This is how my traverse is supposed to look like. Like my parallelogram is looking like here. This is R. Yes. Now what are they asking you? They are asking you for the bearing of the line. What is like RS? So they are asking for bearing of this line. That is the bearing of RS. Yes. Okay. Right. Now tell me, if this is a parallelogram, PQ is parallel to SR. Right now, PQ will be parallel to SR. You cannot say RS because in surveying directions are very important. The bearing of SR and bearing of RS are different. Okay. So when I say PQ, right, the direction is from P to Q. SR is from S to R. So these directions are also important. Right. So what we can say is, if so, bearing of PQ, if they are parallel, forebearing of PQ will be equal to forebearing of SR. If this angle is 30 degree, what is this? This is also equal to 30 degree. If that is 30 degree, this is also 30. Then tell me what is the forebearing of RS? Forebearing of RS is equal to this entire angle is what? 180 plus 30. Like this entire part is 180 degree. Am I audible? Audible? Yes or no? Please tell me, am I audible? Yes, so this will be nothing but what? 180 degree plus 30 degree. I should get the answer as 210 degree. That is our answer. Okay, yes. So use your logic and find the answer. Okay, so figures will always try and help you. Try the next problem here. Try this problem. Figures will always try and help you. Try the next problem here. Try this problem. So, a closed traverse PQRS, a closed compass traverse PQRS is run in a prismatic compass in clockwise direction. The value of the included angle S is dash. So, they are asking you for the value of the included angle S. Now, again, we will solve it by using the equation and also by using the figures. But please remember, if you are going to solve it by using figures, you don't have to draw the entire traverse. Please remember this. Right? You never have to draw the entire traverse. You just need to draw the previous line and forward line only. Please remember that and please try and give me the answer for this. I'll give you 2 minutes, okay? So Harikiran has already given us the answer. Akshita, yes, Mahindrati, Ajay. Okay, so you have given me the answer already. Not opposite angles are equal. This is opposite included angles. Opposite included angles. That is the concept. Okay. Ravi, 30 na opposite included angles. Yes. So you have given me the answer. So let me start with the solution here. So first and foremost, I will find the solution using the equation. Okay. So what is the equation? Forebearing of the line. So what is the traverse? P, Q, R, S, P. They are asking you for the included angle at S. So for the angle at S, we have forward line. SP is forward line. SR is the previous line. So included angle at S is equal to forebearing of the forward line SP minus forebearing of the previous line SR. What is the forebearing of SP? 310 degree. What is forebearing of SR? Forebearing of SR is nothing but backbearing of RS. What is backbearing of RS? Forebearing of RS plus or minus 180 degree. Right. So it is 310 degree minus 230 minus 8. So it's equal to 310 minus, what is this? 50. What's the answer? We get the answer as 260. That is by using the equation. Let us use the figures here. So what is the bearing of RS? Just RS and SP I need to draw. RS is 230 degree. So it is going in the third quadrant. So I'll take R here. And RS is going in the third quadrant here. Right. Next one is SP. RS. Right, that's it. So this bearing is given as 310 degree. This bearing is given as 230 degrees. Now, who's the forward line? Forward line, previous line. How should I measure? From previous line to forward line in clockwise direction. This is the angle that we want. Okay. So this bearing is 310. So, remember what I told you. Use the help of the previous point. If you want S, you need to take the reference of R. So if this entire angle is equal to 230 degree, what is this much angle is equal to? 230 minus 180, that will be equal to 50 degrees. So if that is 50, what is this? This much angle is equal to 50. So from the entire back bearing is 310, and from that 50 is gone, you get the answer. So what is this? 310 minus 50, you will get it as 260 degrees. Okay. You'll get the answer as 260 degrees. Okay. So I hope you are able to solve this. Okay. Yes. You can see so many answers come. Yes, very good. It is nothing but 260 only. Okay. Yes. So that is some questions on included angles from this chapter. Good number of questions from included angles. Okay. The remaining problems I think you'll be able to solve it. Let us solve this one also. The 3 more questions are there. We'll try them also. Try this problem. Try this once. Right, so this is a case from same origin, okay? So this is a case from same origin, so just from figure itself we'll get the answer. The answer is 90. So the answer here, the answer is nothing but option. Question number 10. The quadrantal bearings of line AB and CE are south 2530 and south 5030 respectively. Calculate the included angle. Please solve this. Please solve this. I'll give you a minute. Please try it, okay? What is the bearing of AB? South 25, 30, east. So what will be the whole circle bearing? Whole circle bearing will be 190 minus 25, 30. Right, 180 minus 25, 30. What is 180 minus 20? 160. 160 minus 5 is 155. 155 minus 30 is 140. 154 degrees 30 minutes. What is the bearing of CA? South 25, south 50, 30. 50, 30 east. So that is 180 minus 50 degree 30 minutes. What is 180 minus 50? It is 130. 130 minus 30 is 129 degrees and 30 minutes. Right. So these are the two lines that we have. So where does the line starts from? This is the first question. Does the line starts from, or this traverse starts from C? The answer is no. It starts from A, goes to B. Right. Starts from C, goes to A, and goes to B. This is the order. C, A, B is the correct order. Right. So the beginning is from C. Okay. And the bearing is what? 129 degrees and 30 minutes. Right. Next one is B like this. So this is how C, A, and B will go. Right. This is how it is going. Okay. Now who's the forward line? AB is the forward line. Who's the previous line? AC is the previous line. How should I measure? The previous to forward in clockwise direction. Okay. So the introduced angle at A is equal to forebearing of AB minus forebearing of AC. Forebearing of AB is 154 degrees 30 minutes minus forebearing of AC is backbearing of CA. Backbearing of CA is forebearing of CA 129 degrees 30 minutes plus or minus plus 180 degrees. So if you solve this, you get the answer as 154 degrees. Sorry. Get the answer as 29 degrees plus. What is the answer you are getting? Get it as negative. Much you get 155 degrees. Get it as negative 155 degrees. To this you need to add 360 degrees. What is the answer you get? 100. You will not get the answer as 205 degrees. Are you getting this value here? Yes or no? Yes, very good. 205 degrees is the exact answer. Right, so very good. So the problem is, yes, option B, Tushar. The problem is, you may not understand from where the line starts. So this is where they will try and get confused. Okay, so just draw some lines that will give you more clarity about what is happening. Okay, you can use equations, you can use figure also to solve this, but I'm not going to do that here. Please try it. Try this question here from our classroom practice 11th question. This is again which case you identify and try and solve. So this is again lines coming from same complementary mode of OP and OQ. What is the bearing of OP? 20 degrees. What is OQ? How much? 20 degrees and 15 minutes. This is my angle. So what is the angle O? The angle O is 337 degrees and 45 minutes minus 360 degree minus 337 degrees 45 minutes minus not minus plus 20 degrees and 15 minutes. So 22 degrees and 15 minutes plus 20 degrees and 15 minutes. What's the answer? 42 degrees and 30 minutes. Option D. So option D should be the correct answer. Are you getting this? There is some problem with the camera. I don't know what that is, but I hope your audio is not disturbed. Yes, so this particular video is completely flickering. Yes, very good. You got the answer. Yes. Right now, let us look at the homework question. Did anybody get this answer? Did anyone get the answer for this? Did anybody get the answer for this? Please say yes or no. Yes, Tushar, tell me the answer. This yesterday's homework question for GM batches. I think Friday morning homework question. Tell me the answer. Go back and check it. Okay, that was a response to previous question. Okay. Right? Why no answer? Right then now. If you did not get answer, please write now. calci to find the answer. I told you this. If you have to use this answer for different question, you answer for this, you answer for this. Samruddhi has given me the answer of 100 meters. That is correct. Let me ask you, Samruddhi, did you use any equations for this? Or did you have to use any calci for this, Samruddhi? Okay, so given day before. Okay, so let us see what her response will be later. Okay, Samruddhi Asole, did you have to use any calci for this, yes or no? Anyway, let us see. So a survey line BAC crosses a river in the form of a obstacle in the form of a river, A and C being on the near and distance bank respectively. We are standing at D, 50 meters measured perpendicular to AB. The bearing of C and B are 320 and 230 decimal. I told you just now that whenever you get, whenever you have to draw figures, you have to start drawing from the bearings. So we also do the same thing here. I'll start drawing from the bearing. Okay, so this is my point D. What is the bearing at which I'm seeing the point C? C is observed at a bearing of 320 degrees. So this is where my point C is. So that is my point C. Somewhere around here, at 320 degree, I'm having my point C. And at 230 degree bearing, I'm having my point B. So this is B. Somewhere around here, I'm having C. Okay. Now, let me draw the bearings here. So how is the survey line crossing? The survey line is crossing from B to A to C. The survey line is crossing from B to A to C. Okay. So this is how my survey line is crossing. This is from B to A to C. Now, where is this point D? The point D is measured from A perpendicular to AB. So how is the AD line looking? This is how it looks. This is how it is looking like. Okay, yes. Perpendicular to AB, yes, like this. The length of this line is given as 50 meters. The length of this line is given as 25 meters. They are saying that what is the width of the river? So A is on the one side of the bank and C is on the other side. This is what they are saying. Okay, so the survey line is going from B to A to C. This is how my figures should look like. This is how our figures should look like. Okay. Now, let us see where are the possible mistakes that can happen. One possible mistake that you can do is you will draw like this, and you'll make the survey line BAC like this. They're saying they are perpendicular now. You'll take it exactly like this. So now you'll think that this angle will be 270 degree. Okay? This much angle is 320 degree. So this is 50 degree and this is 40 degree. Now that is wrong. Because they did not say that point A is due western. They did not say that point A is due western. And they did not say, right, it is exactly at 270 degree. So do not take any such assumptions. If you take that, then your answer will be going wrong. Okay? Yes. So now how to solve this problem? The solution will be using the similar triangle principle. So what I'll do is I'll assume an angle here theta. I will assume that this angle here is equal to theta. Okay? Or rather, let me assume this angle is equal to theta. So this is theta. What is this? This is 90. Then what will be this angle here? How much will be this much angle? This much angle would be 90 minus theta. This much value would be what? You see, can you look at that figure and tell me what is the angle BDC is? What is the angle BDC is? Angle BDC 320 degree minus 230 degrees. Yeah? Yes. What is the answer I get? I get the answer as 90. So this is what this is already discussed now. This is theta, this is 90, then what is this? 90 minus theta. That is theta. Now we understood that. This entire angle BDC is equal to 90 degree. So this entire angle is equal to 90 degree. Out of this is 90 minus theta. So then what is this? This remaining angle should also be equal to what? Theta. Right. So this theta is common in the first triangle and theta is common in the second triangle. So tell me what is the value of tan theta from the first triangle? Tan theta is opposite side AD by adjacent side AB for the first triangle. For the second triangle, what is tan theta? Opposite side AC, adjacent side is AB. Now who is the unknown here? AC is here. So tell me the value of AC. AD into AD by AD. So what is AD? 50 into 50 by 25. What is the answer I get? The answer I get is what? I get the answer as 100 meters. So this was a previous year AC question. Okay. So what is the answer here? The answer should be equal to 100 meters. You don't have to use any calci here. Right? You don't have to use any calci. Very good, somebody. You'll get the answer like this. That's it. Okay. So that was a homework question. Okay. So you need to draw some figures. You should have some basic idea about how to draw the figures. Right? This was the another previous year gate question that we gave us homework. Not the same question, but a similar model of question. So the line is measured with a 20-meter chain on a rising gradient of 1 in 10. So this rising gradient is what? 1 in 10. What do you mean by 1 in 10? For 10 horizontals are raised by 1 meter. What is this length of 195.8 meters? But the problem is the chain is too long. Too long by how much? 0.8 link. 0.8 link means 0.8 into 20 centimeter. 1 link is equal to 20 centimeter now. That is equal to 16 centimeters. So my chain is 16 centimeters too long. So tell me, is this 195.8 meter correct sloping length? No. So first of all, we need to find out the correct sloping length. So the correct slope distance is equal to what? It's equal to right measured slope distance into L dash by L. What is the measured slope distance? 195.8 into what is L dash? Right, 20 meter chain. Yes, so 20 plus 0.16 by 20. So this will be the measured sloping length. Can you please tell me what is the value for this measured sloping length? How do you know both values are point D? Now, read the question, Baba. Right, standing at point D, measured 50 meters A. The bearings are this much. What is the meaning of the statement, my dear anonymous attendee? You are standing at D. The bearings of C and D. That means from D you are looking at C and B. That is the logic. Read the question. Okay. Yes, very good, Divyan. So what is the value of getting? 197.366. So the correct sloping length is what? 197.366 meters. Yes. So now, what is the correction for slope? Correction for slope is equal to L into 1 minus of cos theta. So from this, what is the value of this theta? Theta will be, you can calculate, tan inverse of 1 by 10. Tell me the value of theta. Tan inverse of 1 by 10. What is the value of theta? Five point 7 degrees. Yeah, so substitute the value. So this is the L value. Yeah. So tell me what is the correction? What is the correction? Tell me the correction required here. Minus 0.097. That's it. That is the correction. So what is the correct length? Correct length is equal to measured length plus correction for slope. Now what is your measured length here? 197.366. Right. Plus minus 0. What is the answer? What is the answer? 196.39. Yes or no? Yes. Okay, so this was a question that we put in our YouTube channel. The same solution was there. The same question was there in the gate. Luckily we got it. Yeah. Yes. So by analyzing the previous year question patterns and by understanding the untapped areas, we were able to frame these questions. Okay. So it's very important that you write test series as many as possible right before the examination. See, I will never say that you should only attend the ACE Academy test series. I should not say that actually. For your future, for your brighter future, you should always attend as many as you want, as many as you can. So from wherever you get it, you try and write as many as possible, provided you are writing some standard questions. Okay, do not go and write, pay money and go and write for some worthless questions. No, don't do that. So some good quality test series wherever you can find, you should. Right. So definitely, obviously, you have to go through ACE Academy first. After that, whatever you get now, you should try as much as possible for your better preparation. Okay, now yes. So we'll go for a break now. I'll see you in 20 minutes. Okay. Please remember, when it comes angle, a magnetic needle makes with the horizontal. We'll talk about the concept of dip. Okay. So how to measure the included angle, all these things we discussed. Let us continue with our next discussion about dip. See, the definition of dip is something like this. It is the vertical angle the magnetic needle makes with the horizontal. What do you mean by dip? It is nothing but the vertical angle a magnetic needle makes with the horizontal. See, so far in our chapter, we have only discussed about horizontal angles. Right? So far we have only discussed about horizontal angles only. So if you have discussed about only horizontal angle, what is this vertical angle? Right? How is this vertical angle coming? From where it is coming? Let us try and understand. So how do you express dip? Once again. Yes. So you just imagine that this is the body of your compass. Okay. So we are going to talk about dip here. Okay. You just imagine that this is the body of your compass. Inside the body, there will be a central pivot like this. This is what I can call it as a pivot. Okay. That is a central pivot, and this is the horizontal passing through the pivot. We expect the magnetic needle to be horizontal like this, but sometimes what happens is, right, the needle will not be horizontal. It will be making an angle with the horizontal like this. Right. It is supposed to be horizontal along the center line, but it is inclined by an angle like this. So this vertical angle the needle makes with the horizontal, that is what we call it as dip. Okay. So this is the body of the compass. central pole. Yeah, that's it. Now, why do we get it? That is because of the magnetic field lines of the Earth. So, you see, imagine that this is the geographic south, not geographic actually. This is the magnetic south, and this is the magnetic north of the Earth. So, if Earth is having a magnetic north and magnetic south, it means that our Earth is in fact a magnet. Yes. If it is a magnet, it has magnetic field lines, and this is how the magnetic field lines goes. Okay. If it is a magnet, it has magnetic field lines also, and this is how the magnetic field lines go. That is the direction in which how the field lines are going. So they originate from the south, they go parallel to the equator, and they go back to the magnetic north like this. So if you can imagine that we are having a friend here. So you imagine I'm having my friend here standing like this. He holds a magnetic needle. What the needle will do? The needle will always align in the direction of the magnetic field line. So if you look at this, the magnetic field lines are truly vertical like this. So right now, the magnetic field lines are making an angle of how much? 90 degree with the vertical. So what is my dip angle now? The dip angle is 90 degree. Right. So what if my observer comes and stands here? If the observer comes and stands here, sorry. Yeah. So if the observer comes, 1 second. Yeah. Now let us consider another observer coming and standing at the equator. So this is my another observer who's standing at the equator like this. Here also, when I bring in my needle, what the needle will do? The needle will align in the direction of the magnetic field lines. So the field lines are now parallel to the Earth. Therefore, the needle will also be parallel to the Earth. So at this point, my dip is equal to 0 degree. At this point, my dip angle is equal to what? 0 degree. Okay. So the magnetic dip can vary from 0 degree to 90 degree. 0 degrees at the equator and 90 degrees at the magnetic poles. Anywhere between my pole, the dip angle, anywhere between the equator and the pole, dip angle will vary from 0 to 90 degrees. Okay. Now let me ask you something. Do you really want to see the dip? Yes or no? No. We really don't want to see the dip. Right. So what we do is, right, in order to avoid this amount of dip coming, what we'll do is we'll attach a sliding counterweight on top of the needle. What we'll do? Yeah, we will attach a 1 second. Problem with the note here. 1 second. Please wait, okay, there's a problem with the notes. It's not responding. Please wait 1 second. Okay, so this is what we discussed. Yeah, this is how our magnetic field lines are going to look like. Yes. Now, what was the last question I asked you? The last question I asked is, do you want to see this magnetic, dip? Yes or no? The answer is no. So, to prevent this particular magnetic dip from happening, what we can do is we can achieve or we can place a sliding counterweight here. So, on top of this needle, we'll attach a sliding counterweight here. What is this? This is the counterweight. So, right. So, using this counterweight, now we will be able to slide it and we can eliminate dip from it. Okay. So, dip is not something that we want to see in the needle. We'll eliminate it by moving this particular sliding counterweight. That's it. So let us talk about the points that we discussed here. So nothing much here, not very important, but still let us just go through it. So vertical angle, the magnetic needle makes with the horizontal. Okay. Dip is 0 degree at the equator as magnetic field lines of the Earth are parallel to the Earth surface. Okay. And it is 90 degree at the poles as the magnetic field lines of the Earth are normal to the Earth surface. Magnetic field lines of the Earth are normal to the Earth surface. Okay. Next up, it should be eliminated by using a sliding counterweight. Please remember, when it comes to our magnetic dip, there are two lines associated with them. They are the aclinic lines and isoclinic lines. We have two sets of lines associated with our depth. They are aclinic lines and isoclinic lines. So what do you mean by this aclinic and isoclinic? Let us start with isoclinic. What do you mean by the term iso? By the term iso, it means that same or equal. Iso means what? Same or equal. So isoclinic lines, what they will do? They will join points of same or equal, dip angle. Isoclinic lines will join points that are having same or equal value of magnetic dip. Okay. And what will the aclinic lines will do? Right? They will join points which are having zero dip angle. They joins points that are having zero dip angle. So aclinic lines are lines joining points of zero dip angle. Isoclinic lines are lines joining points of equal, or same dip angle. Remember this, okay? Isoclinic lines are lines joining points of equal dip. So remember, inside a clinic, you always find a dispensary, right? Dispensary, correct now? Yes, dispensary. Okay. So you think about this. Dip is short form of dispensary. Okay. You think about this. That dip is short form for dispensary. Dip is short form for dispensary. Inside a dispensary, you always find a clinic. Okay. So aclinic and isoclinic lines are associated with the dispensary or dipper. Clinic is always associated with the dispensary. So please try and remember like this, because now it will seem very clear to you, but later on you may forget. So have some shortcuts. Sometimes it will help a lot. That is about the magnetic dip. Next, we'll talk about one very important concept, that is what is meant by declination. Very important concept, declination. See, declination is very simple to understand. It is nothing but the horizontal angle formed between the true and magnetic meridian at a place. So if you are standing at a place, say A, and you know the direction of true meridian as well as you know the direction of magnetic meridian, the angle formed between these two meridians is what we call it as our magnetic dip. Let us try and understand that. Sorry, this is what we call it as the magnetic declination. Okay, sorry. Let us try and understand that. So you imagine this is the magnetic, or rather the true meridian at a point A. That's the direction of true meridian at a point A. When I keep a compass at A, magnetic compass, let me tell you that the magnetic needle is showing me a direction like this. Then this becomes your magnetic meridian. So can you see a horizontal angle is forming between them? Yes. What is that horizontal angle? This horizontal angle is known as declination. Similarly, you imagine that this is another true meridian that you have, okay, at a point say B, and when I keep the magnetic needle at the point B, it is showing me a direction like this. What is this? This is our magnetic meridian. So again, can you see an angle forming between them? Yes. What is this angle? This is known as declination. In the first example, the magnetic meridian is where it is towards the east of my true meridian. Correct. Now, with respect to my true meridian, the magnetic meridian is towards the east. So what do you call it as? You will call it as eastern declination. We call it as eastern declination, and they are considered to be positive. With respect to my true meridian, where is this? This is towards the western. So we call it as the western declination. Call it as western declination, or it is equal to negative declination. So now, yes. Right. So that is what we call it as a declination. It's nothing but the horizontal angle formed between the true meridian and the magnetic meridian at a place. That's it. Let me ask you a very important question. Is the declination at a point constant? Please tell me. Is the value of declination at a point constant? Yes or no? Yes, very good. The answer is no. Absolutely correct. The answer is no. Why? See, there is no problem with the true meridian. He will remain there. But what about the magnetic meridian? He will always change position. Correct now. So as the magnetic meridian changes position, the declination also changes. So please understand, the declination at a point is not constant. It will change. It will always change. Declination at a point is not constant. On a daily basis, it changes. On a week on a daily basis, on a yearly basis, right, and on an irregular basis also, this declination changes. So due to this, vast majority of changes, I can also call declination as variation. You can also call declination as what? Variation. So please remember, whenever you are writing examinations, like your state service commission examinations, PSCs and all you write now, make sure you remember this alternate names. Declination is also known as what? Variation. So you please highlight this alternate names, because they will ask you like this. The horizontal angle between true meridian and magnetic meridian at a place, okay, is option A, declination. Option B, variation. Option C, both A and B. Option D, none of the above. So you should know both of them. Then only you will be able to get the correct answer, right? Especially for your state service commission and PSC examinations, right? Next, right, let us try and discuss about the lines associated with declination. When I was talking about dipper, we had clinic lines. So with respect to declination, we have agonic lines, right, sir, and isogonic lines. So what do you mean by iso? Iso means same or equal. So what will isogonic lines will do? As the name suggests, they will join points that are having same or equal what declination. Whenever the declination values are equal, and if you join the points of equal declination by using a smooth line, the resulting line is what we call it as an isogonic lines. Then what would be agonic lines? Very simple, right? The lines of zero declination. The lines of zero declination is what we call it as our agonic line. So what do you mean by zero declination? What's the meaning of zero declination? So the meaning of zero declination is, if this is the direction of true meridian at my point A, what is going to be the direction of magnetic meridian? The direction of magnetic meridian will be the same. So the true meridian and magnetic meridians are coinciding. The true meridian and magnetic meridians are coinciding. That is what we call it as our zero declination or agonic lines. What do you mean by isogonic lines? As the name suggests, line joining points of same or equal declination. Now talking about this isogonic lines, please understand they are observed to be radiating from the magnetic north-south region. They are observed to be radiating from where? The magnetic north-south region, and they will take irregular path like this. They will take irregular path. It's not a smooth path, and also they will never form complete great circle. What do you mean by that? Right? Because what do you mean by that? It means that they will not, be very continuous. Right? At one random point it will stop. Okay, at one random point it will come and stop. Okay, so that is what I mean by does not make complete great circles. Okay, so please remember this. This was a previous year, prelims question, and radius from magnetic north and south regions. They form never complete great circles. That's it. So that is the declination. Okay. Now, what declination can change? So let us start with the radiations in declination. Okay. Yes. There seems to be some problem with the camera here. I'll turn off the video. Okay. Seems to be some problem with the camera, so I'm just turning off the video. So now let us talk about the different types of variations in declination. Right. Just give me a second. So it is nothing but the variation and declination over a period of 24 hours. So in every 24 hours, if you are measuring the amount of change that you see, that is what we call it as diurnal variation. So who is responsible for this? Who is responsible for this? Right. So please remember what happens in 24 hours. What happens in 24 hours? So in 24 hours, what happens is, right, the Earth will complete one rotation. So this particular variation is due to rotation of the Earth. Now, more importantly, what is the change, right, that we observe at different locations, different time periods, and at different duration in a year. So be very careful about this discussion. Please remember the diurnal variation, the daily variation is more during the daytime and less during the night time. What do you mean by this? See, the meaning is that in a given day, if I get 10 minutes of diurnal variation in a single day, today, if I observed, or rather we say yesterday, I measured 10 minutes of daily variation. Out of this 10 minutes, almost 8 minutes might have observed in the daytime, and the remaining 2 minutes is what I might get on the night time. That's the meaning. More on daytime, less during night time. Similarly, it is more on a summer day, okay, and less on a winter day. That means in summer, for one day, I got 10 minutes of change. In winter, I'll not get 10 minutes of change. I'll get something like, say, 6 minutes of change. So the daily change in summer is more than the daily change in winter. And the third one is, right, it is more at the poles of the Earth, more at the poles, and less at the equator. So when you go to the poles, right, the daily change will be very wide. Some 15 minutes change you might observe. But when it comes to equator, you see a small value of something like 2 or 3 minutes change. That's it. So the last point that we discussed now, there was a previous year, a question on ESE. Identify the following statements are true or false. Okay, in that one statement was like this. Daily variation is more at the lower latitude and less at higher latitude. Daily variation is more at the lower latitude and higher latitude. Is that more at the lower latitude and less at higher latitude? Is that statement true or false? Please tell me. Is my voice breaking? Yes, very good, Mahendra Reddy. Yes. No, the statement is false. The statement is false. Okay. Yes. Is my voice breaking? Yes. So 2 people are saying yes. Nobody. Yeah, then keep the audio off. I'll keep the video off again. Yes. So now let us see. Coming back to our discussion, you see, this is our Earth. What is the latitude of equator? Latitude at the equator is equal to 0. What is the equator latitude at poles? 90 degree north or 90 degree south. So it is more at the poles. So more at the poles means more at higher latitudes. Less at the equator means less at the lower latitude. So that statement what I told you is false. Okay. So like this they will frame questions. Okay. Yes. So that is daily variation. Next we have annual variation. So what do you mean by annual variation? Very simple. It is nothing but the change in declination over a period of 1 year of 365 days. Change in declination over a period of 1 year of 365 days. Why do we get this? This is due to revolution of the Earth. This is due to what? Revolution of the Earth, right? And please remember, it is found to be more on summer. In a year, the most change will be observed in summer, and the lesser amount of change is observed in winter. So in every year, if I'm getting 10 minutes of change, out of this 10 minutes again, like some 7 or 8 minutes will be happening during the summer, and the remaining portion will be what I'll observe on the winter. Right? That is annual variation. Next, third one is secular variation. What do you mean by secular observation? Please understand. See, whenever you take a particular observation for a very large duration of time, any observation you take for a very long duration of time, we will call that as a secular observation. Right? For example, India is a secular country. So you just think about this. Right? That's not the context here, but still, right, it's a very large, it's a very big country. Just like that, whenever you take an observation for a very long period of time, we can call it as secular observation. It is called as secular observation. Okay. But it's nothing but the variation in declination over a period of 150 to 300 years. Variation in declination over a period of 150 to 300 years. That much period of observation we take. And once we take this, it is observed that it is following a sinusoidal pattern. So it follows a pattern like this. It's like a sine wave pattern or a roller coaster pattern. So it appears to be periodic, but it is not. What do you mean by appears to be periodic? So you imagine this. This is zero declination. This is declination in the eastern side. This is declination in the western side. So initially the magnetic needle will be here, zero declination, and it will go towards the east for some 200 years. For some 200 years, it goes like this, and then it stops, and it will come back to its original position, and it will come back to its original position in another 100 years. In any 100 years, it comes back. So it is coming back, but not with the same time, with a lesser time or sometimes even greater time, and it goes to the western side for 50 years and comes back in another say 200 years. So you see what's happening. It is moving from left to right. It is moving from east to west, etc. But the point is, the period for which it is moving in one direction, nobody knows. Right? Nobody knows. Okay. So that's why it appears to be periodic in nature, but it is not having a constant period. Appears to be a periodic in time. Right? Now, the secular change is not uniform from year to year and not at a given place. That means, for example, in New Delhi, if I find a secular variation of 5 minutes, next year in Delhi, I will not get the same value. It will be another value for it. It will be a different value for it. Okay, now? Yes. Alright, and this is the most important variation because magnitude-wise, this is the highest. Okay, the magnitude of this particular variation is the most. So by default, when I'm saying there's a declination of 5 minutes or 5 degrees, that is mostly nothing but secular variation. That is mostly nothing but secular variation. Understand? Yes. So that is the discussion regarding the secular variation. Right. Next up, we have the last one, that is irregular variation. So what do you mean by irregular variation? Irregular variation mostly refers to the sudden changes in declination. What do you mean by this irregular variation? It is nothing but the sudden variations that we observe. It is nothing but the sudden changes in declination, mainly due to natural calamities like earthquakes, tsunamis, volcanoes, and cosmic events. Cosmic events means, see for example, on the surface of the sun, sometimes large explosions will take place. Okay, we call these particular explosions as what? Solar flares. Okay, and the explosions are happening, and due to this particular explosions, charged particles are released into the atmosphere. So these charged particles, due to the explosion on the surface of the sun, we call them as solar flares. Right? Yes. Now these solar flares, as they cross the atmosphere, they will change the magnetic field lines, for a small duration of time. Momentarily, they will disturb the direction of the magnetic field lines. That is what we refer to as cosmic events. That's it. Okay, so that's what we call it as the irregular variation. Please remember, these are the 4 different types of variations that we have: daily variation, annual variation, yearly variation, a secular variation, and a sudden or irregular variations. Okay, yes. So next, what we need to do is we need to discuss about a very important numerical here, that is the relationship between true bearing, magnetic bearing, and declination. So this is a very commonly asked numerical. In GATE examination also, recently they asked 2 questions from this particular concept, not directly but indirectly. At the same time, in engineering services, this is a pattern that they have been repeating, since so many number of times. So let us try and understand what is the relation here. Okay, yes. So please listen carefully. You imagine this is the direction of true meridian at a point. So this is my point A. Let me say this is the direction of true meridian at my point A. When I keep a magnetic needle at A, let me show you that the magnetic needle is showing me direction like this. What is this? This is the direction of magnetic meridian at point A. Okay. What is this? This is my line A. Right? This is my line A. So tell me, what is the horizontal angle the line makes with the meridian, with the magnetic meridian? What is the horizontal angle the line makes with the magnetic meridian? What is this angle known as? This angle is what we call it as the magnetic bearing of the line AB. So no. Similarly, what is the horizontal angle the line makes with the true meridian here? This is what we call it as the true bearing of the line AB. Now, what is the horizontal distances between, or the horizontal angle between magnetic meridian and true meridian known as? What do you call this angle as? We call this angle as declination. So from this, what is the value for the true bearing? Is equal to magnetic bearing plus declination. So now magnetic bearing plus declination. One more figure we consider. So this is the direction of true meridian at a point, say B or C. And when I keep a compass at C, the compass is showing me a direction like that. What is this? Direction shown by the magnetic meridian. What is this? This is a line CD. So tell me, what is the horizontal angle between the magnetic meridian and the line? Right, that is known as magnetic bearing of the line. What do you call this angle as? Call that angle as the true bearing of the line. The angle between true bearing and magnetic bearing. Now, please tell me, what is the angle between the true meridian and magnetic meridian? We call that as declination. We call that as declination. Okay. So from this, what is the relation? True bearing is equal to magnetic bearing minus declination. Right. So first time I'm getting the answer as what? Plus declination. Next time I'm getting it as minus declination. So if I combine these two, what is the answer I'm going to get? True bearing of any line is equal to magnetic bearing of the same line plus or minus declination. Plus or minus declination. So why did I get plus here? Because the declination is, you see, eastern declination. Why did I get minus here? Because the declination is western declination. So when will I use plus sign? Plus sign for eastern declination. When should I use minus sign? I should use that for western declination. So this is how we'll measure our true bearing. True bearing is equal to magnetic bearing plus or minus declination. This is how that particular calculation is done. Okay, now yes. Right. So let us try and solve one very basic problem here. Please try this. Any answers? With respect to what? With respect to declination. Oh, sorry, with respect to the true meridian. Okay. 131 degree 30 minutes. Okay. maybe was 120 degrees, right? When it was 120 degrees 10 years ago, at that time declination was 5 degrees 30. If the present declination is 60 degrees, that means declination has changed. If so, what is the new magnetic bearing of line? Can anybody please tell me what's the concept I should use here? Can anybody please tell me what is the concept I should use here? Anybody? Tell me in one word, what is the concept I should use here? Yes, very good, Kashmira. The answer is true bearing is always constant. Always constant. Whether it is 10 years ago or 15 years ago, true bearing is always going to be constant. So what's the formula for true bearing? Magnetic bearing of the line plus or minus declination. So magnetic bearing of 1 plus or minus declination 1 is equal to magnetic bearing 2 plus or minus declination. Right. If it is two different cases, I can use like this. Right. What is the first magnetic bearing given? 120 degrees. Plus or minus is plus 5 degrees 30 minutes. Declination is equal to magnetic bearing 2. They are asking us to find out what's the declination. 6 degrees plus to minus 6 degrees. So from this, what is the magnetic bearing of the line? 125 degrees plus 6 degrees, I get it as 131 degrees and 6 minutes. So this is the answer that I should get. Okay, this is the answer I should get. Okay. So the concept is that true bearing remains always the same, whether it is 10 years ago or whether it is 10 years after, or even if it is 100 years ago, the true bearing cannot change. Okay. So this is how you can find it. So they did not ask me to find the value of the true bearing, so I did not find the value of true bearing. If you want, you can find it. True bearing will be what? 125 degrees and 30 minutes. They did not ask me for that value, that is why I did not find it. So one less step, easier way or faster way of finding the answer. That is the logic. Yes. So this is how you solve the discussion on relationship between true bearing, magnetic bearing, and declination. Very commonly they asked in our ESC and also in state level service commission examination also they asked, also in NEET. Now there is another small numerical from this slide, actually a special case here. So that particular question will be framed something like this. A special question here will be framed something like this. Look at this question. Right, the magnetic bearing of sun at noon is equal to, right? The magnetic bearing of sun at noon is equal to 186 degrees. The question is, what is the declination at the face? This is the question. So if the magnetic bearing of the sun at noon is 186 degrees, if so, what is going to be the declination at that point of observation? Please tell me, do I know the relationship between magnetic bearing and declination? Yes, I know. Magnetic bearing is equal to, true bearing is equal to magnetic bearing plus or minus declination. You know that, yes. But to apply that, you should know the true bearing of the sun. Right? So tell me, what is going to be the true bearing of the sun? Let us try and understand that. Okay. So you imagine that. This is the observer's position. Let us just imagine that this is where the observer is sitting. Okay. So this represents the position of the observer. In fact, this represents the true meridian passing through the observer's location here. This is east, this is west, and this is south. What do you mean by 6 a.m.? Please tell me. What do you mean by 6 a.m.? 6 a.m. means sun is at the east. So this represents 6 a.m. Similarly, what do you mean by 6 p.m.? 6 p.m. means sun is setting. Sun sets in the west. So this is the position of sun at 6 a.m. and 6 p.m. But during 6 a.m. to 6 p.m., what is the sun doing? The sun is going from east to west. Where is the sun going? The sun is going from east to west. So this is the path taken by the sun, right, from east to west. This is the path taken by the sun from east to west. So if this is 6 a.m. and this is 6 p.m., at 12 noon, where is the sun? Exactly here, correct, midway. This is where the position of sun at 12. So this is the position of the sun at 12. Right, that's it. Okay. So tell me, if the sun is here at 12 noon, if the sun is here at 12 noon, okay, what is going to be the true bearing of the sun at noon? What is going to be the true bearing of the sun at noon? You see, from the true meridian, I measure it in clockwise direction like this. What is this? This angle is equal to 180. So tell me, what's the true bearing of sun at noon? The true bearing of sun at noon is equal to like 180 degrees. Okay, so it is equal to 180 degrees. So you can see, measure from north in clockwise direction like this. So what is the true bearing of sun at noon? 180 degrees. So the true bearing of the sun at noon is 180 degrees. What is the declination? Declination is equal to true bearing of the sun at noon. What is that? 180 degrees minus of magnetic bearing of sun at noon. So this will be the formula I can use. Right. So let us use that formula here and let us find the answer. Declination is equal to 180 degrees minus 186 degrees. But the problem is it is giving me minus 60 degrees. What do you mean by this? Declination is minus 60 degrees. Very simple. It is western declination. What is the answer? The answer is nothing but it is western declination. Yeah, yes. I'll give you one more data. You try and find me the answer here. Calculate the declination of the place if the magnetic bearing of the sun at noon is equal to 358 degrees. What is the magnetic bearing of sun at noon? Is equal to 358 degrees. So tell me right now, what is my solution? What's my solution? Is my solution 180 minus 358? The answer is no. Solution is not 150. Sorry, 180 minus 358. That is wrong. See, when I represented the position of the sun at 6 a.m., 6 p.m. and 12 noon, we have assumed the condition that the sun is traveling right towards the south end of the observer. This is the assumption we have taken. The sun is traveling right where? Through the south end of the observer. That is not necessary. The sun can travel like this also. The sun can travel like this also. So if the sun is traveling through the north end of the observer, exactly at 12 noon, where is the sun? Exactly at 12 noon, where is the sun? The sun would be exactly at where? At the north end of the reference meridian. At 12 noon, this is where the sun at the north end of the reference meridian. So if the sun is standing at the north end of the reference meridian, what is the true bearing of the sun at noon? The true bearing of the sun at noon is 360 degrees. So now, if you take the value as true bearing as 360, now my answer would be 360 degree minus magnetic bearing of sun at noon. Magnetic bearing of sun at noon. So if I use that formula, what's the declination? 360 degree minus 358 degrees. That is the question. Okay. Then what is the answer I'm getting? Plus 2 degree, or the answer is 2 degree east. Or the answer is what? 2 degrees east. Okay. So that is the formula. Yes, that is how our declination will be calculated. So declination is equal to either 180 minus magnetic bearing of the sun at noon or 360 degree minus magnetic bearing of sun at noon. So the question here is, how do you know which one to select? How do you know you go with the first equation, or how do you know you will go with the second equation? Please understand, you will get an information regarding that from your question itself. If the given magnetic bearing is closer to 180 degree, you go with the first equation. If the given value is closer to 360 degree, you go with the second equation. That's it. Okay? Yes. So if the given magnetic bearing of sun is closer to 180, you can use the first equation. If it is closer to 360, you can use the second equation. That's it. Okay. So this is how our calculation will be done. So please remember, depending upon where the position of the observer and the sun is, the true bearing of sun at noon, right, will be either 180 degree or 360 degree. Okay. Let me write down that particular point here. It is 0 degree or 360 degree. That's it. Right. So that is how you find our answers here. Okay. So if your given data is closer to 180 degree, use it. If it is closer to 360 degree, you can use the second equation. Right. Now please look at this particular question here. Calculate the declination at a place if the magnetic bearing of sun at noon is, first option is A, 180. Forget about this second question here. Now what we'll try to do is we'll just try and solve this. But how do we try and solve this? We'll try and solve this by using the figures. So by using figures, let us see whether we can solve this or not. By using figures, let us see whether we can solve it. So please try. Please try. Just simply draw a figure and try and find the answer. Let me see whether you can solve it or not. Any possibility of solutions? Yes, answer is 60 degrees, that I know. But how did you get it? That is my question. Did you use the equations or did you use the figures? Okay, so there is no way for me to know what you used. So what I'll do is I'll just draw it myself. So what is the magnetic bearing? Magnetic bearing is what? 186 degrees. It means if I take this as my magnetic meridian, if I take this as the magnetic meridian, okay. So what is the magnetic bearing of the sun at noon? It is 186 degrees. So from here, we measure 186 degrees. This is where the sun is. This is where the sun is. Okay. So the sun is having a magnetic bearing of 186. Now what will be the true bearing of sun now? The true bearing of sun will be what? It will be equal to 180 degree. Now? Yes. What is the meaning of that? True bearing of sun is 180 degree. That is equal to. Right. This is the true meridian. Right. True bearing of the sun is 180 degree means what? This is the understanding. The sun lies where? On the south end of the true meridian. Okay. This is the meaning. Okay. So the true bearing of the sun is 180 degree means this sun lies where? On the south end of the true meridian. So how does the sun looks like? This is how the true meridian will look like. Okay. And what is this much angle here? This angle is what we call it as 180. 190. That is the true bearing of the sun. Right. So magnetic bearing we represent, true bearing that we represent. Now what is the horizontal angle here? What is this horizontal angle that you see? That is your declination. What is the value? 60 degree. Correct. Now tell me, with respect to my true meridian, where is the magnetic meridian? Like this. So what is the meaning? It is west. Okay. So the meaning is that the declination value is equal to west. So the declination at this point is equal to 60 degrees west. That's it. That is how I use figures to find our answers. Okay. Yes. Please try this question. Let me see whether you can solve this or not. You can solve this by using equations as well as by using formulas. But we will solve it both ways. Please try and find the answer for this. Bearing of the line is equal to what? North 5 degree 30 minutes east. And the same line is having a true bearing of north 10 degree 30 minutes west. So the line does not change here, right? But the meridians are placed in such a way that the magnetic bearing is north 5 degree 30 minutes east and true bearing is north 10 degree 30 minutes west. Let me just try and draw this. Okay? Let me just try and draw this. I will first draw the magnetic meridian. I first draw the magnetic meridian. So you can see this is my magnetic meridian. Okay, right? And or rather, let me draw a true meridian first. Yes, we'll draw the true meridian here first. Okay, so you imagine that this is my true meridian. This is my true meridian, and no, this is my line AB. Okay, so what is the bearing of the line AB? Tell me. True bearing is not the 10 degree 30 minutes west. So my line AB is somewhere around here. So this is my line AB. A. What is the angle they are saying? This angle they are saying is equal to how much? 10 degrees and 30 minutes. 10 degrees and 30 degrees. 30 degrees. Okay, yes. Now tell me, the same line, the line AB does not go anywhere. Line AB does not go anywhere. True meridian will also not go anywhere. So these two lines that we drawn, they are fixed permanently. But what about the magnetic meridian? Does it remain the same? No. He can go and stand here. He can go and stand here. He can go and stand here like this. He can go and stand wherever he wants. Now for this given condition, where is he standing? What is the magnetic bearing of the line? North 5 degree 30 minutes east. What is the meaning of that? The line AB lies on the northeastern side of the magnetic meridian. Right? If you take the magnetic meridian, the line AB is where? On the northeastern side. So where will I draw the magnetic meridian? Should I draw like this? No. If this is my magnetic meridian, this is western. This is western side. No. The line is such a way that, right, it lies on the eastern side, northeastern side of the magnetic meridian. So how should be the magnetic meridian? This is how my magnetic meridian should look like. So this is how the magnetic meridian should look like. And where is the line? This is towards the east. So what is this? 5 degree 30 minutes east. Okay. So now the angle is equal to 5 degrees and 30 minutes east. Correct now? Yes. Now tell me, what is the horizontal angle between the true meridian and the line? What is the horizontal angle between the true meridian and the magnetic meridian? This is what we call it as declination. So what will be the value of declination from the figure? It would be 5 degree 30 minutes plus 10 degree 30 minutes. It should be 16 degrees. Where is the magnetic meridian with respect to the true meridian? It is towards the west. So the answer is what? 16 degrees west. Okay, the answer is 16 degrees west. This is how the solution will look like if I'm trying to figure. But nobody will ask you to draw figures, obviously. We can try and solve it without using the figures. Okay, so let us write down the whole circle bearing of the line. What is the whole circle bearing? True bearing, magnetic bearing is 5 degree 30 minutes. What is the whole circle bearing of the true bearing? North 10 degree 30 minutes west. So 360 minus 10 30. 360 minus 10 is 350. Minus 30 minutes is 349 degrees and 30 minutes. Okay, so how will I write the declination here? True bearing of the sun minus magnetic bearing of the sun. So here also I write true bearing minus magnetic bearing. That is declination. So true bearing is 349 degrees 30 minutes minus magnetic bearing is 5 degrees 30 minutes. So what is the meaning? You get the answer as 344 degrees. So in whole circle bearing systems, you are getting the you're getting the declination as 344 degrees. So this is my true meridian. The meaning is from this true meridian, if you measure an angle of how much? If you measure an angle of 344 degree, that is where you get your magnetic meridian. That is where you are getting your magnetic meridian. That is the understanding. But please understand, like we don't say the declination as measured from north in clockwise direction. No. Like so in this particular example, what would be your final answer? This will be your final answer. So this is 60 degree measured distance. This is 60 degree measured distance. These are two different ways of solving this. I hope you are familiar with this. So that's it. That's it for today. Tomorrow when we come back, we will start our discussion on local attraction. Very, very important. And regarding tomorrow's class, actually, there might be. No? Yes. Okay. Right. So let us. There's a small audio show. Expect the picture. Okay. So let us start our class. Okay. Yes. So today's topic is going to be first topic that we will discuss is regarding local attraction. Okay. So we are talking about compass survey. Okay. And the last portion that we need to discuss is regarding the local attraction, as well as the two compasses that we use in our compass survey. Okay. So these are the two last discussions that we have to do. Okay. Yes. So let us begin. Can you please tell me what you mean by local attraction is? Can you please tell me what is meant by local attraction is? Anybody? Good morning. Good morning. What is meant by local attraction? Any answers? See, please understand. Local attraction is nothing but the deflection of the magnetic needle. Right? What is meant by local attraction? It is nothing but the deflection of the magnetic needle. And why does the magnetic needle deflect? Due to the presence of magnetic materials. Okay. So you imagine that you are bringing your compass near a magnetic material. Okay. So whenever a magnetic material comes towards the needle, what will happen? Two things can happen. Number one, either the needle will be attracted to this magnetic material, or the needle will be deflected by this magnetic material. Okay, it will be attracted or repelled. Whatever of these two happens, the needle is going to change the direction. Yes, the needle is going to change the direction. With this change in the direction shown by the magnetic needle is what we call it as local attraction. So what you see here, what is meant by local attraction? It is nothing but the deflection of the magnetic needle due to the presence of local magnetic fields. Due to the presence of local magnetic fields. That is what we call it as local attraction. So imagine that this is your magnetic compass. This is the magnetic needle, right? And imagine to this particular magnetic needle right now, local attraction is coming. Locally, a local magnetic field is coming. So due to the presence of this local magnetic field, this is a local magnetic field. It may be due to a particular magnetic object or due to some magnetism. What will happen to the needle? The needle will slowly change the direction. So you see, this was the initial direction of the needle, but now due to local attraction, like what happens? The needle is rotated and it shows this as the direction of the magnetic meridian. So there is an error in the direction. This error is what we call as local attraction. This error is what we call as local attraction. Can you give me some examples of such materials that can create local attraction? Can you give me examples of any such material that can cause local attraction for us? Right. Examples of this particular material, yes. I can say like this: steel pens, like whatever you're having in your hands. Okay, steel pens are examples. Steel watches, right? Steel pens, steel watches, ornaments that you wear. Okay, keychains, key bundles. These are all examples of materials that are capable of producing local attraction. So these examples, what I told you, we collectively call them as metallic objects. What are metallic objects? Steel pens, steel watches, right? Keychains, key bundles, the ornaments that you wear. Collectively, we call them as what? Metallic objects in our survey. Okay. So let me ask you a small question. Let me frame a small question here. Okay, this is my question, right? So local attraction is due to option A, wind, option B, gravity, option C, metallic object, and option D, none of the above. So these are my question. These are the four examples. Can you tell me what is the answer for this? What is the answer for this? You see, the answer for this particular question is what? It's nothing but our option D, none of the above. The answer D, none of the above is the correct answer. See, the answer is option C, metallic object. I need not ask you this. Right? I need not ask you this question. The answer is not metallic object. That's the reason why I'm asking you this question. Right? So why is the answer not metallic objects? Because you think about this. You know that the metallic objects like steel pens, steel watches, keychains, etc. If you keep near your compass, they will create local attraction. Then as a good surveyor, are you supposed to keep those particular materials there? if you know that the steel pen near my compass will create local attraction, will you keep it there and say, sir, I'm having local attraction? No. If you say that, I'll say that you're a bad surveyor. Right? That makes you a very bad surveyor. If you know that this creates local attraction, a good surveyor is expected to eliminate it. So can you remove that steel pens, steel watches, key chains, etc. from the surroundings of a compass? Yes. So please understand, these metallic objects are avoidable objects. These metallic objects, whatever the examples that we wrote or discussed, these are nothing but avoidable objects. And please remember, in our local attraction or in our discussion regarding local attraction, right, these avoidable materials should not create local attraction. Right. So if you know that this creates local attraction, you avoid it. Now, if this local attraction is due to this avoidable materials, then that is treated as a mistake from your side. Okay, right. Please understand, local attraction is not due to avoidable materials. The effects of unavoidable materials is what you should call it as local attraction. Okay, so please read this. So the effects of metallic objects like steel pens, steel watches, key chains, key bundles, ornaments, etc. are expected to be eliminated by the surveyor. Right, because these are all avoidable materials. Then what should create local attraction? Only the effects of unavoidable objects like transformers, high voltage transmission lines, buried steel pipes, etc. and naturally occurring metallic mineral ores should be considered. Okay. So imagine that you are doing your compass surveying here. Okay. You're doing your compass surveying here, but just nearby your location, there's a high voltage transformer. Okay. So there is a high voltage transformer present here like this. Due to this particular high voltage transformer, what will happen? Will I get some local magnetic fields? Yes. I will definitely get some local magnetic fields. Due to this local magnetic fields, will I get local attraction? Yes. Right now, is the transformer an avoidable material? Can you eliminate the transformer from your location? No. If you try to eliminate the transformer will eliminate you. That is a problem. Okay. It is an unavoidable material. So is my high voltage transmission line. So if there's a transmission line carrying 220 kV, right, is going above your head, right, 220 kV is going above your head, will you get local attractions? Yes. There will be local magnetic fields, due to which there will be deflections in the needle. There will be local magnetic fields, due to which there will be deflections in the needle. Okay. Right. So due to this also we can get, effects of local attraction in our needle. Understand? Yes. Can you eliminate that 220 kV transmission line? No. Right. Like just like that, if there is a buried steel pipe in your location, there's a steel pipe buried beneath your location, followed by what if there is a metallic structure near you? For example, you are doing compass surveying near Eiffel Tower. Right. So due to the Eiffel Tower, will I get local attraction? Yes. Will I be able to eliminate it? The answer is no. Understand? Right. So these are things that we are unable to avoid. And one example of natural source of local attraction would be the metallic mineral ores. Okay. Whatever metallic mineral ores that are present inside the Earth's surface, if it is magnetic, it can create local attraction for us. These are all unavoidable objects. So their effect is what we call it as local attraction. That's it. So that is the introduction towards local attraction. Now let us see how we can detect local attraction. How is it possible for me to detect local attraction? Let me just draw a small line here. So imagine we are having a line here AB. Okay. Right. So this is the direction of magnetic meridian A. This is the direction of magnetic meridian B. Okay. Okay. So this is a small line here. I can call it as line AB. Right. Tell me, what do you call this angle as? What do you call this angle as? Please tell me. What is this known as? This is known as the forebearing of the line AB. This is known as the forebearing of the line AB. And what is this? You see, this is known as the backbearing of the line AB. Yes or no? Yes. So that is the forebearing of the line AB and as well as the backbearing of the line AB. Yes or no? Yes. Now tell me, for this particular condition, tell me what is the difference between the forebearings and backbearing will be? Can anybody please tell me what will be the algebraic difference between or the magnitude of difference between forebearing and backbearing is? Tell me. Right, very good, Praveen. Anybody else? Come on, one more answer give me. Yes, very good. So in this particular example, the difference between forebearing and backbearing is exactly equal to 180. Yes. Now let us imagine that. Okay. There is a small local attraction present here. So there is a small local attraction coming here like this. Due to this local attraction, what is happening to my needle? Let me say that the needle is going to be deflected. Due to this local attraction, you see, from the original direction, the needle is going to be deflected like this. From the original direction, the needle is going to be deflected like this. So now tell me, like we have lost the original position, yes or no? This initial position is gone. This position is gone. Now I am going to measure my backbearing from where? Will I measure it from the original position? No. You see, this was my original position. I use dotted lines to represent that. So you see, this was the original position of the magnetic meridian. But that particular position is lost now due to local attraction. And now if I want to measure the backbearing, from where I'll measure it? I'll measure the backbearing from this actual meridian. Okay, so this is the actual meridian, magnetic meridian in the field. Why we are taking the actual meridian? Because the correct magnetic meridian has been deflected. So this was the correct magnetic meridian, but due to this local attraction, what happened? It has got deflected like this. So my field, in my field, I'm having that actual meridian only. Now I end up measuring the backbearing of the line from that actual meridian. If so, under this condition, please tell me, what will be the difference between forebearing and backbearing? What will be the difference? Will it be equal to 180 degree, right, or not equal to 180 degree? Will it be equal to 180 degree or not? The answer is no. Now they are no longer, the difference is equal to 180 degree. Okay. So if I give you a line, if I give you the forebearing and backbearing of a line, to see whether you are having local attraction or not, what do you need to do? Just take the difference between forebearing and backbearing. So if the difference between forebearing and backbearing of a line are not equal to 180 degree, there exists local attraction. There is local attraction present. Now, right, for a random line, say xy, if the difference is not equal to, difference between forebearing and backbearing is not equal to 180 degree, right? Can you please tell me which station is affected by local attraction? Which station is affected by local attraction? Is it station x or station y? For a line xy, forebearing, backbearing difference is not equal to 180 degree. So which station will be affected by that? Can you say? The answer is no, you cannot say. Okay, the answer is yes, you cannot say. Very good. Because it may be at the station x, or it may be at the station y, or it may be due to the fact that both x and y are affected by local attractions. There is local attraction at x as well as there are local attraction at y. Okay, now, yes. So that is the point. Let me just write down. either any one of the station or both the stations are affected by local attraction. Yes. Okay. That is a detection between local attraction. Now, when it comes to the correction of local attraction, let us see what are the different methods. Detection is over. Let us talk about corrections. Now, corrections can be done in two ways. Like first one is method one, which is also known as Baring's method. First method is what we call as Baring's method. Yeah. Correction. Method one is by Baring's method, and method two is by input angle method. Right. For your GATE and your ASC examination prelims point of view, Baring's method. Now, method one is slightly more important. More details about method 2. The theory behind method 2 is also very important for your GATE and ASC prelims point of view. For PSC point of view, these things are not very important. But anyway, let us try and discuss. Okay, right. So, what is Baring's method? Right. See, Baring's method has a fundamental assumption. Baring's method has a fundamental assumption all throughout this particular chapter. Okay. What is that particular assumption? Let me write down here. Okay, so there's a fundamental assumption in our Baring's method. What is that assumption? The assumption is that, you see, the difference between forbearing and backbearing are not equal to 180 degree only due to local attraction. Okay, so this is the fundamental assumption. The difference between forbearing and backbearing between two lines are not equal to 180 degree, and this is only due to local attraction. This is only due to local attraction. That's it. Let us understand this. Okay, so whenever we are doing our traversing, our field book will look something like this. We are having lines A, B, B, C, C, D, D, etc. And what is given? Forbearings and backbearings of all the lines are given. Forbearings and backbearings of all the lines are given. Right. So, right. Can you see that? Are the difference equal to 180 degree? So, you look at the line AB. If you take the difference, will I get 180? No. Line BC, will I get 180? No. So, the differences are not equal to 180. And in the Baring's method, what is the fundamental assumption? The fundamental assumption is that this differences are not equal to 180 degree only due to local attraction. No other, factors are playing a role there. Understand? Yes. So, now let us try and understand what are the different steps we should follow to apply corrections. So, there are basically, 4 steps that we need to follow to apply corrections to the Baring's of all the lines. What is step number 1? Step number 1 is very easy. You find out the line that is free from local attraction. Right. Just look at all the given data, forbearing, backbearing for all the lines. And step number 1 is to identify, is there any line that is free from local attraction? How do I know that? Just take the difference between forbearing and backbearing. If the differences are equal to 180, there is no local attraction present. So, looking at this traverse data, can you please tell me which is the line that is free from local attraction? Tell me. Yes. 2 people have already given me the answer. Yes. Very good. So, the line CD is the one that is free from local attraction because the difference between forbearing and backbearing of that particular line is equal to what? 180. Okay. So, the difference between forbearing and backbearing of CD is equal to 180. Okay. So, please tell me. So, if the line CD is having no local attraction, think carefully and answer. Okay. If the line CD is having no local attraction, what can you tell me about the station C and D? What can you tell me about the station C and D? If A and D are C and D, sorry, if the line CD is free from local attraction, what can you tell me about the station C and station D? Are they free from local attraction? Yes or no? Are they free from local attraction? Yes or no? The answer is yes. Yes. C and D both are free from local attraction. Yes or no? Yes. We can consider both station C and D are free from local attraction. Due to this, I can also say that whatever angles I observe from C and whatever angles I observe from D, both these angles are also free from. All those angles are also free from local attraction. Okay. Let me say this once again. In this example, line CD is free from local attraction, which means station C and station D, they are also free from local attraction. Station C and D are also free from local attraction. Right? That means whatever angles I observe from C and whatever angles I observe from D, both of them are free from local attraction. So, can you please identify what are the readings I take from C and D? Other than the 100 and 280 degree, can you identify any other readings that are free from local attraction taken from C and D? Come on. Yes. What are the angles? DA? No. What about DA? See. Right. So, I can select this. I think you are getting the idea. So, right, the station C and D are free from local attraction. That means all readings I take from C and D are free from local attraction. So, what are the other readings I take from C? You see, backbearing of BC, yes or no? Yes. Backbearing of BC is taken from C, that is free from local attraction. Similarly, forebearing of DA is taken from D, that should also be free from local attraction. Okay. So, by the end of step number 1, we are identifying that there are 4 readings that are free from local attraction. By the end of step number 4, we are identifying that there are 4 readings that are free from local attraction. Yes or no? Yes. So, this line CD is free from local attraction. Station C and D are free from local attraction, which means all readings I take from C and D are free from local attraction. That's it. Okay, now? Yes. So, what is the next step? So, you see, if the correct backbearing of BC is 300 degree, the correct backbearing of BC is 300 degree, what should be the correct forebearing of this line? Can you tell me? Yes. So, the correct backbearing of which line? BC is equal to what? That is already identified as 300 degrees. If so, what should be the correct forebearing of line BC? What should be the correct forebearing of the line BC? We know it should be 300 degree minus 180 degree. I should get the value as what? 120 degree. This should be the correct value, right? But what is the measured value? What is the measured forebearing of line BC going to you? Please look at the data. That is 121 degree. So the correct value is what? 120 degree. But what is the measured value? What is that? It is 121 degree. So is there error? Yes or no? Yes. There is definitely error there. But error is at which station? At station C or station B? But error is at which station? Where will I measure forebearing of BC from? I will measure forebearing of BC from where? From B. So this is the error at my station B. What is the error? Measured value 121 minus correct value 120. The error is equal to plus 1 degree. Right? Then tell me what is the correction I need to apply at B? The correction I need to apply at B is what? Minus 1 degree. Right? So this is the second step. Once you identify the readings that are free from local attraction, calculate the correct opposite bearing. Calculate the correct opposite bearing. Okay? Yes. Calculate the correct opposite bearing. Now using this correct opposite bearing and the measured bearing at that station. Right? What do? You find out the error at that station and you find out correction required at that station. So what is the correction required? The correction required is minus 1 degree at which station? At the station B. So what do you understand from that? What you should understand from that? Right? You should understand that whatever readings I take from B, all those readings should be corrected by minus 1 degree. Whatever readings I am observing from B, all those particular readings should be given a correction of minus 1 degree. Tell me, is there any other reading I take from B? Yes or no? Is there any other reading I take from B pointer? Tell me. Any other reading I take from B? Tell me that angle value here. Yes, very good. Yes, so what is the angle I measured from B? The back bearing of AB. The back bearing of AB is measured from B, right? So what is the correct back bearing? Yes. So therefore the corrected back bearing of AB is equal to what? 201 degree minus 1 degree. You should get it as 200 degrees. Okay. So the required correction is minus 1 degree. Apply the correction of minus 1 degree here. What is the correct value? 200 degree. So now what you need to do is repeat the previous step. Tell me, if 200 is the correct back bearing of the line, what should be the correct forebearing of AB? Right? If 200 is the correct back bearing of the line, what should be the correct forebearing of the line AB? Yes, very good. It should be 200 minus 180. I should get the value as what? 20 degree. So the correct forebearing of the line AB should be what? 20 degree. Correct forebearing of the line AB should be what? 20 degree. But what's the measured value? 18 degree. So tell me, is there error there? Yes, definitely there is error. Tell me what is the error at the station A? Tell me what is the error at station A? Measured value is 18. Correct value is 20. Then what is the error at the station A? Right? Yes, very good. The error at station A is what? Minus 2 degree. Absolutely correct. Then what is the correction I need to apply? The correction I need to apply is plus 2 degree. Right? So at which station? At station A. So please remember, from this we'll understand that whatever angles I am observing from A, for all the angles observed from A, I should give a correction of plus 2 degree. Is there any other angle I observe from A? Please tell me. Come on fast. Is there any other angle I observe from A? Yes, very good, Aditya. Anybody else? Yes, very good, Tanvir. Tanvir, you simply say the line I will not understand. Say back bearing of DA or forebearing of DA. Okay. Right, very good, back bearing of DA. Yes. So the back bearing of DA, is observed from A, and what is the correction I need to apply there? Plus 2 degree. So if I apply plus 2 degree, what is the correct value here? 230 degree. So again, repeat the procedure. If 230 degree is the correct back bearing of DA, what should be the correct forebearing of DA? The correct forebearing of DA should be what? 230 degree minus 180. I should get the value as 50 degree. But this 50 degree is already identified as correct value. So what I can say, therefore, check that. Right? Already identified as correct value. Therefore, what I can write? I can write the answer is check that. Okay, that's it. So these are the different steps involved in our direct method. I'll repeat this once again. So please listen carefully. Okay. So what is the first job? First step is from the given traverse data, you need to identify the line that is free from local attraction. So identify the line that is free from local attraction. In this case, what is that line? That line is CD. Difference is equal to 180. So once CD is free from local attraction, whatever readings are observed from C and D, all those readings are also free from local attraction. So the back bearing of DC is free from local attraction. The forebearing of DA is also free from local attraction. Now if 300 is the correct back bearing of BC, what should be the correct forebearing of BC? 300 degree minus 180. I should get the value as 121 degree. So the correct value is 120 degree, but the measured value at that station is what? 121 degree. So what is the error? Measured value 121 minus 120. So the error is plus 1 degree. And what is the correction? The correction required is minus 1 degree. But where I should apply this correction? In which station? C or B? That particular correction needs to be applied at station B. Which means that all observations I take from B, whatever angles I observe from B, all those angles have to be corrected by an angle of minus 1 degree. So the back bearing of AB is measured from B. Apply the correction of minus 1 degree. Corrected value will be 200 degrees. Now you repeat the process. Last 2 steps you keep on repeating. Yes or no? Yes. So that's a very simple discussion. Let us talk about the particular points one by one. I hope that is clear. Yes or no? Is it clear? Yes, very good. So now let us look at the steps here. Step number 1. Identify a line that is free from local attraction. Yes. Step number 2. Starting from a bearing free from local attraction, calculate the correct opposite bearing. Starting from a bearing free from local attraction, we need to find out the correct opposite bearing. Right. What is step number 2? Using the correct bearing and measured bearing at that station, calculate the correction required at that station. Yes or no? Yes. Okay. Now what is the next step? Apply this correction to all bearings measured from that station. That's it. Now what do? You have a corrected value. Repeat the procedure. You just need to repeat the procedure. That's it. This is what you want to do. Okay. Now, very simple procedure. That is what we want to follow. So please look at this problem and try and solve this. Okay. This is the problem from your classroom practice only. So they are only asking you for one value, right? But what we'll do is we'll apply for the entire traverse. Okay. So please take your time, right? And no need to write any steps. This is not our university examination. So with simple amount of steps, try and find out the corrected bearings for all the lines, not just for any one line, for all the lines, and see if the check is satisfying or not. Please proceed. start. Okay. So tell me, which is the line that is free from local attraction? The line that is free from local attraction is nothing but our line D. See here, 15, 30, not balance, 15, not balance, 30, 15, not balance, 15, 15, yes, 8, 8, 0, 25 minus 7 is nothing but 18. It's also 15, 30 is not balance. So just by looking in that particular perspective, I can clearly say that the line DA is free from local attraction. Right? So that means these angles are free from local attraction, and also the back bearing of CD free from local attraction, and because it is taken from D, forebearing of EA is also free from local attraction because it is taken from E. Now next up is starting from the bearing that is free from local attraction, calculate the correct opposite bearing. So let us assume that, let us consider starting from 161 degree 30 minutes. If I'm starting from 161 degree 30 minutes, what should be the correct back bearing of the line? Sorry, forward bearing of the line. 161 30 plus 180 degree. I should get the answer as 341 degrees and 30 minutes. So that should be the answer. I should be 341 degrees and 30 minutes. One second. 341 degrees and 30 minutes. That should be the value I should get. But what is the measured value? 340 degrees and 15 minutes. So tell me, what is the correction I need to apply to this measured value? To this measured value, if I add 15 minutes, okay, to this measured value, if I add 15 minutes, it becomes 340 degree 30 minutes. To that, I need to add one more degree. So the correction I need to apply is plus 1 degree 15 minutes at station C. What is the meaning of that? All the bearings observed from C requires a correction of plus 1 degree 15 minutes, which means the back bearing of BC requires a correction of plus 1 degree 15 minutes. So after applying the correction, what is the value? That value will be, you see, 228 degrees and 30 minutes. Now, if that is the correct back bearing, what should be the correct forebearing? 228 degrees 30 minutes minus 180. I should get the value as 48 degrees 30 minutes. So that should be the correct value here. But what's the measured value? The measured value is 49 degrees. So how much correction I need to apply to the measured value? From this measured value at B, I should reduce 30 minutes. I should reduce 30 minutes. So 49 degree minus 30 minutes. I get 48 degree. So the correction is what? Minus 30 minutes. Where I should apply this to all readings are taken from B. So I'll apply it at the back bearing of AB. Then what is the corrected value I'll get? The corrected value I'll get is 307 degrees and 15 minutes. 307 degrees and 15 minutes. Right. Now reduce 180 from that. It should be 127 degrees and 15 minutes. Right now? Yes. It should be 127 degrees and 15 minutes. Okay. That's it. Now, what should be the correction I need to apply? To this particular angle A, the correction I need to apply is what? 126 degree 30 minutes. To this particular value, if I apply correction of plus 30 minutes, what will happen? Plus 15 minutes. Okay. It becomes not 15 minutes, now 45 minutes. To this 126 degree 30 minutes, if I add 45 minutes, okay, will I get the value? 127 degree 30 minutes? 15 minutes? Yes. Because 126 degree 30 minutes plus 30 minutes is 127 degree. To that I need to add 15 more minutes. So that is 45 minutes total. 30 plus, that is the required correction at A. Where should I apply this correction? To all readings are taken from A. So the back bearing of EA requires a correction of plus 45 minutes. After applying the correction, what will be the corrected value? The corrected value will be 32 degrees and 15 minutes. So if 32 degrees and 15 minutes is the correct back bearing, what should be the correct forebearing? 32 degree 15 minutes plus 180. So 2 degree 15 minutes will come. 18 plus 3 is what? 21 degrees. So what we can write? Therefore check. We can write like this. Therefore our answer is check. Okay. Because that value 212 degrees 15 minutes is already identified as a correct value. That's it. Are you able to get these values, yes or no? Are you able to understand that, yes or no? Yes, very good. So Praveen has asked one question. What if no such line is there that is free from local attraction? It's a very good question. It's a very good, genuine question. But I'll come to that point. See, if none of the lines are free from local attraction, you need to identify the line that is differing the least from 180 degree. Take that least difference from 180 degree, distribute half of it to the forebearing of the line, half of it to the back bearing of the line. This becomes the line that is free from local attraction, and then you proceed. That is only required for our engineering services mains point of view. For our prelims point of view and for our gate point of view, absolutely not required because it's a very lengthy procedure. Okay, yes, please remember that. Okay, right. So when it comes to our ESE mains, we have to discuss about the condition where no line is free from local attraction. Okay, now yes. So that is about our method 1. I think now you are very comfortable with method 1. Now we can go to our method 2. We can go to our method 2. So what does the method 2 talks about? Method 2 talks about the included angle method. Method 2 talks about the included angle method. So what is the concept behind this included angle? To understand that, I will make use of a small figure here. Okay. So please listen to this discussion very closely and try and find the answers I'm asking you to. Okay. Right. So you imagine that you're having a station here, like this say P. This is a station here, say P. From this particular station P, let us assume that there are two lines here, say PQ. What are the lines that we are having? The lines we are having is PQ. And the line that we are having is PR. PQ and PR. What is the forebearing of the line PR? The forebearing of the line PR is say theta 2. This bearing is what? This bearing is theta 2. What is this bearing? This bearing is equal to theta 1. Right. So the bearing of the line PQ, right, is theta 1. The bearing of the line PR is theta 2. What is the included angle theta here? Can you please study? It's very simple. Yesterday only that we discussed. It is theta 2 minus theta 1. Correct now? The difference between the bearings, the included angle between the lines are theta 2 minus theta 1. Yes. Now imagine I am going to introduce a local attraction here. Imagine that I am going to introduce a local attraction here, due to which let us assume that the needle has rotated some plus x degrees. Needle has rotated by some plus x degree. What do you mean by plus x degree? In the clockwise direction. If I'm saying it is minus x degree, means it is in the anti-clockwise direction. So due to this local attraction, there is a reflection, rotation in the needle of how much plus, x degrees. So what will happen? The new needle or the new magnetic meridian will look in this particular manner. Right? The new magnetic meridian will be looking in this particular manner. So that is the new magnetic meridian or the actual meridian I can get. Right? So after the x degrees of local attraction, this is how the actual meridian is going to look like. So this is the actual magnetic meridian. This was the correct magnetic meridian. Okay, now yes. Now tell me, due to this particular reason, right, what will happen to the bearings of the line PQ and QR? So the original direction is lost. So I'll just fade it out like this. Right, that's it. Okay, so now that the needle has reflected, what will be the bearing of the line PQ now? So from the actual meridian in the field, you will now measure the bearing towards the line PQ like this. So this is the new bearing of the line PQ, I call it as theta 1 dash. And similarly, what is this? This is the new bearing of the line PR, I call it as theta 2 dash. Okay, so you can observe, what you observe is, once that particular local attraction has happened, the bearing of the line PQ and the bearing of the line QR are changing. So the bearing of PQ changed from theta 1 to theta 1 dash, and the bearing of the line PR is changing from theta 2 to theta 2 dash. Please tell me, right? Are the change in the two angles the same or different? Are the bearings of the two lines changing by the same amount, or are they changing by different amount? Please tell me. Are they changing by the same amount, or are they changing by different amount? Very good, Raveen. Nice, very good, Tanvi. The answer is correct. So the change that we are observing in both the bearings are same, okay, or equal. So this is the first point that you should understand. Whenever a station is affected by local attraction, whenever any station is affected by local attraction, what will happen to the bearings observed from that station? The bearings observed from that station are going to change, but the important point is all bearings are equally affected. What's happening? All the bearings are equally affected. Yes or no? Yes. Right. So whatever change you are observing, if there is 5 degree change in the bearing of PQ, the same 5 degree change will be observed in the bearing of the line PR also. If so, if that is true, can you please tell me, if I take the difference between the new bearings, say theta 2 dash and theta 1 dash, if I take the difference, what will happen? What will happen? What will be the value of theta 2 dash minus theta 1 dash? Right. What is the value of theta 1 dash, theta 2 dash and theta 1 dash? Very good. It will also be the same value. It will also be the same value. So this is before local attraction, this is after local attraction. So you see what is happening. Even if local attraction is present, the included angle formed at that station is not changing. The included angle formed at that station is not changing. Because what is ultimately the included angle theta? Included angle is nothing but the angle between the two lines. Yes or no? Right? Included angle is nothing but the angle between the two lines. When I'm saying that there is local attraction, the lines are not changing. The lines are not going anywhere. Absolutely not. Only the meridian is changing. So if the meridian changes, the bearing changes. But the angle between the lines should remain the same. Okay, so please remember, included angle is the angle between the lines. If the local attraction is present, meridian will change. If meridian changes, then bearings of the lines will change. But both for all lines, the change will be the same from a single station. Therefore, what I can say, the included angle remains unaffected. What I can say is that the included angle will remain unaffected. So yes. Okay, so that is one major important concept for us. Let me extend that concept forward. PQRST. So this is a closed traverse I'm giving you, right? Let us assume that the included angle at P, Q, R, S and T. I know all the included angles at P, Q, R, S and T. Now you imagine that at my station P, there is a local attraction of L1. Due to which, is there any change in the included angle at P? No, absolutely not. There is no change in the included angle at P. Similarly, now you imagine there is another local attraction at Q, LQ. Will it affect my included angle at Q? No. Similarly, there is a local attraction at the point R. Will it affect my included angle R? No. Will the local attraction at the station S affect the included angle? No. Will the local attraction at present T, will it affect the included angle at T? The answer is again no. Right. So you see, look at this particular closed traverse and tell me what is happening. Each and every station of this particular traverse, is affected by local attraction. So no, each and every station of this particular traverse is affected by local attraction. Yes. But tell me, are the included angles affected? No. The included angles are not at all affected. Then, please listen carefully and answer. Then, will the arithmetic check for included angles be satisfied? Yes or no? If none of the included angles are changing, should the arithmetic check for included angle satisfy or not satisfy? Please tell me. Should it satisfy or should it not satisfy? Please tell me. Should it satisfy or should it not satisfy? Yes, very good. It should satisfy. So you see the conclusion. Even if my traverse is having local attraction, even when my traverse is having local attraction, the included angle arithmetic check should be satisfied. Yes or no? The arithmetic check for included angles should be satisfied, even if local attraction is there. Now, for any reason, right, if the included angle arithmetic check is not satisfied, what is the meaning of that? The meaning is that the traverse is having local attraction, yes, but it does not affect the included angles. But if the included angles are affected, it means that your traverse is having local attraction and some extra errors. Local attraction as well as some additional errors are present. Example will be your instrumental errors. Understand? And at this point, my method 1 fails. Right? At this point, method 1 fails. Why? Because remember, what is the fundamental assumption in method 1? The difference between the bearings are not equal to 180. It is only due to local attraction. But we just applied the arithmetic check and we realized that in my traverse, we are having errors other than local attraction. So at this point, the assumption is not valid. Therefore, bearings method is not applied. Okay? Bearings method cannot be applied. So please remember, right? Bearings method will fail if the arithmetic check for included angle is not satisfied. Understand? So that is our discussion regarding the included angle method. So you see here, what are the points? If a station is affected by local attraction, all bearings are affected equally. Therefore, included angles remains unaffected. In other words, the arithmetic check for included angles should be satisfied. If it is not, there are errors other than local attraction present in the tabs. Say instrument errors. Okay. At this point, what happens? Our bearings method will fail. At this point, bearings method fails. The solution is only suitable for our included angle method. So from this, I can again conclude that bearings method is method 1. Bearings method is best suited for open traverse. And method 2 is best suited for closed traverse. Right? Is best suited for closed traverse. Why? Because please understand, arithmetic checks are only there for my closed traverses. Arithmetic check is required only in included angle method. So in the included angle method, the best choice of traverse will be closed traverse because you can apply checks. So the best situation for method 1 would be our open traverse. That's it. Okay. But please understand, if the arithmetic check is satisfied, if the arithmetic check for included angle is satisfied, you can go with any of the two methods. Both of them will give you the correct answer. Yes. So let me explain what are the different steps involved for our included angle method. Step number 1 is to calculate included angles. First method is to calculate included angles. Okay. After that, what you do is you need to apply checks. Check. Okay, arithmetic. Now, if the check is not satisfied, you calculate what is the error required. How do you calculate the error required? So you see, you added the angles here, and the sum of the angles are coming as say 540 degrees and 1 minute. You got the 540 degrees and 1 minute. That is the sum of the angles A plus B plus C. But the formula say 2n minus 4 into 90 degree. That formula has given you the value as 540 degree. Okay. So what is present here? Error is present. So what is the error? Measured value 540 degree 1 minute minus correct value is what? 540 degree. So the error is equal to 1 minute, and the correction required is equal to what? Minus 1 minute. What is the correction per angle? Correction per angle is equal to, see, we are assuming that we are having 5 sides. Then what is the value? Minus 1 minute by 5. That is equal to 20 seconds. How much? Minus 20 seconds. Okay. Step number 3 is to calculate corrected included angle. Right? Corrected included angle. That is step number 4. What is step number 3? What is step number 4? Starting from a line that is free from local attraction, using this included angle, recalculate all the bearings. Okay. So starting from a line free from local attraction, local attraction, plus this corrected angle, you need to recalculate all the bearings. These are the different steps. This will minimum take you 30 to 35 minutes. This particular entire procedure will take you minimum 30 to 35 minutes. So tell me, will they ask you this particular discussion in your GATE examination? No. This is not at all important for GATE. It is important only for your ESE mains examination. So please remember, the included angle method is mostly important for our ESE mains preparation. Okay, ESE mains preparation. But the theory behind this particular included angle method, that is important for us to do. So let us just calculate all the bearings. Starting from a line that is free from local attraction, using this included angle, recalculate all the bearings. Okay, so starting from a line free from local attraction, local attraction, plus this corrected angle, you need to recalculate all the bearings. These are the different steps. This will minimum take you 30 to 35 minutes. This particular entire procedure will take you minimum 30 to 35 minutes. So tell me, will they ask you this particular discussion in your GATE examination? No. This is not at all important for GATE. It is important only for your ESE mains examination. So please remember, the included angle method is mostly important for our ESE mains preparation. Okay, ESE mains preparation. But the theory behind this particular included angle method, that is important for us to do. So let us just summarize the different steps involved. Step number 1, calculate included angle. Step number 2, apply arithmetic checks, 2n minus 4 or 2n plus 4 depending upon your traverse. Next, apply the corrections to all included angles, right? And then what you do, starting from a line free from local attraction, recalculate the bearings of all lines. Okay? So this will take us a minimum 30 to 35 minutes. So they may not ask you this for your GATE examination. For your GATE examination point of view, we need to only remember the bearings method. That is more important for us. Yeah. Yes. So that's it. That is the discussion regarding the local attraction. Okay? Yes. Let us try a small problem here. Please try this. Previous year GATE question. Please try this. So we can use some figures to find the answers here. Let me see any responses. One answer I got is 151 degrees and 30 minutes. Let us see. Okay. So they are saying that there was a local attraction. There was a local attraction of minus 1.5 degrees suspected at A. With the magnetic bearing of line AB was 145 degrees. Calculate the true bearing of the line considering declination of 5 degrees east. So let us assume that this is the correct magnetic meridian. This is the correct magnetic meridian. Okay, right. And what is happening here? There is a local attraction due to which what happened? The needle got rotated by minus 1.5. What do you mean by minus 1.5 degree? It means that the needle has rotated in the anti-clockwise direction of how much? Of how much? 1.5 degree. So this is the actual meridian. That is the actual meridian. Okay. Right. Now, what is the bearing of the line AB? The bearing of the line AB is nothing but 145 degree. So let us assume that this is my line AB. Now tell me, where is the 145 degree measured? It is measured from the actual meridian in the field. So this is 145 degree measured from the actual meridian. If you want to know the correct magnetic bearing of the line, what should be the correct magnetic bearing? It should be measured with respect to the correct meridian. So tell me, what is the correct magnetic bearing of the line? It will be equal to 145 degrees minus 1.5 degree. That is equal to 143.5 degrees. So now, yes. The correct magnetic bearing is what? 143.5 degrees. Yes. So then, what is the true bearing? The true bearing is equal to magnetic bearing plus declination. Okay. So the correct magnetic bearing is what I will use. Plus or minus plus 5 degree. I get the answer as what? 148.5 degrees. So the correct magnetic bearing, the correct true bearing of the line is equal to what? 148.5 degrees. That's it. So that is our answer. Yes. So I hope you understand this. So we have used some figures to try and understand. Okay. So I told you, if it is plus x degree, rotation is on the clockwise direction. If it is minus x degree, rotation is over the anti-clockwise direction. We have used that concept here, and we have got the answer. So now, yes. So I've used some figures here. Right. That's it. So next time you get this particular question as plus or minus x degree, take that plus or minus x degree and add it. Take that plus or minus x degree and add it to the measured value. You'll get the correct value. So 145 degree plus minus 1.5 degree. I got the answer as 143.5 degree. That's it. Right. Now I got the correct magnetic bearing. To that you need to add declination. That's it. Okay. Yes. Now this was a gate question in 2005 or 2006. The same gate question asked in 2013. Okay. The same question they asked in 2014. This is the question they asked in 2014. I'm repeating this. It is the same question. Please read this and try and solve it. I'll give you 5 minutes. It's a slightly tricky question, so I'm going to give you 5 minutes. Please try it after that I start. Okay. Again, I'll say, if you are able to draw some figures, you should get the answer. You should be able to get the answer. You forget about the declination initially. So if you can see the last question that we did, I did not represent any declinations here in my figure. So declination need not be represented. So forget about the declination. The remaining things, see if you can draw it in a figure. If you are able to do so, you will be getting the answer. I'll give you 5 minutes starting from now. Please try it. Okay. This is my first line here, first station here, A. Since this point A was having local attraction, what we did, we took an observation towards a point B that was at the south 50-30 east. South 50-30 east. This is my point B. Okay, yes. What is the bearing that they are giving you? This is 50-30. And what is this? North 48-45 degree west. What is this? This is B, not B, this is B. What is the advantage of P? There is no local attraction. Right. So now you look at this. Okay. Practically what they have given. They have given us the data of forebearing of AP, right? Forebearing of AP and forebearing of PA. But forebearing of PA is nothing but what? It's nothing but backbearing of AP. Correct. Forebearing of AP is nothing but what? It's nothing but forebearing of PA is nothing but what? Backbearing of AP. So practically what they are giving us is they are giving us forebearing of AP and they are giving backbearing of AP. Now tell me which bearing is correct? Forebearing is correct or backbearing is correct? Tell me, forebearing of AP is correct or forebearing or backbearing of AP is correct? Tell me, which will be correct? The measured forebearing from A or the measured forebearing from P, which will be correct? Backbearing of AP is measured from P, right? Forebearing of AP is measured from A, so who will be correct? Why no response? Am I audible? Very good. Dinesh, am I audible? Was there a delay? Yes. Very good. Okay, so this is free from local attraction. This particular rating has no local attraction. Right, it has no local attraction. So if there is no local attraction, right, if this is the correct backbearing of the line, right, if there is no local attraction, can you calculate the correct forebearing of the line? Yes. You can calculate the correct forebearing of the line. So correct forebearing of the line, you know, measured forebearing is given to you. Take the difference, you get the error at A. Find the correction, apply the correction. That's it. Okay. So let us write down the data here. So what is south 50 30 is 180 minus 50 30, that is 129 degrees and 30 minutes. So now, yes. Now, right, what is the correct forebearing of PA? Correct forebearing of PA is nothing but correct back bearing of AP. Not the 48 degree. That will equal to how much? 360 minus 40 45. What is 360 minus 40? 320. 320 minus 8 is 320 minus 8 is 312. So 311 degrees and 15 minutes. Okay. So that is the correct back bearing of AP. So that is the correct back bearing of AP. What should be the correct forebearing of AP? Correct forebearing of AP will be equal to minus 1 degree. How much will I get? 131 degrees and 15 minutes. Yes. So you know the correct forebearing of AP and you know the measured forebearing of AP. So what is the error at A? What is the error at A? Measured value minus correct value. Measured value is 129 degrees 30 minutes minus correct value is 131 degrees and 15 minutes. Okay. Error at A is equal to 129 degrees 30 minutes. Right. Correct value at A is 131 degrees 15 minutes. So what is error? Measured value minus correct value will be minus how much? In 1 degree 45 minutes. Right now? Yes. If it is 1 degree 45 minutes from this, you'll get the answer. So what is the correction required at A? Plus 1 degree 45 minutes. Yes, that's the correction required. So the required correction for local direction A is plus 1 degree 45 minutes. Now what you're saying, like line AB was there, measured as north 48 degree 45 minutes east. So from A, there is another line here AP. There is another line here AB. And what is the bearing of this line? 80 degrees and 50 minutes. So they are asking you for the correct bearing of this line. Okay, so let us do that. What is the measured forebearing of AB? Degrees and 50 minutes. So they are asking you for the correct bearing of the line. Okay, so let us do that. What is the measured forebearing of AB? Okay, therefore corrected forebearing of AB degree 35 minutes. Corrected forebearing of AB is 82 degrees and 35 minutes. That's it. Okay. So now what is the declination given here? The declination given as what? 3 degrees. So then what is the true bearing? 3 degrees. So what is the true bearing? True bearing is equal to magnetic bearing plus or minus declination. So it is 82 degrees 35 minutes is plus 3 degrees 85 degrees and 35 minutes. Okay, that's it. Degrees and 35 minutes. Do we have an option? They are asking the answer in reduced bearings. What is this value in reduced bearings? Not 85 degrees and 35 minutes please. That's it. Okay. So the correct answer for this is option B. That's it. So option B is the correct answer. Yes or no? Did anybody get the answer as B? No, it's not C, it is B. Okay, that is the answer. Right, so is this clear or shall I repeat this once again? Yes, so I'll repeat, okay. So read the question. In Delhi, it's Praveen, good morning. I'm sorry, it's a little late. The PC was doing some update, I guess. It was a little late to start, okay. So anyway, let us start our today's discussion. Okay. So actually we almost completed our last discussion on compass. We discussed about local attraction. Today we are going to talk about the the final comparison between the two compasses that we have. Okay. So that is the last discussion of this particular syllabus. That is the comparison between the two compasses. So how many compasses do we have? We have actually two compasses. They are prismatic compass, as you can see here, and the second one is what we call it as, or we refer to as a surveying compass. Okay. So these are the two compasses that we have. We will try and discuss about both of them one by one. Okay. So I'll try and show you some small animations here. Okay. Those animations are not what is actually important for you. Right. That what is actually important for you is finally at the end of the day is the comparison between the two compasses. Okay. But for the sake of understanding the comparison, you need to know slightly what is the working, how the different parts looks like, and how they work. Okay. So a little bit idea is necessary for us to understand. So blind mugging up can be avoided. Right. Blind mugging up can be avoided. So let us see what are the things that we need to look into. Okay. So Let us talk about the first compass here. There is nothing but the prismatic compass. Okay, so the first compass that we have is a prismatic compass. So in our plan view, how does the prismatic compass look like? It looks something like this. It has a circular body. The body is generally made up of brass, right? Brass being a non-magnetic material, it is an advantage for us. Right, now in this plan view, when you look at the compass like this, can you see a magnetic needle? Yes or no? Can you see a magnetic needle here? Yes or no? In the plan view, when you look at the compass, will you be able to see any magnetic needle? The answer is no. We cannot see any magnetic needle because please understand, right? There is a freely suspended aluminum disc that is attached like this. Okay, so please remember, you cannot see the magnetic needle because the magnetic needle is kept below the freely suspended aluminum disc. It is kept where? Below the freely suspended aluminum disc. Whatever horizontal angle graduations we have, all the horizontal angle graduations are engraved on this body. And the type of needle that we use, please remember the name. It is a broad type needle. The type of needle I use is what we call it as a broad type needle. And similarly, whatever graduations we have, the horizontal angles, everything is graduated here on the aluminum disc. We have north, south, east, west systems like this. One more thing, please remember, we are following a whole circle bearing system in this particular prismatic compass. Okay, we follow whole circle bearing system. So the range of values will be from where to where? Obviously, the range of values will be from 0 to 360 degree. Obviously, the range of values will be from 0 to 360 degree. Now, the important question is, where is 0 degree marked? Where do you think the 0 degree of this particular compass is marked? Is it marked at the north, south, east, or west end? The correct answer is it is marked at the south end. So this is very important. So 0 degree of the compass is marked at the south end, 180 degrees at the north end, 90 degree at the west end, and 270 degree at the east end. So this is how graduations are marked up in my prismatic compass. Very important. Okay, 0 degree start at the south end, and the graduations are increasing in the clockwise direction. Right, and the graduations are increasing in clockwise direction. Similarly, if you look closely at all of the readings that I mentioned here, 0, 90, 180, all of those readings, if you look at that, you'll also realize that those graduations are inverted. The graduations, whatever we have, they are inverted graduations. Now, what these graduations are inverted, we will understand in the next few minutes. Okay, yes. Now, attached to the body, you can see that there are two veins here. Right, you can observe there are two veins attached to the body like this. The one at the south end is known as the side vein. The one at the north end is what we call as the object vein. What do we mean by side vein? What do you mean by side vein? See, please understand by side vein, the understanding is we are looking through this particular south end of the needle. By side vein means we are looking through this particular south end of the needle. Okay, the observer's eye will be at the side vein. Okay, the object vein is used to bisect the ranging rod in the field. Okay, the object vein is used to bisect the ranging rod in the field. So please understand, the observer's eye is at the side vein. The side vein is at the south end. Therefore, 0 degree starts at the south end. Wherever the observer's eye is present, okay, that is where 0 degree is. And we will rotate the body to bisect the ranging rod in the field in clockwise direction. So when I am bisecting a ranging rod in the field, we should always rotate the body in the clockwise direction. So that what happens, the graduations are also increasing in the clockwise direction. That's it. Now, as I told you, if there is a ranging rod kept in the field, to bisect this ranging rod R, what I need to do? First of all, I need to align the magnetic north-south direction. After that, rotate the body and bisect the ranging rod R. So how does that rotation take place? This is how the rotation takes place. So the point that you should understand from this is the body rotates, but the aluminum disc remains what? Freely suspended. The body will rotate, yes, the body will rotate, but what happens? The aluminum disc is going to remain what? Freely suspended. Yes or no? Yes. Okay, so this is the plan view. Now let us look at the compass in our elevation, cross-sectional view. So in the cross-section, it looks something like this. The yellow arrangement that you see here, that is the tripod arrangement. So this is basically ball and socket arrangement. Okay, the ball and socket arrangement, right? It's like just like this. Okay, so ball and socket arrangement like this, just like our shoulders and all. The ball and socket arrangement will help us make the needle horizontal. So basically, it will help me do leveling of the particular magnetic aluminum disc. Sorry, it helps me to do leveling of the aluminum disc. That's it. So suppose the aluminum disc will have a central tripod like this. We discussed this in the tip also, and this will be the freely suspended aluminum disc. Beneath the freely suspended aluminum disc, you can actually see the needle. This needle is what we call it as the broad type needle. Let us call this as the north end of the needle, and this as the south end of the needle. On the north end we have the object vein, please remember, and at the south end what we have the side vein. Yes or no? Why do we call it as side vein? Because observer's eye is at the side vein. Correct now? Yes. You can see one beautiful set of eyes here. That is the observer's eye. Okay. Now, when I need to bisect the ranging rod in the field, I will use my side vein, I will use my object vein, and I will bisect the ranging rod like this. I will use the side vein and object vein to bisect the ranging rod like this. So this process of bisecting the ranging rod in the field is what we call it as side vein. This process of bisecting the bisecting the ranging rod in the field is what we call it as side vein. So it's what we call it as sighting. So once sighting is completed, once the ranging rod is bisected, what we need to do? We need to look at the readings. We need to take the readings. So to take the reading, does the observer needs to come and look at the needle like this? The answer is no. The observer need not come and look at the needle because please understand, attached to the side vein, very important, we are having a right prism here. So attached to the side vein, you see, we have a prism. So that is a prism. Now whenever the observer looks through the prism, what will happen? We get a reflection of the aluminum disc. What we get? We get the reflection of the aluminum disc. Okay? Yes. So if you can look at the reflection of the aluminum disc, you can see what is the reading that we have. What is this process known as? This process is what we call it as the observation. So remember, the graduation on the aluminum disc is what inverted. So if you are supposed to get a reading here as 60 degree, that 60 degree will be marked in the inverted direction like this. This is how the 60 degree is marked. But when the observer looks at this, he gets to see the reflection. So in the reflection, how does it appear? It will appear direct. So if the reflected image, please listen, if the reflected image has to appear direct, how should be the graduations? The graduation should be inverted. Understand? How is ambulance written in the ambulance? Ambulance is written in the opposite direction. Yes or no? Yes. Why? The ambulance is written in the opposite direction so that any observer who's looking from the other side or looking to any driver who's going in front can look at the rear view mirror and read it as ambulance. Same concept. We want to read it directly, so the actual graduations are inverted. That's it. Okay. So this is how the plan and the elevation of the first compass will look like. Right. That is our prismatic compass. Now we'll move on to our second compass here. That is nothing but the Servius compass. So how does the Servius compass looks like in the plan? It looks like this. It has a circular body like this. Right. And please remember here, when you look in the plan view, you will never have any aluminum disc. There is no aluminum disc present. Okay. So you cannot see any aluminum disc present there. So whatever graduations we have, all those graduations are engraved directly on the body. Whatever graduations we are having, all those graduations are engraved directly on the body of the compass like this. In our prismatic compass, we followed the whole circle bearing system for WCB. So here, what is the bearing system you will follow? You will follow reduced bearings. Understand? Yes. So what is the range of values we can have in reduced bearings? It is from 0 to 90 degree. Okay. So where is 0 degree marked? You see, 0 degree is marked at the north and south end. Where is 90 degree marked? At the east and west end. But very carefully you observe, east and west are interchanged. So this is where the west is, this is where the east is. So be very careful. Right here, 0 degree is marked at the north and south, 90 degree at the east and west. Yes. But the problem is the east and west directions are interchanged. East and west directions are interchanged. Yes or no? Yes. Right. So that is how the body of the compass is going to look like. Right. Now attached to the south end, what we have the sight vane, just like before. Attached to the north end, what we have the object vane. Sight vane is where the observer's eye is. Object vane is where the slit to bisect the ranging rod is present. Yes or no? Yes. Now, right, when we look at it in the plan view, can you see the needle here? Yes. You can definitely see the needle here because there is no aluminum disc. Right. And the type of needle that we use is what we call it as an edge bar type needle. Please remember, okay. The type of needle that I use in my prismatic compass is broad type needle. The type of needle I use in my survey's compass is edge bar type needle. And how does it look like? It will look something like this. This is how the edge bar type needle is going to look like. So now, yes. Now you can see that it is marked N here, which means once the ranging rod is bisected in the field, wherever this north end points, I need to take the reading. Okay. Once the sight vane, object vane, everything is rotated, once the ranging rod in the field is bisected, what do you need to do? You need to look at where the north end of the needle is pointing. You need to look at where the north end of the needle is pointing, and you need to take the reading. That's it. So you can see like this. So when I am rotating the body here, please remember the body will rotate, the graduation will rotate, but the needle will remain freely suspended. Okay. The body with the graduations are rotating, but the magnetic needle will always align in the north-south direction. That's it. Okay. So in the elevation view, this is exactly like my previous compass. We have the option to attach the tripod. Pivot will be there. On top of the pivot, we have the broad type, edge bar type needle. Let us call this as the north and south end. Attached to the north end, we have the object vane. Attached to the south end, we have the sight vane like this. The observer will be looking through the sight vane. When he bisects the ranging rod like this, right? What is this process known as? Sight. Right. This process is known as sighting. Okay. As I told you, once the sighting is over, what the observer needs to do? He needs to come and look at where the north end of the needle is, pointing. To take the reading, the observer needs to come from here and he needs to look at where the north end of the needle is pointing. Okay. So this is what we call it as observation. Okay. Immediately after sighting the ranging rod, you need to look at where the north end of the needle is pointing, and that is pointed towards the graduation. So tell me, in our previous case, that is in my prismatic compass, do I need to do this sighting and observation separately? Did I need to do the sighting and observation separately? The answer is no. Right? It was not done separately. But here it is done separately because we don't have any prism. We don't have any prism. And also, if you remember, the graduations in the survey's compass are direct. 0 degree north and south, 90 degrees east and west. And if you recall, the graduations are recorded in the direct manner, which means I'm not using a prism to take the reading. Directly, I look at the compass and take the reading. So the sighting is one procedure. After that, we need to do the observations. That's it. Okay. So that is how the instrument looks like in the plan and in the elevation. This is how the elevation and plan view will look like. Let me slightly explain what the working of this particular instrument is. You'll understand why east and west are interchanged. Imagine this is the field condition that you're having. A line, AV is there. This is field condition. Okay, so in the field, north, south, east and west, everything is in the correct position. In the field, north, south, east, west, everything is in the correct position. Okay, this is my line AB. Let me say that this particular angle is theta. In my survey's compass, how should this angle be reported as? This angle should be reported as north 30 degrees. Correct? In reduced value, you should take it. Okay, so let us keep this field condition aside. That is a field condition. So what I need to do is to measure the horizontal angle or the bearing of the line AB. Right? You imagine this is point A. What I need to do is at the point A, I need to bring in my compass and keep it exactly at point A. So this is point A. Right? Enlarged view I'm showing north, south, east, west, everything is the same. I'll bring my needle. I'll bring my compass to the field. Right? What I need to do now? Center this particular compass exactly at my point A. Okay, so you can see the north-south direction on the needle, correct? Now, north-south direction on the needle. East-west direction on the needle are interchanged, correct? Now, east and west direction in your needle, in your compass are interchanged, right? Now, what I need to do is align this particular compass so that you see at the point A, when you are standing at A, the needle is aligned in the east-west direction, north-south direction. The needle is aligned in the north-south direction, right? So east and west in the field are in the correct position, but inside the compass they are interchanged. Okay, now yes. Let us see how the bisection process will take. I need to rotate the body and bisect the ranging rod. I need to rotate the body and bisect the ranging rod. Needle should align in the north-south direction only, no doubt here. And let us see how the bisection will look like. So I will slowly rotate the body like this and then bisect the ranging rod. Okay. So you see what am I doing here? I'm slowly bisecting the ranging rod to bisect the point B. Right? I'm slowly rotating the body. Everything rotates. I need to bisect the ranging rod B. So once this particular ranging rod B is bisected, the observer will look like this. This is known as the sighting. Now what I need to do to take reading, I should come and look at the north end of the needle. To take readings, what should I do? I should take readings at where the north end of the needle is pointing. As you can see, this is where the north end of the needle is pointing. Now tell me, what is this angle in the field? Look at this. This is 30 degree. Then the angle between north direction and the line AB is 30 degree means the angle between north direction and angle B is 30 degree means what will be the reading here? This reading will also be equal to 30 degree. But how will you read it? You will read it as measured from north 30 degrees towards the east. Measured from north 30 degree towards the east. So measured from north 30 degrees towards the east. So are you getting the same bearing of the line? Yes. Now tell me, what if the north and south, what if the east and west were not interchanged? If the east and west were not interchanged, instead of east here, you would have got west, this would be east. Now what will be the reading? Measured from north 30 degree to the west. That is wrong. So that is wrong. Okay, so why we have interchanged east and west? So that the quadrants and all we are getting correctly. The quadrants are obtained in the correct fashion. If the east and west were not interchanged, I would have read it something else. That is not correct. That is why east and west are interchanged here. Okay, now? Yes. I hope you have a little understanding of why east and west are interchanged. Not very important, but at least some of you may get it out. That is why I discussed about that. That's it. Now, as I told you in the beginning, we don't want to know how the animation works, how the figures looks like. We need to just summarize the comparison between the two compasses. That's it. So let us look at the different objects and let us compare the same objects in the two prismatic and Surveyor's compass. The first object is nothing but our needle. Okay, the first object is nothing but our needle. Okay, so what kind of needle I use in the prismatic compass? Anybody? Tell me what kind of needle I'm using in my prismatic compass? Right. Yes, very good. I use in the prismatic compass I use broad type needle, and the Surveyor's compass, what is the type of needle I use? I'll use the edge bar type needle. And what the edge bar type needle will do? It will act as an index. The edge bar type needle will act as an index for us. Okay. Yes. That means the point against which the reading is taken. Where is the scale in the two compass? In our prismatic compass, the scale is on the freely suspended aluminum disc. Yes or no? But in the Surveyor's compass, it is engraved on the body. There is no aluminum disc. So the graduation is engraved on the body, and the graduations will rotate with the body in the Surveyor's compass. But in prismatic compass, the needle will remain in the freely suspended state. Yes. Third one is our bearing. So what do you mean by bearing? The kind of bearing I use in my prismatic compass is WCB. That is a whole circle bearing system. But very importantly, where is east, west, north, and south? Right. So please remember, right? East, west, north, south, everything is correct. North, south, east, west. But where are the readings? 0 degree is at the south end, 90 degrees at the west end, 180 degree at the north end, 270 degree at the west east end. So this is a common, multiple choice question in our competitive examination. Where is the north end of the needle marked in the prismatic compass? Where is the north end of the needle marked? North end is marked at the, west end. Please remember that. The north end of the graduations are observed on the west end of the needle. Yes or no? Yes. Now, in the second compass, we used reduced bearing system. So the graduations will vary from 0 degree to 90 degree. Right? 0 degree is marked at the north and the south end, and 90 degree is marked at the east and west end. Under the east and west end, right? And the east and west are interchanged. So this is where east is. This is where west is. East and west are interchanged. Okay. Yes. Now, what about the graduations in my two compass? In prismatic compass, the graduations are inverted, and in the Surveyor's compass, the graduations are direct because there is no prism. Next one is sighting and observation. Tell me, in the prismatic compass, can I do it together? Yes or no? Yes. Yes. Very good. I can do that particular discussion together. Okay. So it is simultaneous. Sighting and observation is done simultaneously, but in the Surveyor's compass, it is not simultaneous, two separate processes. Okay. Yes. Now, the one last point that we need to discuss is regarding the tripod. So, in the case of our prismatic compass, I'll say tripod is not essential, but in the case of Surveyor's compass, tripod is essential. So, what do you mean by not essential and essential? What do you mean by not essential and essential? Please understand, not essential means even if it is not there, no problem. What do you mean by not essential? By not essential, the basic understanding is even if that particular tripod is not there, it is not an issue for us. We can work with the instrument. But essential means what? Without that particular tripod, Surveyor's compass cannot work. Okay. So, you just think about this. In our present day life, do you need smartphones? Yes or no? Yes, absolutely. Right. So we absolutely require our smartphones nowadays. There's so many advantages are there. Easy payment, easy navigation. You can find the details about whatever you want to know by using your smartphones. Yes. Right. So if you go and even if you think about this, you can even study a lot by using the smartphones and all. So if you go and tell your father and say, "Hey, father, I need a smartphone. I need to study. I need to attend the online lectures and all." Nowadays, fathers will think that okay, it is essential, so we'll provide. Okay. Back in our days, right? If you go and ask our ask our father for a smartphone, father will take chapel. Right. Nowadays, if you go and ask the father, "Father, I need iPhone to do studying," father will again take chapel. Because right, iPhone is not essential. A small Android or a very cheap phone will also be doing the same thing as an iPhone. If you are looking at the study point of view, yes or no? Yes. So even without an iPhone, your things will be okay. So the iPhone is not essential for doing the studying work and all. But in the case of Surveyor's compass, right, what is that requirement? It is essential. Why is this tripod essential in the case of our Surveyor's compass? Because sighting and observation is done separately. You need to first bisect the ranging rod. After that, you need to come and look like this. So if you are holding that instrument in your hand without tripod, if you come and look like this, the entire reading will be gone. Understand? That is the reason why it is essential for a Surveyor's compass. But if you are having a steady hand, you can keep the prismatic compass in your hand, bisect the ranging rod, and look at the prism. You will get the reading. Bisect the ranging rod and look at the prism. You will get the reading. So that is enough in the case of our Surveyor's compass. Prismatic compass. A steady hand is enough. If you have seen the movie Pirates of the Caribbean, right? If you have seen the movie Pirates of the Caribbean, you can see our hero in that movie, Jack Sparrow, we call it. He always carries a compass in his hand. To use that compass, he just use his hand. He'll not put a tripod on a ship, right? And do your centering, leveling, and all. That's not really possible. Okay. So that's it. That is the discussion regarding the comparison between the compasses. So remember, for your exam point of view, this comparison is sufficient. Right. Let us next discuss about the temporary adjustments of prismatic compass. We will use prismatic compass only because of whole circle bearings arrangement and also because of the fact that sighting and observations can be done simultaneously. For these two particular reasons, we are always going to use our prismatic compass only in our surveying machines. Right? That Surveyor's compass now it is a little bit difficult. East to west interchange, it's totally confusing for some people. So therefore, we generally avoid it. Okay. Yes. So what are temporary adjustments that you need to understand first up? Temporary adjustments means these are adjustments done at every setup, done at every instrument setup. These are adjustments done at every instrument setup. That is what we call it as temporary adjustments. Okay. So what are the different temporary adjustments? Right. The general order is going something like this. It is setting up. General order is something like this. Setting up, where you fix the instrument with the tripod. After that, you do centering. Centering means the center of the compass and the point on the ground should line the same vertical line. The center of the compass and the point on the ground should line the same vertical line. That is known as centering. And the third step is what we call it as leveling. So leveling means we are trying to make the aluminum disc freely suspended, and this can be done with respect to the ball and socket arrangement inside the tripod. Okay, so the tripod is having a ball and socket arrangement. With respect to that, you can do your leveling work. And the last step is you need to focus the prism for reading. Alright, different people will have different perspective of the eye. So every time each observer needs to focus the prism. Okay, these are the temporary adjustments that you need to do at every instrument setup. You set up the instrument, fix the instrument with the tripod, you do centering, leveling to focus the reading. But if you remember the last point that we discussed in our in our comparison, when I was talking about tripod, the prismatic compass, does it require a tripod? No, it is not essential. If it is there, okay, but it is not essential. Not essential, matlab, I don't have to do that particular setup. So we can directly go for centering, leveling, and focusing of the prism. Right. So these are the different temporary adjustments of your instrument. Okay, now yes. Now apart from temporary adjustment, there is also one more adjustment known as the permanent adjustment. Can anybody please tell me why we have to do permanent adjustment? Why we have to do permanent adjustment? Can anybody please tell me the answer for that? When will I do permanent adjustment? Can anybody give me the answer for that? If temporary adjustments are done at every instrument setup, when will I do the permanent adjustment? If there is any fundamental relations of the instrument are disturbed. So if any fundamental relations of the instrument are disturbed, that means, or in other words, if there are any instrumental errors, to eliminate them, I will do permanent adjustments. Okay. So when will I do permanent adjustment? If fundamental relations are disturbed. Second one, if instrumental errors are present. If instrumental errors are present. Okay, that's it. So that's it. That is a comparison between the two compasses that we have. Okay, I'm pretty sure that we have solved all the questions, right? All the major models of questions have been solved. I think we'll discuss about one more question regarding the multiple select questions. Okay, so let us look at the multiple select questions in this chapter, and this chapter will be over. Yes, so yeah, into the angle questions we done, 12th question done, 14th question. This 14th question you can do it yourself. This 14th question you can do it yourself. Okay, please practice that 14th question. I think I'm pretty sure that you'll be able to do it yourself. Okay, so this 14th question I'm leaving it for you. Okay, so that's done. Question number 15 also we have tried. Same question we have tried with figure as well as by using our equations. And 16th and 17th will do. So let us try and solve question number 16 and 17. Okay. So if you have the material with you, please proceed. Pretty simple question. So I hope you are able to get the answer for that. Let me the answer for question number 16. Yes. So yeah, what is the answer you're getting? I think very simple. Now everybody getting yes, 70 degrees is the answer. Okay. Right. So setting up the notes. So we can just draw some figures here. You should get the answers. And we did not frame any relations for the deflection angles. So how is the line going? The line AB is going from north 60 degree east, north 60 degree east, and the next line is south 50 degree east. So this is A, B, C. So this angle is given to me as 60 degree. this angle is known as 50 degree. Okay. So to measure the deflection angle, what is the step I need to do? Extend the line forward. So if this is 60 degree here, what will be this? This is also 60 degree. And what is the amount by which I deflect it forward? The amount by which I deflect is 180 degree minus of 60 degree plus 50 degree. What is the answer? The answer is equal to 70 degree. I think in your booklet, the answer would be given as option B. Sorry, is given as option C. That is not correct. Okay. The correct answer is option B only. That is 70 degree. Look at this question and tell me which are the correct statements. Identify the correct statements with respect to a compass. Identify the correct statements with respect to a compass. Dip is an angle measured in the vertical plane. Yes or no? Absolutely yes. Vertical angle, the needle makes it the horizontal. That is dip. Compass are graduated in centesimal system. That means 400 grades gone. Yes or no? No. They are graduated in sexagesimal system. 0 to 360 degree. The degree definition comes in sexagesimal system. Drip is treated as a natural source of power. That is also wrong. Dip should be treated as an instrumental source of power. Right? It should be treated as an instrumental source of power. So why is that an instrumental source of power? Because as I told you, if you don't keep the sliding counterweight, okay, whenever we are making the needle, and if you forget to keep the sliding counterweight, that is when we will be having this particular error. Okay, that is when we will be having this particular dip. So sliding counterweight is not there. That's why the dip is done. If you don't keep it, then it is 100% sure that you will be having dip. So it is not about that needle is there. Is that dip is there or not? While constructing itself, did I keep that particular element is there or not? That is the important question. Yeah? Yes. And the last option is isogonic lines are lines joining points of same or equal dip. Dip is associated with isogonic lines. No, this statement is also false. So dip is associated with what? Instead of dip, it should have been equal declination. Dip is associated with the isoclinic or aclinic lines. So the only correct statement is option A. Yeah, that's it. So I think that is the complete discussion of our compass survey. That's it. Right. So we have finished the chapter successfully. Okay. And we have solved some numericals also. I hope you have tried those numericals. The remaining numericals. No, I'm pretty sure that you might have solved this. That's it. So now we will move on to our next chapter here. What is that?